activities and start toward the end of the mine life and may continue even after the reservoir are exhausted till the mine area is restored to an acceptance levels. For example, physical and geotechnical measures. In this, it include decommissioning of infrastructure, peat and white management, and closing entries for the public safety. In environmental and ecological measures, now moving to the next slide. In methodology, this is the quality study and analysis on the global practices in mine closure and post-mining transition. The research methodology includes quality review. In this, we evaluate peer-reviewed literature, government documents, policy reports, and international guidelines to the trends and challenges, best practices of mine closure. In comparative and policy analysis, we compared the legal framework, policy, instrument, and regulatory reform in 6 mining main regions, which are Australia, Canada, India, Brazil, South Africa, and Mongolia, to allow a better comparison of convergence and divergence of the closure activities strategies. Synthesizing of case study. Move beyond the theory, we integrated real world examples from the different countries to illustrate the best practices of technical methodology with environmental transition within the socio-economic framework. In thematic content analysis, we categorize the massive data into specific key themes, including cost internalizations, hydraulic management, geomorphic restoration, AMD mitigation, and post-mining land use framework. Now moving to the result and discussions. The primary goal of this research paper is to inform the researchers and policymakers about the transformative changes in the industry by synthesizing global policies, development, and technical solutions. This specific objective include global policy review, comparative analysis, technical methodology review, socio-economic framework, post-mining land uses. In global policy review, this is the early form of the closure, categorized by limited planning and statutory requirement, result in environmental and social liability, increase in abundant mines, contaminated land, and socio-economic deprived communities led to the rethink about the closure as an important transition phase requiring regulatory, technical, and community engagement. There are 3 key drivers of the policy evaluation. First one is the environmental awareness. Recognition of long-term impact on the land, water, biodiversity due to the mining has ensured to rise in the call for the making regulations. In socio-economic imperative, serious social and economic closure outcomes such as unemployment, community deteriorations. This also enhanced for the making global policy for mine closure planning. In climate change events like extreme drought, floods are also ensured to make a policy for risk assessment of mine. This also enhanced to integrate the risk assessment in the mine closure planning. In comparative analysis, this is the comparative analysis of the legal framework and regulatory reform of 5 major mining regions. First one is Australia and Canada. They are leading in the integrated planning because they have evolved the closure framework into the project approvals early in the project mine life cycles. In India has also progressively taken steps through the amendments in the mine concession rule and mineral conservation and development rules 1988. Latest guideline by Ministry of Coal for 2025 for.
Please conclude within 1 minute.
Yes, sir. These are the timeline of the evolution of mine closure planning in India. In pre-2003 abandonment phase, mines were often closed non-scientifically or abandoned without structural decommissioning, leading to the significant ecological degradation. 2003, the first amendment to the Mine Concession Rule 1960 and Mineral Conservation and Development Rule 1988. Conclusion and recommendation of this paper: mine closure and transition are multi-decadal challenges situated at a juncture of technical, environmental, and social system. The main goal of our paper is to inform researcher and policymaker to. At last, I would recommend that internalization of environmental and social costs into the mine closure planning and approval processes, considering the utilization of adaptive evidence-based technical methodologies to ensure physical and chemical stability, categorize the deployment of multi-skilled integrated system for post-mining use selection and performance evaluation. Thank you. These are the references of my presentation.
So thank you. I think you are Duman Lal.
Yes, sir.
Hello. Thank you, Dr. Duman Lal. And I now request second presenter, Dr. Manoj Bagde from Simpar CSR, to present his paper, Investigation into Backfill Failure Using Dynamic Numerical Modeling. So you're welcome, sir, and start.
नहीं ये नहीं है. So thank you, Chair, for inviting me. So my topic is investigation into backfill failure by dynamic numerical modeling. This is related to metal mining and cemented rock fill. So in a brief introduction, so backfill failure and dilution is degradation of economical ore due to unwanted rock, failed backfill and low-grade ore getting diluted into the economical ore. So it reduces probability of mining operation and it is unwarranted at every stage of the mine. It issues the backfill failure, data control issues, safety and sometimes even stope is lost. Such cases are happened already. Even stope is lost, economic ore is lost. So it adds to the cost of mining, hauling, transportation, milling and processing. And since it adds to the cost of production and it's unwarranted. It is expected that all stages of mining operation and acceptable to certain extent. It's up to depending upon mining to mining, ore to ore, and maybe up to 3% is expected acceptable. So numerous mining and rock mechanics parameters including backfill and ore dilution. So in this case, dynamic numerical modeling studies the problem of backfill failure and ore dilution are very adjacent to stope blasting and various factors affecting failure dilution and possible control measures to eliminate or minimize is discussed here. So parameters affecting failure dilutions are mining related induced stress regime, rock mass strain parameters, geological and structural characteristics of the deposit, stoping methods and sequence implied like primary and secondary stope, stoping method, delayed backfilling, and type of backfill material and stain etc. So backfill is a filling up an excavation with waste and suitable material. You can see here, and here in stope 1 extracted and then backfill, and then you can see when stope 2 is extracted, this backfill failure is causing ore dilution coming into the stope 2. So stable fill, here you can see two cases, stable fill and one failed fill. So it all depends on fill in place. You need a stope dimension, geometry, backfill exposed dimension, how much height is there, then extension sequence, initial stage developed, backfill distribution, if it is CRA per page and how it is distributed into the stope, fill strength, cement content, how much percentage is used, load induced on backfill, dynamic strength, consideration are given or not, and fill without fill. So stability of mine openings, increase recovery, and helps in waste management and reduce surface subsidence. So these are the purpose of backfilling. So I will not go much in detail, like wall stability and regional support, increase extraction and dilution control. Sometimes in cut and fill working, floor and pillar recovery reduces mining cost, protect mine workings, reduce rock bed damage, subsidence control, environmental protection, and in some way it helps in fire control and improved ventilation. So here, stopping sequence and loading waveform, some scientific background is given. So loading waveform effect on normalized fatigue strain you can find in scale is more. So in some sequence, mining sequence also, such condition is developed, like here. You can see it is scale, both the sides you have extracting stope and one is backfill, so some type of scare type of waveform is developed. Now here if it is continuous mining, here some types of ram type condition is developed. So we'll discuss this in the case of dynamic numerical modeling. So using three waveforms like sine, ramp and scare were used and simulated, and with 5 Hz frequency and 0.1 megapascal blasting load, total duration of 4 seconds simulated. So stope dimension was around 15 to 10 meter and depth around 800 meters. So the in-situ stress was sigma h is 1.8 times sigma v, and which represents the Candian sill complex mining conditions. So mostly cemented rock fill material was used, and first model is run in static and failure observed. Then boundaries are freed and coiled boundaries are invoked to absorb energy, and also 5% of natural relic damping for the geotechnical material were used. So dynamic numerical modeling in flag. So like here, in static condition, this is a stope 1 extracted and backfill, and this stope 1 extracted to the adjacent this. So you will find around failure yielding of 1 centimeter. So when we are using different waveforms like sine, scare and ram, you can here see scare is more damaging. So backfill failure in static was 1 centimeter, and when you compare with ram, dynamic loading condition and sine and scare, so in ram it was a 4 centimeter, sine 5 centimeter, and scare it was 7.5 centimeter. So ram waveform is more or all uniform in nature, while scare waveform found to be complex one and found more damaging. So scare waveform conditions resemble similar to secondary type stopping, while primary stopping resembles ram. So this is some of the review backfill failure in dynamic. This is in dynamic conditions. This is a cavity only survey, and fill failure was observed up to 0.5 meter. It is in dynamic condition. This is in static. How yielding took place in the backfill column. And these are again the review. Different Clark and Pakalnish has given a different conditions and how much failure is taking place. So measures to control backfill failure, importance of tight filling. We can see here two conditions. Here 0.5 meter gap is left, and here it is filled. So how this is stress zone is reducing. So importance of tight filling, stress considered zone is screen नहीं आ रहा है क्या? So in this slide, actually, I am trying to show the tight backfilling, how it is important. It can help into rock burst, reduce chance of reducing rock burst, preventing roof, adjacent backfill failure and dilution, and design of backfill stain act as a primary support system post extraction upward. So to avoid backfill failure while blasting adjacent stope, subsequent ore dilution with backfill material, consideration of dynamic strength of backfill should be given. So take care of dynamic loading. So some figures are given here, how importance of tight filling. So you can see here high performance formatted tailing very close to the roof. So here we can prevent the failure, and these are the common tailings pulp close to roof. Okay, it's very difficult to fill completely 100%. So some few methods are there now, fill back close to the face and good hanging wall contact using fill back. So I will come to conclusions. So backfill ore dilution is the contamination of economical ore with unwanted material, including adjacent backfill during the mining operation. It has a direct influence on cost of the mining operation and then profitability. Planned dilution could be taken care of during initial design itself. Unplanned dilution is governed by the mining and rock making parameters like stope geometry, adjacent stope blasting to backfill column, and strength of backfill etc. The various factors governing backfill failure or dilution and possible measures towards its reduction and control are discussed. So consideration of the dynamic strength while designing backfill material in initial stage of the mine planning is very much wanted. Further, experimental along with the instrumentation monitoring in tandem with the numerical modeling strategy will help to develop the site-specific best models for quantification of backfill failure, dilution, and its prevention. The efforts are needed in this direction for the survival and sustainability of the underground hard rock mining, the world over, and particularly in developing countries like us through the multidisciplinary approach, applied research. So these are some acknowledgements. This work was carried out at McGill under Hanimitri, Professor Hanimitri. So I thankfully acknowledge Director Shia Simper and ISM committee to 26 organizing committee. Thank you very much.
So, Dr. Bagade, you talk about backfill material,
Yes, sir.
isn't it? Have you done any case study to find out what is the present status and which material is used for backfilling and what new advancement can be
This is
made?
in this study we have used cemented rock fill particularly, but now in general mines, paste fill, I have visited some mines, 2-3 mines, so they are doing paste fill.
Cement backfill means you are mixing sand?
No, paste fill is tailings and all they will use, and they have
not talking about paste fill. Presently we have
cemented rock fill, they will use the waste rock and they will add some 5 to 10% cement into that, around 10 mm granular type rock.
Waste rock you are cement. Mixing with sand and mixing with cement.
Not necessarily sand, only cement.
Only cement and mixing.
So homogeneity is not that achieved.
Okay.
But still in you can use a waste rock. So environmental point of view they are doing in development.
So then have you tried with new paste fill material and compare with that one?
Paste fill sir is totally different. Actually this is very costly affair. Like 150 crores only the plant cost and something like that. Like HZL or Vedanta is doing. But to save the cost and all those things, sometimes this is CRF, cemented rock fill is very good approach. Where rock is very competent, like hang wall, footwall is very competent enough to take care of that.
Thank you. Any question from audience? We can have one question. I think no question is there. So okay.
Thank you very much, sir.
Thank you, Dr. Bagade.
Thank you, sir.
Now I request next presenter, Surendra Prasad Singh, to deliberate his, to present his paper, Digital Initiative in Open Cast Mines, a very vital, I think, subject. Meanwhile, I think some dignitaries come from DGMS. I think... Okay. So is Dr. Surendra Prasad Singh is present here? Okay. So we'll move with the next presentation. Any presenter, Subodh Kumbalkar or Chandrayani Prasad Verma or Ravindra Kumar Sharma, so any one of the author who will deliberate on technical evaluation and support design for underground development working in case development working and Indian case study. Please, you can start.
Good morning, respected chairmen, chairpersons, honorable judges, authors and delegates and participants. This is Subodh Kumbhakar presenting a case study of high-speed shaft sinking developments at Balaghat mines. In coming 10 minutes, I will be giving few minutes about the introduction of that mine site. We will come to the problem statements, then the method approach that we have taken to deal with, and finally we will go to the recommendations and support design, and ultimately we will give the conclusions. So, as you know, Balaghat mine is deep and mature underground manganese mine in central India with increasing depth, experience higher in situ extraction and more complex ground conditions. To meet the deeper production requirements, a new high-speed shaft was decided having 7.5 meter of diameter was planned beyond 750 meters. A large loading chamber near this critical area was directly controls the ore handling and production. The host rock mainly consisting sericite schist, quartzite schist, some manganese bands are there. So these are the problem statement. Mainly we'll have to deal the major challenges development of large size loading chamber which is very close to the shaft, and initially the chamber was planned at 24th level due to severe and continuous water ingress concerning the safety hazards and operational challenges. That's we have mine management decided to relocate it to the 23rd level in hang wall. Whether more poor rock quality was there. Although because of the fair roof quality, conventional full excavation was unsafe. Therefore, the optimized excavation and sequence of the support were essential for ensure the stability. The methodology we have used coupling using empirical approach, and that is to validate the numerical modeling from FLAG 3D. A detailed geotechnical and investigation were carried out at the joining in shafts. Critical unsupported span and stand-up time when calculated, rock load and rock factor of safety were evaluated, and ultimately the support design recommendations have given. So these are the few peaks of at inset at 20 to 22nd level. To address this issue, detailed geological and geotechnical investigation carried out around the shafts and nearby intervals. A stage excavation strategy was accordingly. Finally, the FLAG 3D was performed to analyze the stage redistribution and yielding behavior of rock and factor of the safety. And borehole 74 was critically analyzed to main subsurface, and along with the spiral relation, the high-speed shaft to the ore body or in depth variations. You can see the vertical sections of the logging details with respect to the boreholes at the site. So these are the empirical approach. We have calculated the ESR unsupported span considering ESR value 1.6, which gives an Q value ranges from 1.3 to 2.8, which gives an span of 3.6 to 4.9 meter. RMR based assessment indicates unsupported span that is 3.6 to 4 meter and a standard of time up to 3 to 4 meters, 3 to 4 days, I guess, sorry. The empirical Q system that I have discussed in earlier slides, the equivalent dimension for the excavation was critically using the maximum span and ESR value assessment support demanding poor to fair rock mass conditions. And Q system chart indicates that the unsupported span approximately 4 meter and systematic rock bolt combining with shotcreting and gut bolting were essential. In some places where joint fracture rock mass were found, shotcreting up to depth thickness of 50 mm along with closely spaced rock bolts were recommended. So these are in this table we have given 3 developments with the dimensions and respective support designs at different sites. In all cases, the factor of safety considered greater than 2 or similar to 2 for long-term stability. Side bolts in second roadways, that is the dimension of 2.4 to 4 meter up to 3 meter of the shaft, and beyond the 3 meter the dimension changes to 2.5. The bolt length were 2 meters and a grid of 1 by 1 meters. The side bolts be provided at 1 meter interval, including shotcreting of 50 mm should be laid for the wire mesh. And loading chambers, the dimension 13.5, 9 bolts and 8 bolts for the road passage roadways, 8 and 9 bolts of 3 meter having grid of 0.8 by 0.8. So here is a schematic view of a support pattern at loading chamber that I have discussed in earlier slides. 9 bolts of 3 meter long having grid of 0.8 by 0.8, which eventually gives the factor of safety of more than 2 and sustaining rock load 9.8 ton per meter square. So these are the numerical modeling done to assess the yielding zone at roadways, second belt roadways, and these are the excavation sequence. We recommended top to bottom excavation with limited span that has given at unsupported span, that is 4 meter by 3.6. And these are the conclusions. This study investigate the large underground excavation associated in deep high speed shaft can be deployed, which is in poor to fair rock mass conditions, though systematic and integrated approach. The empirical analysis of RMR and Q effectively permisses unsupported span and stand-up time highlighted necessity to stages excavations. And the loading chamber was successfully excavated and supported and validated through numerical modeling and for the adapted design and methodology or confirming its applicability to a similar kind of mine. This is all from my side. Thank you. Thank you for the patient sharing.
Hello. Thank you, Dr. Kumbarkar. I have one question. How far away was this loading chamber from a shaft? And what was the support system in the inset and the, you can say, level which is connecting to chamber, loading chamber?
Lots of developments were being there, sir. Pump sites and other.
No, my first question is how far away it was from shaft?
I'll have to look for the whole paper, sir. It was, as far as I guess, 7 to 10 meters.
No, not necessary to say in meters. What I wanted to say, whether it was within the shaft pillar or outside the shaft pillar. That is my question.
It was within the shaft pillar, sir.
You are sure? And second thing is that what was the support system which was there in level, which was connecting to that loading chamber? And what was this support system in the loading chamber?
Mm-hmm.
Is it the same which was in the level or not?
It was same, sir, particularly same. The main problem was having water ingress and poorer rock quality at the hanging wall. That's why you have used 8 meters, 9 roof bolts of 3 meters. Whether we have used in South 8 roof bolts of 9 meters.
Water enrichment was not there for this loading chamber development. It was already plugged out. Okay. Thank you.
Thank you for that.
Yes.
Dr. Kumbhakar, I have two questions from your slide. First, you have discussed about roof characterization. Can you tell me what you mean by roof characterization?
So we have done RMR and Q for characterizing the roof for poor to fair. It is the class that we have given from the table of RMR.
Which RMR system? Which RMR?
Benavasky's RMR systems I have given, sir.
What is the basic difference between Benavasky RMR and Q system?
So Benavasky RMR is having 5 parameters, and Q system is the function of jointed rock mass and SRF and ESR, sir.
In Q system, they have not considered about the joints.
No, sir. In joints, in Q system, joints parameters are there.
And in Benavasky RMR?
It also there, sir. We have used CMRI RMR for this also.
Okay, thank you.
You're welcome.
Small correction. CMI RMR is not applicable to this mine because this comes under a metal mine.
Okay.
And this is a hard rock.
Okay.
That is basic rock mass classification.
That is given.
And coal measure rock is something different. So that is not CMRI.
That we cannot use that.
So
thank you.
Thank you.
Welcome.
Any question from audience? Okay. So, so I request, thank you very much, and presenter. And the next presenter to please present his paper, Evaluation of Fly Ash as a Partial Binder Substitute for Cement Paste Fill. Yes. Your name, please?
Evaluation fly ash.
Okay, thank you.
What's your name? Ganesh. Full person? Your name? 47. This one. Prashant Singh. No, Ganesh Reddy. Ganesh Reddy. Okay. Thank you. So let's start. So good morning everyone. This is Ganesh Reddy from Technical Officer CSR Simfor. Today going to present a paper on evaluation of fly ash as a partial binder substitute for cemented paste fill and underground metal mines. So the major contents is go for introduction, then objective of the study, then followed by methodology and our elaborate experiments and conclusions. Sorry, what is this here? Yeah, okay. Here we can see that there is a huge demand for extraction of minerals. At the same time, like parallelly we'll have to backfill that. So here, like backfilling technology is being implemented worldwide and underground metal mines. So it enables water-free backfilling and improved ground quality. The use of cemented paste fill is essential for self-supporting fill during secondary failure extraction. And here we are using the major binder as OPC. That OPC is like a bit cost-effective. It's taking 75% of total backfilling expenses, so we are replacing that with alternative binders like fly ash. So is it okay? It's okay. Yeah, it's okay. Okay. Yeah, here we have our main objectives of this study. Here we can see that to evaluate the effect of ordinary Portland cement for strength development and to develop a mathematical model to predict strength requirements for secondary pillar extraction and to investigate the feasibility study whether it is feasible or not for replacing OPC with fly ash. And the next one is we'll have to check for short-term and long-term strength characteristics for paste fill material. The next one is to determine an optimal paste mix design to satisfy strength requirements. So here is the methodology, like the materials we have taken from Radisson Zinc Limited, the mill tailings we have collected from HJDL, then fly ash also collected from the captive mines of HJDL, and we are taking 8% OPC here with 43 grade, and water to solid 77 and 23 by weight percentage we are taking, and we are replacing from 8% of OPC to 4% with fly ash as a binder replacement. And we can see the physical, chemical and geotechnical properties for this method. Here we can have a laboratory study for physical. First one going with physical and setting parameters. Here we can see a specific gravity and bulk density and porosity as physical parameters. We can see male tilings is gradual increase. The reason is like we can see 2.9 and 1.4, and we are seeing a lesser porosity that shows that its compactness. So the same thing, like it's getting decreases in fly ash. The reason, like these are finer particles having more pore volume, like pore size, and also include surface area also. Here you can see PSD studies for mill tiling and fly ash, and VCAT apparatus used for setting studies. We can see for initial and final setting times is gradually decreasing when we are going into the proportions from 1% to the 4% when we are replacing that OPC with fly ash. It is not much decrease, like it's a very slight decrease. Still we can use lesser quantities by at around 28 curing days. So here we can see the sizes, median size and grain size. And so look at here. Okay. So here we have coefficient of uniformity for well-graded materials. Always it's greater than 6. So here we have 10.8 and 7.9 for mill tailings and fly ash. So that means we can use these two materials for our experiment. And the mostly, look at here, uniform of curvature CC, its value depends on 1 to 3. So we have a slightly decrease in fly ash. So still we can consider this. And but in the case of mill tailings, it's okay. It's more than 1, so we can use it. And the next one is chemical and morphological study. We have done XRF and SEM analysis. So the major element, the major composition, chemical composition, we can say silica and aluminum and calcium in mill tailings. And it's like calcium by silica ratio, it's like HI index, we can get 0.6. Then second one, we can get 0.2. The decrease in HI index is the ratio is getting decreased. So here you can see that the mill tailings is having a angular particle in size, which is having sharp edges. And we can this spherical some structure for fly ash. See, we can, if you can coat this material with some of the additives, then you will observe some intrinsic structure like calcium aluminum silicate type structure. So we are not going into that. We are stopped at initial stages. This is another laboratory technique, that is geotechnical properties. It is for we will use for seed test. Like, see here you can see UCS and triaxial test, which has been carried in our rock mechanics laboratories. And you can see whatever proportions we have taken from A1 to A5. So here you can see the UCS and curing time, a graph you can see here. We have cylindrical modes with different curing times we have prepared in the lab, and we have been tested here. And we have analytical approach. And here we have taken a Mitchell et al. A model for calculating a C and UCS, which has been used for our strength requirement. And here we have a multiple regression analysis for UCS model. We can see the regression model here. And the source of components here, we have taken intercept in percentage of fly ash and days, and when we are interacting both of them. And here the main estimate, we can
Mr.
take the
Reddy,
coefficients.
please conclude.
Yeah, we can take the coefficients as an estimate, then we can calculate standard error out of it. The standard error being used at t value, t test value. When the t test value is greater than 0.005, then we will, the probability of, like we can see here the significance, like if it is 0, then if it is more probable than like if it is 0.001, and we can have 0.01 also. So these are all, like you can see for percentage of fly ash and days and then interaction. You can see the residuals, normal residuals and residual versus predicted UCS and predicted versus UCS. So it can tell the stability. And here we have conclusions. So what we have explained so far, like physical and setting time, geotechnical, it gives you all. Thank you.
Next participant.
Yes. Any question from audience? Yes, please.
Yes, sir.
There is sharp reduction in UCS.
Yes,
You
sir.
have seen that graph, no?
Yes, sir.
You only showed that graph. Very sharp. So
Yes,
that
sir.
means fly ash is not
Sir,
working as the binder.
No, actually, like
It is replacing miltailing. It is not replacing the cement.
fly ash, like proportions we can take, sir, with curing time. So at less curing time, it will be like, it is giving negative results. When we are increasing curing time, then there will be a slight positive results we can observe.
Curing time you have taken up to 56 days.
56 days, but we don't need to go for 56, sir. 28 days is good enough for that.
But in 28 days also there is sharp reduction in this usage. Something around from 2 MPa it has come down to about 1 MPa. So you can see the graph, no? You only have shown the graph.
Yeah.
So I think why fly ash is not acting as a binder, that need to be studied.
Okay, sir. Thank you.
Have you used any other binder for increasing the strength of this material?
So we are using silica.
Fly ash is not a binder. It's not a binding material.
Yeah, we are using mill tailings and
Mill tailing is also not a binder.
some.
Okay. Any other question? So thank you very much, and we request the next presenter to yes, thanks. And next presenter will present his paper, Stability Assessment of Underground Structures During Extraction of Thick Seam Using Continuous Mining Technology, a case study. Very interesting topic. I hope presenter is ready. 134, sorry. 134, sorry. Okay, just sorry. Assessment of cognitive performing among machine operations in underground mines. Yes, you can. So who is the person? Person is Ajay Kumar Biswas Samanta and Ashish Bhattacharya ji. Ajas AK. Is he present? Please come.
So, good morning all. I am Ajas AK, a research scholar from IIT Kharagpur, and my...
Please keep some space. Yes, so that it's very clear.
So, my topic is assessment of cognitive performance among machine operators in underground mines, a prospect to manage an aging workforce for safe operations. So the concept of cognitive performance encompasses domains of perception and sensory process, executive function, and cognitive control. The cognitive performance is measured in terms of vigilance, in operations such as machine operations that requires sustained attention. Cognitive performance is measured in terms of vigilance, and vigilance is referred to as an ability to sustain attention to a task for a period of time. And cognitive decline, which negatively impacts operators involved in machine operations, especially in underground mines. And the objective of our study was to assess cognitive performance and its relationship with age among machine operators in underground mines. And this is the methodology where we used machine operators which were operating side discharge loader machine in underground coal mines, and the mines were situated in eastern regions of India. The study was approved by the Institutional Ethics Committee of IIT Kharagpur. The evaluation of cognitive performance of operators was performed by a device called PVT-192, and this is the device which is regarded as one of the objective measure of cognitive performance or vigilance in variety of experimental settings. It is basically a reaction time measurement device. As you can see, the right side portion shows the machine which is having a topmost. Sir, yes, sir. I don't have that pointer or something else. So this is the device we are using. This is the top portion. The top portion where we have the visual stimulus display, and this is the blue portion. The blue portion is the equipment main display, and we have two buttons. One is selection button and the other is the reaction button. And the reaction time is measured when a LED display will be shown here. Then the operator or the subject will be necessary to press the buttons to give the reaction. So the participants use their dominant thumb to give the reaction upon receiving the visual stimulus. So this is the experimentation part where the operators were given the advice to maintain their attention and provide a response upon observing the visual stimulus, and the experiment. And the experiment is for 10 minutes, and during this period you will get a visual stimulus randomly appear at a variable interval of 2 to 10 seconds. And the device measures reaction time which the operators incurred during their experimentation. So this is the pictorial representation of the experiment, and here the subject start the experiment by pressing the start button, and the stimulus, a random stimulus appears. Then the subject gives the reaction by clicking the button. Then the whole process, then the stimulus disappears and it appears again at a random period, and the whole process continue for a period of 10 minutes. Then this is the result. The first, the black table represents the independent variable we have considered, which is age, which is having a mean of 42.38 years, and we have divided the participants into 4 age groups. First group ranging from 21 to 30 years, which is having a percentage of 4.9. Then the second group is from 31 to 40 years, which is having 40.9%. Then third group, 41 to 50, 32.8%. 51 to 60, the fourth group, with 21.3%. And the right side table shows the outcome measure, which is the reaction time, which is having a range from 22.4 to 224.89 milliseconds to 530.98 milliseconds. And these are the different percentiles we encountered. This is the ANOVA test we carried out. Then we had a F statistics of 8.02, and which is having a significance level which is less than 0.001. This is the graph of variation of mean reaction time that encountered by the operators while experimentation, and we have we can see a gradual increase across each groups, and the individual group averages are 316.79 for the first group. Second group is having 369.27 milliseconds. Third group 403.07 milliseconds, and last group 473.26. So here we can see the last group across 3 to 4. We are having a large jump of the reaction time, which is roughly of 70 milliseconds. This is the conclusion, and here we have an increasing trend, as I have already shown. And the similar studies have shown that older age adults encountered a large reaction time compared to younger subjects. And this needs a redesigning of workplace to suit the age and associated physiological and cognitive changes, which is necessary to improve the workers' productivity and safety and health. And some of the recommendations are restricting the night work for older workers which are above 50 years, and transferring the older workers from rotating shift work to daytime work, then reducing working hours and providing sufficient resting periods. Then combined use of digitization of the workplace with collaborative technologies to develop a senior enabled working environment. Then the technological use of virtual reality and augmented reality for ergonomic simulations and assessments. Then finally, integration of older workers' knowledge with collaborative technologies such as collaborative robots and wearable support devices to enhance productivity and safety of workers. Thank you.
Thank you very much. Now, what was your sample sample size for this survey?
For this study, it is 61 side discharge loader operators.
Have you done this study there at a workplace or on the surface or somewhere?
Means this study we have done in workplace at the working phase, as well as the data I have shown is at the end of the work. That is at the surface itself.
Okay. Any question from audience? Yes.
This is a good study, but with regard to whatever the group you have selected, within the group, what is the minimum and maximum reaction time or response time?
I have shown it's from 224 milliseconds to 530 milliseconds. It is the range.
That is the range,
yes,
but
sir.
within that one, skew may be there towards the minimum side, or skew may be there for the maximum side. But I am asking this thing because with respect to age, what happens sometimes, if you target the particular kind of persons with having the distraction kind of thing, then there may be a difference. Okay, whatever the study you have suggested is okay, but if the distractions are more at the workplace, naturally your time will increase, irrespective of the age. Okay, so that is the one parameter you can consider. Okay.
Yes.
Okay,
But
good study.
Sir, we have carried this experiment at the surface itself. So the distraction, what you have said, is not coming into the picture.
Okay. Thank you. Any more questions? Oh, thanks.
Okay.
And
Thank you, sir.
now we request the next presenter to present his paper, Stability Assessment of Underground Structures During Extraction of Thick Seam Using Continuous Miner Technology. Any presenter who is present here? Tamil Prasad? Yeah. Okay. Please start.
So, good morning, one and all present here. Myself, Tamil Prashant M., PhD scholar from NIT Rourkela.
So today I am going to present my topic, stability assessment of underground structures during extraction of thick seam using continuous miner, a case study. So these are all the contents today I am going to discuss. So basically continuous miner was introduced in around 24 years back in India at Anjan Hill mines. So since then, today we have around 50 continuous miners at varying geological and geomining conditions. So in this study, I am presenting about one such implementation of continuous miner to extract a thick coal seam which was developed in the middle section with semi-mechanized mining method, and they plan to depillar this panel using continuous miner technology at panel C2A of GDK 11 Incline Mine, Singareni Collieries Company Limited. This is the so we can see the seam is total thickness of the seam is around 6.1 meter, and this seam majorly developed in the middle section. So here the portion located marked in the yellow, this section developed in the top section. The other than the yellow portion, all these places where the pillars were developed in the middle section, which is leaving around 2 meter of thick and layered and laminated coal in the immediate roof. So we can see the disturbed roof in the middle section working. So here we can see the exposed roof bolt after roof fall, and this in some location this middle section working is supported with the standing type of support system. And we can see other geomining details. The depth of cover is around 289 meter and the RMR is around 50. So basically the mine management is planned to widen the gallery up to 6 meter to ensure the easy maneuvering of the continuous miner and ram car. So the widening is done by trimming the coal of 1.2 meter from all sides of the pillar in both middle section and top section working. Further, they plan to make the roof stable. So they plan to extract the roof up to the massive strong sandstone roof in the middle section. So they plan to extract about 2.1 meter of coal or shale bands which is left in the roof during the development of the coal pillar in the middle section. So the final extraction height would be around 4.6 meter during development, and the top section is left as 2.5 meter, only widening is done in that location. After that we did the stability assessment of these heightened and widened pillars using the strength calculation using a Severus formula, and the load is calculated using the tributary area method. So here we can see many pillars have almost all the pillars having WH ratio of more than 5, which is squat in nature, but some of the pillars here having the factor of safety of less than 1.5 here also. So this was the main concern when we are getting the permission from DGMS. And the first concern is the height of working, which is 4.6 meter, and next concern is the factor of safety of the pillars, which is less than 1.5 for many pillars. So finally we got the permission to extract these pillars. So the support design is done by using the formula developed by Venkateshwarlu sir. The rock load is calculated using this formula at gallery and junction. So here we used around 1.8 meter length roof bolt with 1.2 meter by 1.2 meter grid pattern at gallery, and 2.4 meter length of roof bolt with 1.2 meter by 1.2 meter grid pattern at junction. And additionally we also installed 5 number of flexi bolts of 5 meter in the junction as additional support. And as the sides of the pillar is exceeding around 3 meter, the side support is also recommended with plastic wire mesh. So here we can see three number of side bolts in a row is installed, and the wire mesh is installed like this. The first corner is jammed in the roof, as the structural control and stress control failure is more in the corners of the pillars. So the manner of extraction is followed. So here we combine the split and fender method and modified fishbone method for the manner of extraction. So first the pillar is split into 2 unequal parts. One is of fender A is of around 12 meter, this one, and fender B is of around 18 meter. So the slices extracted like this: slice 1, slice 2, and slice 3, slice 4 from split gallery, and the remaining part of the fender B is extracted from the original dip gallery. So after extraction of each and every slice, bottom cooling is done in 2 stages for top seam working. First ramp of 1 in 6 meter is made, 1 in 6 is made to extract around 1.5 meter thickness of floor coal,
and again 1.8 in ramp is made to extract the remaining coal from the floor, which makes the final working height of 6.1 meter. And the ribbon snook is designed based on the empirical approach developed by Dr. Ashok Kumar. So here the required area is around 75 meters square for the final ribbon snook. So numerical modeling is also carried out for this study. So initially we conducted numerical modeling. Initially we developed an in-situ model considering the width of 288 meter, length of 450 meter and height of 115 meter. So for then we developed the galleries by considering the working height of 5 meter and gallery width of 6 meter. So here we also estimated the rock load height at junction before bolting, which is 2.84 meter, and at gallery, which is 1.75 meter. Then we installed the support as per the previously shown support plan. We also installed a flexi bolt and roof bolts. Then we can see the rock load is reduced at junction as well as at the gallery. Then pillar strength is also estimated using numerical modeling. So all the phases in the numerical modeling, top, bottom and all sides are fixed, and a constant velocity of 1.15 into 10 to the power minus 5 meter square is applied, and we got the pillar strength of 1.66. So this coal pillar, this includes all the weak beds and the shale bands which are there in the borehole litholog. And then numerical modeling is also carried out during the deep pillaring at different stages.
Hello, you may conclude.
Okay. The factor of safety of the fender is found to be 1.23 to 1.77 through numerical modeling. And the strata monitoring is also carried out using dual telltales, 2 horizon, 1.5 meter and 5 meter during winding and tightening. And we haven't observed any roof sagging from this. And during deep pillaring, the routine monitoring is carried out using AWTT, which was anchored at 15 meter roof horizon and 5 meter threshold limit. And RTT also installed in the middle of split gallery and original dip gallery at 8 meter roof horizon, and 23 mm is observed before a roof fall from this. And multi-point extensometer and vibrating wire stress meter also installed as part of design monitoring. You can see the measure from this. And we haven't observed any major overriding, although 1 or 2 small overriding observed from this panel. In addition to structural control failure and stress control failure, we also face some operational issues in this panel. So the continuous miner used and continuous miner and other bolting supporting equipments used in that mine is of around 4.5 meter only, but in some locations.
Finally conclude.
Yes, sir, that's it. In some locations the height is exceeding 5 meter also. So in that locations we faced a major challenge in installing support system or when driving the split gallery. Although we successfully extracted this panel with around 71% recovery rate.
Yes.
Thank you.
What was your, final size of fender you have decided? Yes. Whether it is based on empirical
numerical modeling, yes,
or numerical?
Numerical modeling, sir.
Where was factor of safety more? In case of numerical modeling or that?
In case of numerical modeling, the factor of safety was more, sir.
Okay.
Yes. Have you validated your model?
Yes, sir. This model validated. The rock load height we validated in the field. By the instruments, sir. By dual telltale and this one, AWTT.
How much the rock load difference was coming?
Sir, actually we observed around at 1.5 meter we observed the roof sagging. So, but in numerical modeling we got the rock load height of 2.84 meter, but after bolting also we got around 2.54 meter.
Okay, thank you.
Yes, thank you.
So, any question? Yes.
Less than 1.5.
Yes, sir.
Okay. But in your one of your slide you showed. One of your slide you showed that that fender safety factor goes up to 1.7. How it is possible? Fender is part of a pillar. Once you cut it, the factor of safety has to drop down to around 1 or something or below that.
Yes, sir. Fender factor of safety is from 1.2 to 1.7, sir. Those pillars which are having factor of safety less than 1.5, those pillars are not extracted with split and fender method. Those are smaller size of pillar little bit. So we extracted with modified fishbone method or Neville method. Those
I
pillars.
think you please check your calculations.
Yes,
A
sir.
fender is a small portion of a pillar.
Yes, sir.
Overall pillar safety factor, you say 1.5 roughly, and fender has got 1.2
No,
to
sir,
1.7.
those pillars not splitted actually. Those pillars
You
extracted
can
with
show
different
that table
manufacturers.
also, I think.
It's okay, it's
I read
okay.
somewhere 1, 2, 3 also. 1.23 also. Yes, that.
Yes, sir. So that pillar is
Even,
not
1.5,
followed this
1.2
split and fender
even.
method, sir. We extracted that pillar with modified fishbone method. As the already factor of safety is less than 1.5, so we haven't splitted the pillar, so we extracted with modified fishbone. So these three pillars are 21, 22 and 23, and pillar number 37 and 38 is not splitted. Other pillars we split.
That also has less than 2 safety factor, right?
Yes, sir.
Yeah, but fender having this high safety factor is little bit.
Those pillars are this pillars, sir. 4, 5 and 9, 10. These pillars having 1.7.
Fender should have safety factor at least 1.5, not less than that one.
Yes.
Somewhere having you have. Okay, anyhow, thank you. Thank you very much for your nice presentation. Next presenter will present his paper.
Number 8.
This is assessment of rock load height at the Gulf edge during depulering with stowing, a numerical modeling study. Author is present. Who is author? Yes. Priyanshi Onam.
Yes.
Yes, please. Please start.
Good morning, everyone. I, Priyadarshi Onam, pursuing PhD from NIT Rourkela under the supervision of Sahendram, and I will be presenting today on the topic assessment of rock load height at the Gulf edge during depulering with stowing, a numerical modeling study. The most common mining method, as we all know, is the board and pillar mining method in India. And through this mining method, while the extraction of coal, a large amount of coal gets locked up in the form of pillar. And to extract these coals, we have to go for depulering either by caving or stowing. And in the stowing, like semi-mechanized depulering with a stowing panel, we are still going for the conventional cockchock supports at the Gulf edge. And the installation of these cockchock supports is very little bit risky, and it also time consuming, and it limits the movement of machineries. In this slide we can see the plan and site view of the Gulf edge supports, which is installed at the plan and site view of the conventional cockchock supports, which is installed at the Gulf edge. Now we will discuss about the roof-rib interaction at the Gulf edge during mechanized depulering with caving. In this, we know that in mechanized depulering with caving, the extraction rate is fast. So due to the fast extraction, the in-by rib adjacent to the Gulf edge remains stable and temporarily stable. And while this temporary stable rib, it helps the RVBLS, and under this temporary stable rib, it works efficiently. The next one is conventional depulering with stowing. In this, the extraction rate is little bit slow compared with the mechanized depulering with caving. So in this, the rib adjacent to the Gulf edge, it is induced to the mining stress for a longer period of time, and due to the longer stress and time dependent, these rib become unstable, and it doesn't provide that much competency to the RVBLS. Now we will go with the conventional depulering with stowing. In this, the voids which are coal which are extracted is systematically filled with the backfilling. So these backfilling, it provide competency to the ribs which is adjacent to the Gulf edge, and the unsupported roof span is very less, due to which there is a possibility of going with the RBGS, that is roof bolt based Gulf edge supports, in the conventional depulering with stowing. In this case study, I have taken panel number 4S/26 at the Godavari Khani number 1 and 3 inclinement. Here the sim number 4 was being depuled with the hydraulic stowing using STLs. And in this table, I have shown the geomining details of the panel. The instrumentation like a stress meter, extensometer and instrumented roof bolts were done at the two locations, and it is shown in the image. And through these instruments, the readings, it is shown in this figure. In the figure 5, we can see the graph of here cumulative induced stress is shown, which is recorded with the phase advance at the location 11D and 40L. And in the figure C, we can observe the roof displacement, which was happened at the 11D and 40 levels. And for numerical modeling, I used Flag 3D software for which is on FDM. The geometry of the model was like 350 meter length, 170 meter of width, and the floor was extended to 50 meter above and below the seam with the gallery dimensions of 3.6 meter and 4 meter width. This image shows the pillar extraction with sand stowing, and here the diagonal line of extraction is being followed. The red color, it shows the sand stowing, and so beside that we can see the ribs which are understood. At the left side is the gope that is filled with the sand. And here in the rectangular red dotted line is the area where the RLH was examined. The RLH was observed in the immediate roof with the unsupported and unsupported. Like left side figure 8, we can see the unsupported immediate roof. Here the RLH was observed along approx 1.19 meter, and in the supported immediate roof it reduced to 0.74. And these are the results of the numerical modeling. I did a parametric numerical simulation by just varying gallery width and RMR. Gallery width was varied from 3 meter, 4 meter and 5 meter, and RMR was varied from 30 to 65 by a variation of 5 RMR. We can see the variation in rock load height and at different RMR and gallery width. And in the figure 11, we can see the comparative study for rock load height at the go phase during deep leading with caving and stowing. In the caving, was estimated from the Kushwaha and others formula at the go phase, and the other graph it is shown of this study. Now it was in this study it was found that the RLH is a little bit less affected due to the depth of cover due to the stowing, and in this numerical model the RBVS significantly lowers RLH at the go phase, and this study indicates that there is an opportunity to go from conventional cockjack supports to RBGS, that is roof bolt based go phase support. Thank you, sir.
Thank you very much. We are very much in time. Any questions from audience? Any question from audience? I think no questions. So thanks. And now we request next presenter for presenting his paper, Analysis of Carbon Footprint and Carbon Credit in Coal Mine Sector in India using CMM Cash Flow Model. Pallavi Wankhede and Hemant Bharwani. Anyone presenter?
Absent. Next.
Is absent? Nobody is present?
Yes, sir.
Pallavi Wankhede and Hemant Bharwani?
Not absent.
Okay. So we'll go to the next
Development of field validation.
paper, that is development of field validation of a coal roof index for roof stability assessment in underground coal mine by Sanu Prithvi, Raju, and Gade Priya and Ashok Jaiswal. Please tell your name, author.
What's your name? Prithviraj.
Okay. Thank you. Prithvi.
No, that's not mine. So Good morning to one and all. So myself, Dr. Prithviraj. I'm working as an assistant professor in NIT Raipur. So here I'm going to present a paper, titled Development and Field Validation of a Cool Roof Index, that is CRI, for Roof Stability Assessment in Underground Coal Mines. So these are the contents which are there in my paper. So first, the introduction, statement of problem, and development of a new geomechanical classification and comparison with CMRI, RMR classification, and last the conclusions. So moving on to introduction part, as we know, in India, most of the underground coal mines are working under board and pillar method of working only. So as per the MOC's or Ministry of Coal Production data, so where they have written that 35 million tons of coal annually is produced using the board and pillar method of mining. And in this board and pillar method of mining, the failure of immediate roof is recognized as a critical geotechnical risk in underground coal mining environments, especially in weak rough conditions. And as per the DGMS records, 10 to 35% of total fatal accidents in Indian mines from 2012 to 2022 are recorded, and that are mainly caused by roof falls or ground movement. So the prime concern is to assess the stability of the galleries, roof, and appropriate support design. So this is the statement of the problem, and the rock mass characterization is the most important part to assess the roof conditions. And nowadays in coal mining, so generally we are using CMRI RMR classification, which is developed by Venkatesh Farlu sir, and this is the formula used to calculate the CMRI RMR. And here from this graph, we can see it's a graph between stand-up time and CMRI classification. So here we have plotted case studies up to 44 case studies, Indian coal mine case studies. So in that, so you just check the marked region. Here some of the mines, the cases, which has having a RMR more than 40 to 60. So here it was a fair rock, but the stand-up time was mentioned, it is within the 30 days only. So, and this is somewhat, we have to think, because the RMR value which is greater than 40 and which is up to 60, so it should stand more than 30 days. But based on the records, based on the field observations, and based on the CMRI and RMR data, so it was mentioned the stand-up time was less than 30. So after the re-examine of these cases, it has been found that so some of the influence, sometimes the influence of single weak parameter is sufficient enough to reduce the strength of the roof mass. So based on these, we have proposed a new coal roof index. So this is the formula generally used to calculate the coal roof index. And it is based on the multiplication of individual dependent parameters. So here we have total 5 dependent parameters ranging from RCRI1 to RCRI5, so which are a layer thickness, structural features, weatherability, groundwater flow, and uses of the strata. And by using this one, so we have included a rock load factor, which is nothing but the combination of effect of stresses condition and geometrical parameters. And the final adjusted CRI is the ratio of CRI, which is calculated by using this formula, and RLF, that is nothing but the rock load factor. And to calculate the rock load factor, we did a numerical simulation study by using a phase study software, and we did a 3 various widths. We did a parametric study with 3 different widths ranging from 3 meters to 5 meters, and 2 different heights, 2.5 meters to 3.5 meters, and with 7 different depths ranging from 50 meters to 350 meters were considered. And by using this, we did a regression analysis from the numerical simulation data, and this is the formula we got from the regression analysis to calculate the rock load factor, and which has a function of width, height, and depth, where width is the gallery width, and height is the height of the gallery, and depth is the depth of working. And this is the figure which shows the yield zone view, that is nothing but the plastic zone view within the roof of a single case, where W width of a gallery is 3 meters and height is 2.5 meters, and it has a depth of 50 meters. So the proposed rating system here, so and to calculate what is the cumulative of that thing. So for a layer thickness ranging from 0.22, if it is less than 14, so this is the rating value, CRA value we need to consider. And similarly for different things and for uses of the thing, and from for it is 0 to 10, the rating value is 1, and if it is less than 50, it is 20. So by using this chart, we can calculate, we can assess the values of different ratings, and by using these ratings, we can calculate the CRA value by using the formula and the rock load factor. And this is the roof, cold roof characterization, and based on the values what we have got, so we made a cold roof description from extremely weak to extremely strong. And in CMRI RMR value, so there are only 5 classifications. We have included 2 more things that are extremely weak to extremely strong. And by using this chart, we can assess the rating of a roof. And also made a comparison between CMRI with the proposed one. So the main purpose of CMRI is to develop for estimation of rock load and support design in Indian coal mines. But whereas this proposed CRI classification, it is designed to estimate stand-up time and support design in Indian coal mines, and also we linked the proposed CRA value with the Eucken-Brown strength parameters, because by linking this one with the Eucken-Brown strength parameters, we can do the numerical simulation approaches also, study also. And this method is additive one, it's a multiplicative one, and it's not explicitly included. And here the R square value, the correlation with stand-up time, the R square value we got with this CMRI value was 0.48, but with the proposed CRI value we got around 0.78. And prediction of stand-up time, so in old CMRI RMR value it is not available, but in the proposed one it is available to predict the stand-up time also. And I'm moving to conclusions part. So these are the conclusions. Here we have developed and proposed a new CRI value, which has functions of 4 different parameters. And we have also included the RLF value, rock load factor. And this is the final formula to calculate the CRI value. And the adjusted CRI ranging from 0.01 to 1000, and we have calculated 7 classes have been identified based on the CRI, extremely weak to extremely strong. And the suggested CRI classification has a strong correlation with observed stand-up time for all 44 cases. The coefficient of determination of R square, that is 0.78. And thanking you. And he is the main author, Dr. Sonu, Deputy Manager. So you have any in detail discussion, you just contact this person.
I think it's very interesting paper, very much, and I think you mix both the things, isn't it?
Yes,
and both the even you have changed the formula for rock load also.
Yes, sir.
Because in CMRI formula, what rock load empirical relation formula is given, you are not using that one.
Yes, sir.
Stand-up time and all this concept is not very much applicable to coal mines. It's sedimentary rock, isn't it? And Eucken-Brown criteria, again you are bringing it here.
Yes, sir. Yes, sir. For nowadays, most of them are
but the basic structure is same thing. What you are
all
5 parameters, same parameters.
Yes, sir. But what happened?
And you are ignoring here the the adjustment factors. Effect of depth and effect of working by nearby.
No, sir. We are included by that in RLF. Rock load factor में include किया था वो तो. So that one included.
I think I keep it open to audience, and you can ask question rather than me. Isn't it? Yes.
Actually, I have some questions regarding your findings.
Yes, sir.
Yeah. How you have decided this stand-up time?
Sir, actually it was in literature, in the same Venkateshwarlu sir's literature only. It was mentioned in the literature. Stand-up time was mentioned in the literature. Literature for sir has considered total 44 Indian cases, coal mine cases, and the stand-up time was also considered in those cases, in the literature.
And what do you mean by RLF?
Rock load factor, sir.
What is it?
So it is a So rock load factor generally, sir, is how much height means we are expecting up to height.
Fill height.
Yes, sir. Means from the numerical.
But Actually, if you will see the Venkateshwarlu's formula,
Yes, sir.
if we just remove the density from that formula, we can also get the that rock load height from that formula.
Yes, sir. But what happened in Venkateshwar sir formula? It is a additive, means it is just a summation of 5 parameters.
Okay.
So and from this graph, so it is given from the sorry. Can you please switch out? So here, sir, so this graph was deduced from the Venkateshwar sir only. So here you can see clearly. So if suppose suppose R1 has a more influence, okay. So total the RMR value is more, and here you can see the RMR from starting from 40 to 60. I'm mentioning about 40 to 60. Less than 40, it is a weak one. We can consider as a weak strata. But greater than 40 to 60, it is a fair one. But the stand-up time it is less than 30 days. So it means within the 30 days we are expecting.
How you have calculated that?
Which ones?
That is stand-up time.
Stand-up time was given, sir.
Oh,
It is given in the literature.
Achha, okay. That you have also said that you have added 2 more roof types, na? So what is the advantage? Okay, it's okay.
Thank you.
Audience, if you have any question?
Very interesting.
Yeah, it's very interesting study.
From
Anyway.
Zaki's rock mass classification to everything, every rock.
So, but thing is, you said that you had got better correlation with stand-up time.
Yes, sir.
So you didn't show that in a graph.
Yes,
Then
sir.
we could
Actually,
have
it was
given,
mentioned.
how the spread.
Yes, sir. Actually, it was mentioned in the paper, but because I have to concern with the slides, number of slides. So I had to
But
make it
one thing
mention.
also I wanted to know: all these roadways were supported before 30 days, right?
Yes, sir.
So with support, it has fallen.
No, sir. Without support. It was mentioned without support, actually.
So those roadways were without support.
Yes, sir. In simulation, actually, these are rock load
Not simulation. I'm talking about the data which you have shown.
Yeah,
The
sorry,
graph.
sir. I don't have any much idea. Actually, I'm not the expert of this topic. So.
Okay. We need to contact that guy.
Yes, sir.
Even they time and all that.
Yes, sir.
You should follow somebody. I mean, whose observation are they?
Sir,
I mean, the graph creator, because you put standard graph and standard.
No, sir. It is a PhD work of Dr. Sonu. Sonu is working under Dr. Ashok Jeshwal, sir. He has completed his PhD.
But anyhow, I mean, very interesting.
Thank you.
Thank you very much.
You, sir.
And we request the last presenter to present the paper, exploration and characterization of higher earth elevation, something. Paper ID 59. No, one more is left. Just wait. Yes, 59.
Yes, exploration and the characterization.
Exploration and characterization of higher something.
Rare earth.
Higher.
देखिए कहाँ पे है?
कौन सा है?
ISAMET. Yes.
ये ना?
PPT. Yes. Pointer कहाँ है? This one.
आपका नाम बता देना है. Pointer आती है ना?
Yeah. Very good morning to all. My research area and the topic of my paper is exploration. Myself is Sadanand Sharma from CSIR Simper. My topic is exploration and characterization of rare earth element in the Mahan coal block, Singrauli coalfield, central India. इसको थोड़ा इधर 1 मिनट इधर आएंगे. इसको
फुल स्क्रीन में आप कन्वर्ट कीजिए, इतना ही आएगा, ओके, दिक्कत है, ओके. Our topic background is rare earth elements are critical for clean energy and strategic technologies. And second is global supply concentration drive, search for alternatives. Coal and clay-rich strata are emerging RE hosts. Indian Gondwana coal remain underexplored. Mahan coal block offer a strong geological potential. As because this topic I have chosen, actually I am working in the Department of Gas Emission and Clean Energy Resources, where the coal core will be done through the exploration, and for this particular part we have chosen the topic because as per the global demand of the rare earth element all over world, so our country wants to explore these things for Atmanirbhar Bharat. So that particular things we are also want to depend upon that particular rare earth elements, and that rare earth elements is the nothing but the lanthanides, all 17 elements from the periodic table, that is the lanthanides, as well as one scandium and yttrium including this. So total number of 17, we are searching for the 17 elements. Now, Indian RE coal context are Gondwana coal field are widespread across India. RE is supplied mainly from beach sand monazite. Actually, our country is only dependent upon the monazite sands. That is the seashore sands. From this, we are extracting the RE. But nowadays, we are searching in the coal and its strata, as well as in the roof partings and the overburden also. Next is coal-associated strata shows RE enrichment. Next, clay and phosphate mineral acts as hosts, and systematic coal-based RE studies are scarce. These are the study area. Mahan coal block that is in the part of the Son coal basin under the Barakar formation with the thick coal seams, and this is the clay-rich interbeds inside that, and that is the very favorable condition. That is the RE favorable seams, and these are the two seams. One is seam 7 and other is seam 8. And from these seams, we have collected 20 number of samples. We have made 20 number of 20 number of samples. From these samples, we are carried out some laboratory analysis. And here is the from the extreme right of the part seam 7 and seam 8. Seam 7 is the upper coal seam, and seam 8 is the lower coal seam. And these only two seams are here, and seam 7 is the thicker seam, and seam 8 is thin seam. And this having the 8 carbonaceous horizon identified, and seam 7 and seam 8 are economically significant. And seam 8, already I told that this seam is thin, and seam 7 is thick. And this having the clay-rich parting within seam 7. And this one is the common associated minerals that is we are extracting. We can extract from this mineral. This is the host phase of the rare earth element, scandium to lutetium. And our main objectives of this work is quantify RE concentrations, means signature. We want to find the signature of the RE concentration. Next is the identify mineralogical host phases. What are the mineralogical phase that is present inside that particular 4 zones, from the parting to the coal also, and roof also. And next is the evaluate unconventional RE potential. And for this purpose, we are having some particular methods, that is the proximate analysis, ultimate analysis, and ICPMS for trace and critical elements, that is the RE analysis, and next is XRD diffractogram for mineralogical purposes. And one most important thing is the FESEM, which we have not done till the experiment. Next is the sampling strategy. This is the this right extreme portion of the figure is the working areas from where the Mahan coal area, where we have collected the core samples, and the core based sampling was carried out from systematically logged exploratory borehole cores drilled in the Mahan coal block, and coal parting roof and floor lithologies we have carried out from this and selected the sample from these particular zones. And next is the strict lithological separations. I have already told that 24 number of samples we have made from this. And next is the coal quality SIM. Actually, this is the laboratory studies. We have studied the physical, chemical, and petrographic analysis, and in which we have found that low as 18.87 weight percent and high GCV in that 5146 kilocalorie per kg, and vitrinite rich compositions in that. And next, in SIM 8, very high as 44.07 weight percent, low GCV we have studied here, and high mineralogical matter contents are inside that. And these are the analytical techniques from which we want to gather some information for these particular purposes. And these are the XRF analysis of SIM 7 and SIM 8, and ICPMS analysis of SIM 7, SIM 8. And these are the comparative studies for the SIM 7 and SIM 8 for XRF and heavy metal concentrations. And this is the RE concentration in ppm of Mahan coal blocks. We have studies for the coal, and inside that we have seen that parting means that having the reach of the clay rich matters, and this having maximum amount of RE material found inside that. Yeah. Okay. This is the comparative RE distribution across coal and associated lithologies, and this is the average RE and ICPMS of Mahan coal, and this is the trend, RE enrichment trend of Mahan coal from coal to floor cells. And this is the conclusion. Rare earth elements enrichment in Mahan coal block is controlled primarily by mineralogical and lithological rather than coal rank alone. And next is the clay rich parting roof floor cell shows the highest total RE concentration, confirming predominantly mineral bond mode of occurrence. And there are two kinds of rare earth elements here, that is the light rare earth element and heavy rare earth elements. And this light rare earth element dominated in the indicating that limited post-depositional fractionations and a detrital source influence. And most important thing is the kaolinite and illite are the carrier of the rare earth elements. And SIM 7 demonstrate more efficient RE retention compared to SIM 8 due to favorable depositional conditions, and the study highlights clay-rich intercalation as promising unconventional RE resources supporting India's critical mineral strategy. And these are the references, and thank you.
So, thank you very much. Any question from audience? It's a good paper. Or
yeah, here. Just go to next. Here. You talked about this vitrinite 62.85 by volume. So this volume percentage is in terms of which, because the sum of all this is not making 100%. Is it making 100%?
Actually, sir, I am not a geologist. Dr. Mende is geologist. He can explain about that.
Okay, so vitrinite, liptinite, internite, mineral matter, and all these are constituting 100%, right? So this is all the mineral matter composition, right?
Yeah.
So, your question yes. You are satisfied, sir?
No, can you?
Actually, he made constituents mineral matter free basis.
Okay. Okay, got your point. Thank you.
Okay. Thank you. Thank you very much. I think no more presenter is here, and we have completed a list. Let me give a gist of this paper.
Thank you all, Chairman, Co-Chairman. Now I would request our Chairman, Session Chairman and Session Co-Chairman to come on the dais for felicitation of our presenter. Thote sir and Avinash sir, please come to the dais. And I will call one by one name of the presenter. Come on the dais. ठीक है. Yes. Duman Lal, please come forward. Next is Dr. Manoj Bagde sir. Next is Subodh Kumbhakar. Please come. Next is Ganesh Reddy. Next is Ajas AK. The next is Mr. Tamil Prasant M. Next is Priyadarshi Onam. Next is Prithvi Raju. The last is Mr. Mr. Sadanand Sharma. Thank you, sir. Now I would request Dr. John Lewis, sir, to felicitate our session chair, Professor N.R. Thote. Please, sir. Thank you, sir. And I request Professor R.I. Ipude to felicitate our today's session co-chair, Dr. Avinash Paul, sir. Please, sir. Thank you, sir. So with this, the session is, we are closing here, and now there will be a break of 10 to 15 minutes for tea and coffee. So I thank you all once again.
Hello. Thank you, everyone. Thanks.
Every industry presents unique challenges that demand smart, agile, and efficient solutions. At Solar Technical Services, we don't just provide products. We deliver expertise, innovation, and precision-engineered solutions tailored to your specific needs. From mining to infrastructure development, our expertise extends across multiple sectors, ensuring seamless operations, optimized performance, and sustainable results.
It gives me a great pleasure to inform you that Solar is now providing customized blasting services to many of our customers who require specialized blasting requirement. This we do it by providing fit-for-purpose product and making available skilled resources. Solar takes full responsibility of all operation and safety and management of the blasting services. We strive to achieve a safe, efficient, and consistent blasting, which is the strength of our team.
At Solar Technical Services, we don't just provide solutions. We optimize, refine, and enhance operations for maximum safety, efficiency, and sustainability across mining, construction, and infrastructure industries. Blast optimization, engineered for maximum impact with minimal disruption. Efficient fragmentation means lower costs and higher productivity. Optimizing resources for long-term efficiency, minimizing environmental impact while maximizing productivity. Backbreak and overbreak management. Controlled blasting techniques to reduce material wastage, enhancing structural stability and improving cost efficiency. Vibration management services. Cutting-edge technology to monitor and control ground vibrations, ensuring the safety of nearby structures and communities. Fragmentation prediction and analysis. Advanced modeling and data-driven solutions for precise fragmentation and improved material handling. Operational costing solutions. A meticulous approach to boosting productivity while maintaining cost efficiency, ensuring every project stays within the budget. Our expertise has powered some of the most demanding projects across industries, including coal mining operations, enhancing extraction efficiency and safety, NTPC PB mine, optimizing blasting for large-scale energy operation, limestone extraction, precision solutions for cement and construction industries, metal mining, infrastructure mega projects, contributing to nation-building endeavors. Raj Infra and Mumbai-Pune Expressway, pioneering controlled blasting solutions. Jayakwadi Dam and Shahpur Railway Blast, ensuring safety and precision in critical engineering projects. With a presence in 82 countries and over 6 lakh metric tons of explosives delivered by FY24, Solar Technical Services is a trusted partner in blasting and technical excellence. Solar Technical Services, expert solutions with the power to propel.
Solar Industries India Electronic Control Club के सिस्टम से उसने 55,000 एमपी का ब्लास्टिंग किया और उसने काम पूरा 2.5 महीने में करके अच्छा तरीके से हमको कन्वर्ट कर दिया।
सोलार में इलेक्ट्रॉनिक ट्यूटोरियल यूज करके हम लोग ब्लास्ट किया। ईच होल इंडिविजुअल प्लास्टिक करते इसलिए वाइब्रेशन थोड़ा कम आ जाएगा। नियरेस्ट हाउसेस गोडाउन्स में हम लोग किसी को डिस्टर्ब नहीं करना है, इसलिए स्पेशली सोलार को यूज कर रहे हैं।
अरे भाई वो कहाँ है, उसका नाम भी याद नहीं आता। अरे Good morning. Authors, I'm requesting the presenters to please bring their presentation here.
Submit their
submit
PPT's
their
presentation.
soft copy here, please. Yeah, no? Hmm.
A small note, the present is, you can submit your presentations.
attention, please. Do we have the presence of Sangam Kumari? Okay. Iftisa is there, na? Yeah. Oh, okay. So, ladies and gentlemen, greetings again. We are starting the next session. Today, some of you may be texting your partners with wonderful messages, being a Valentine's Day. So, let's start the session on this wonderful note that there will be a lot of love in the air. So, we have with us two distinguished personalities here in the form of the session chairman and the co-chairman as well. So yesterday we heard Dr. Sebnam Duzgun as a keynote speaker, and I am again privileged to introduce her briefly. She is a full professor, Brett Banfield Distinguished Chair and Associate Department Head at the Mining Department of Colorado School of Mines. More than 25 years experience. She also is an eminent personality in the domain of GIS, AI-driven mineral and geothermal exploration, geospatial analytics, remote sensing, system safety. That is one of the important aspects. She has authored 4 books, 11 book chapters, more than 90 journal articles. I request Ajay Agrawal sir to welcome her for this session with a floral bouquet. Accompanying her for this session, we have another distinguished personality, co-chairman Dr. Sanjay Roy. Dr. Sanjay Roy is currently Scientist G and Head of Slope Stability Department at CSI Simford Dhanbad. He has completed his BTech in Mining, MTech in Quality and Reliability Engineering, and PhD in Mining Engineering. More than 70 publications, 7 patents to his credit. He has received royalty of more than 1 crore from his patents, has completed more than 200 projects related to explosives and safety, slope stability. He has been conferred with prestigious National Geoscience Award, CSI Technology Award, and Mining Engineering Design Award, and appreciation letters from DG, DGMS, DG CSIR, PESO, and many agencies for his outstanding work in the field of mining engineering. I again request Dr. Ajay Agrawal sir to welcome him with a floral bouquet. Thank you, sir. Now I hand over the control to the session chairman for conducting the session.
Thanks very much. It's an honor for me to chair this session for everyone. I want to make you a bit of a reminder. We have 10 papers, and everyone will have around 8 minutes. So I want you to recognize that your goal here is to deliver the major aspects of your work, not the details, so that you create a curiosity among us. We go to the proceeding and read your paper, okay? So give us, please, the most important and also critical parts of your paper, okay? Don't go into details. And I didn't know, but we're supposed to evaluate you. And so I'm welcoming the first presenter, Varshnam Mane.
Dr. Katpatal will be presenting. This Varsha Mane and Dr. Yashwant Katpatal.
Oh, okay. Oh, thanks very much. So, do you need this?
Okay. So very good morning to all of you. I am very happy to be here, and I will be sharing some experiences of one of the project. But before that, Honorable Chairman, Dr. Shabnam, Dr. Roy, the co-chairman, the participants who are present here from different mining academics or industry. I am going to share one small case study which we have conducted in Nagpur mining areas, coal mines. And this project was actually awarded to Government of Maharashtra, and the Government of Maharashtra Department of Groundwater Development Agency, GSDA, has worked into this. And I was only part of this project as a co-PI, and this project was actually funded by World Bank. So groundwater depletion due to mining is a very well-known fact. Yeah, okay. It's okay. I will take care. So groundwater depletion is a very common phenomena. Everybody knows that the groundwater discharge due to mining is there. So the project was taken to quantify how much water is actually depleted, and then what are the strategies which can be adopted to, let's say, use the water which is actually discharged by the mining activities. So this study was done. Next. This study was done in one of the two mines which are in the north of Nagpur, which are actually the Bhanegao and Singori mines, which occupy some area. And this is the details, what is the area, etc. And the dewatering depth in the two mines was it. Now everything started with what was major was to install different observation stations around the mines, different mining areas, all the villages which were actually around that mines. The monitoring of groundwater was taken up, and then using that data, which was the fluctuation in the groundwater before the mining started in 2022, and then after the mining was taking place after 22, and the whole data using the differences and the hydrographs which are generated. Next. So this is the objective, to assess the current water, and also the quality of water which was actually coming into the mine and which was discharged, that was also tested by the department, so that it can be used for different purposes which are there. Some of the water can be used for irrigation, some of the water for the industry which is there, and some of the water for supplying to the residential population which is close to that area. So next. These are the areas which are there. Now these are the two mines, which is Bhanegao coal mine and Singori mine. Now you can see that the river Kanan is there, one river Kanan, and on the two sides of the Kanan river, these are the two mines which are there. And this area, when you see the land use land cover map, which was generated for, let's say, 2003 to 2004, and then finally 2024 and 25 and 23. Now 22 the mining operations started seriously. And we see that a drastic change in the land use is there, whereby we find that not only the coal area is increasing, but the other residential and other industrial and other lands are also increasing very fast. Now that is actually alarming, and apart from the mining area, the other ancillary development is also very, very fast in that area. Next. Now we see that this is the methodology. The more focus was on the record of the groundwater data, and for that, using the funds which were derived from the World Bank, different observation wells were identified all around the villages, and then the piezometers were actually installed. That these piezometers with automatic data loggers and recorders were placed, and this data was actually used. So you can see that, and then using the data which was generated from the automatic recorders, the modeling was done to understand that what is actually the situation in the groundwater which is happening within the mine due to discharge. It was tied up due to let's say the mining activity, and then finally we have tried to give recommendations how to use this water. Next. So this is the geological conditions in the area. The pink one are the metamorphics which are there. The central portion is the sedimentary terrain which is there. You can see that the barakar measured with the coal are shown in the center. The several profiles were selected. You can see AA, BB, CC, etc. And along these profiles, along these section lines, the profiles were generated. Now you can see these profiles which shows that what is the situation depth-wise of the different aquifers which are present in the area, and these aquifers are actually these have to be actually used for the quantification of the capacity of the aquifers as well as the dynamics which is involved in this particular area. You can also see that there are 3 faults which are present in the area, which are actually displacing the coal seam, which are the 7 coal seams which are present in the area. Next. Now these are the piezometers which have been installed in different villages, all the villages, 8 piezometers all around, and plus all the observation wells which are present in the villages were also taken up for record of the data. Which is because we must get all the data which is happening in different villages, and then only the dynamics can be actually understood. Next. Now these are the hydrographs. You can see that after 22, that is the before 22, the fluctuation shows a very harmonic type of, let's say, changes, while after 22 it changes drastically, and this is due to the mining operation which is happening in the area. Now after 22, next. Now these spatial modes were also, tools were also used to find out the spatial changes in the groundwater levels, and you can see that this is the situation of 2021 before the mining was happening, and 2022 and 2022 subsequent years. You can see a drastic change in the groundwater levels in the same season can be seen, where the red lines comes into the picture, which shows the depth increasing. Next. Now then using this, the different parameters were actually estimated. You can see the total recharge and then total available water, etc. And you can see that the total draft. Now the draft and other parameters can be compared with the situation which is in 2015-16 and the situation which is in 22-23. Now you can see that the main figure which comes here is the gross groundwater draft for all uses. It was 1653 hectare meters, and it has increased to 2630. Now this includes the mining, dewatering, that has actually increased the figure which is there. Now the last figure which is there, the surplus groundwater which is present in the area has decreased. You can see 168, it has come to this. So this is what is happening to the aquifer capacity or the storage which is happening in the area. Now these figures will help us in planning and with taking let's say the steps which are there in the near future. Next. Now you can see that quantity of water available per year, then quantity per day in liter, then how much population can be covered by the total water which is being discharged, and finally how much area can be irrigated in the area, which is the extra region under irrigation in the area, because it's a cropping area and you have the agriculture fields on the north and other areas. So, but when we are using this for irrigation and other purpose, we have to be very, very sure that the groundwater should not again be coming to the mine through inflow. Okay, next. Yeah. So, and finally the recommendations were given that the discharge should be actually put into the river at appropriate places. It is already being put in different parts of the river, but appropriate places which can again be used for supply to the, let's say you can see the Khaparkheda plant is there. The plant can be using this, and other areas can be using this. Now we have to see that when the mine let's say the water from groundwater which is coming into the mine can be separately stored into some, let's say, other area. It should not be mixing with the complete thing. And then finally the quality can be maintained, and then quality which has been checked, which is seemed to be okay for various purposes, that can be let's say utilized without any problem, because anyway the water demand is already there into the thing. Yeah, good. So this gives all the conclusions which are there. This was a big project. I think it's a very big report. A part of that report is being presented here. However, it covered various other facets which are there. Due to paucity of time, I think I must be stopping here. So thank you very much for giving chance me for this particular, sharing this particular very important project which has been conducted for quantification in coal mines. Thank you very much.
Thanks very much for the concerning the time. We can have one question, actually. Quick question.
Yeah. There is some kind of now CFD kind of a flow characteristics of the region, how it is getting charged and how it is getting depleted. That is how the water is flowing, that water region.
Yeah.
You have done that?
Yes, I've done.
Okay. Good.
Thank you. The next paper is paper ID number 48, CO2 injection related paper. So any author?
She's coming. This one, no?
8 minutes to cover your paper.
Okay. Thank you. No, I am comfortable. Good morning, respected chairperson, co-chairperson, and all the members present in this hall. I am Iptisha Raul. I work as a project associate in CSIR, Simpar, Dhanbad. Today the first author of this paper is not available, so I am going to present this paper. The name of this paper is CO2 injection driven softening of deep coal seams, behavior, mechanisms and slurry recovery through surface pumping. So here I am presenting a wild concept which is still a very early stage of development, and few scientists and research scholars are working in this concept, and right now we don't have any pilot or field scale demonstration of this concept. The core of this concept is when we gradually inject CO2 in coal seam, after a time it gets saturated in the coal seam. Due to higher kinetic energy of CO2 and its affinity to interact with the pores of the coal, it soils the pores of coal, not only in volumetric scale but also in bulk scale. Also this CO2 soften the coal. When we inject this CO2, it also softens the coal. Now the key question that we are addressing is what are the kinetic parameters and controlling factor during the injection of CO2 so that we can soften the coal, make it slurry and pump it to the surface. Now coming to the Indian scenario, the 2/3% of the proven coal resources are still present in deeper still present deeper into the earth. So we need, this is impossible to extract those coal through the conventional mining. So we have to think alternative way to extract those coal. Now, why are we interested to inject CO2? So, as I said earlier, that CO2, the presence of CO2 can soil the coal, pore of the coal, and it help to create micro cracks in the coal seam. Along with it, create new fracture system within the coal seam. Also, when CO2 dissolve with the water, it forms carbonic acid, which also dissolve the clay minerals and carbonate minerals. In India, the Gondwana coals contain clay-rich minerals, so this process is sensitive to those coal. Now, the important part of our study is the supercritical CO2 saturation. The supercritical CO2 is a phase of CO2 where it flows like a gas but penetrate or dissolve like a fluid. So when we inject supercritical CO2, the absorption power of CO2 increase within the coal. Therefore, the stress distributing all the stress also, like when we injecting this supercritical CO2 in coal seam, it's creating lot of fracture. So stress also redistributing within the coal seam. Now this supercritical CO2 also lower the gas transition temperature, making coal more ductile, and it also help to accelerate the reaction between the carbonic acid and clay mineral present in the coal. Now the experimental studies suggest that the presence of supercritical CO2 can reduce the uniaxial compressive strain and Young modulus up to the 70%, which is very good for slurry formation. Now the question is, at what extent we have to weaken the coal so that we can make a slurry and pump it out on the surface. So the experimental studies suggest that the uniaxial compressive stress between 1 to 2 MPa, and if we reduce the Young modulus 40 to 70%, then we can get a particle size of coal which is 50 to 500 micrometer, which is suitable for slurry making and pumping and suspension. Now, of course, geology also play an important role. A few of these is roof and floor lithology. So we need a impermeable roof and floor rock so that CO2 leakage does not occur, and also depth, pressure and temperature also plays an important role, that how CO2 will behave within the coal seam. Then also water also play an important role. So we need saturated coal seam, not oversaturated coal seam. So those point we have to take a note. Then the major drawback of this concept is the subsidence. So when we injecting CO2 during the softening process, subsidence can occur. The factors like permeability, soiling, then roof competence, then seam thickness, confining pressure, degree of mechanical softening, those factors affect the degree of mechanical softening and stress distribution within the coal seam. So we can mitigate the subsidence through real-time monitoring. Now, in India, Gondwana coal basins like Jharia, then Raniganj, Bokaro, Talchi, Sohagpur, Wardha, those coal basins contain thick, deep-seated coal. which are suitable for CO2 injection, and those coals are mostly bituminous, then they contain high in vitrinite, then with medium and reactive inorganic component, making them highly suitable for CO2 absorption and swelling. Now, I discussed those points in earlier slide, so I want to conclude my PPT with a note that through this concept, we can reimagine that CO2 is not a waste. We can use as a tool to extract the coal which are not mineable through the conventional mining. Thank you everyone for your patience. Thank you.
Thank you. Anyone having any question on this paper?
No, sir. No, sir. Right now.
This is only theoretical. I don't think any roof will be permeable, roof and floor will be permeable to sustain these gases, CO2 gas. I am doubtful. I am working in coal mines from last 36 years. And in Jharia also. I worked in Jharia and Nagpur. But this is hypothetical. Oh,
yes, sir.
Yes, but no roof, floor and your roof both cannot be so permeable that this CO2 will be contained there itself in the coal seam. I am doubtful. Okay, however, okay, thank you.
I think you both can have a discussion during the lunch time. Anyone? Oh, okay. So we can move to the next paper.
So the next paper is paper number 53, and Anurag will be presenting.
He's there.
Okay, great. So you have again 8 minutes.
फोल्डर में होगा ना? ये नहीं, वो भी नहीं है, इसमें डाला है, इसमें डायरेक्ट कॉपी कर दिया क्या? You want to use the dice? You can have the comfortable here. Yeah.
Good morning, everyone. My name is Anurag, and I'm an ACSR research scholar working at CSIR Simfer. The topic that I will be presenting is towards sustainable resource development, managing environmental and operational issues in high sulfur lignite deposits of Saurashtra Basin. The objectives of my study is evaluation of the depositional condition of high sulfur coal lignite deposits, investigation on source of high sulfur content in coal and lignite deposits, origin and distribution of different forms of sulfur present in coal and lignites, risk assessment for utilization of high sulfur content lignites due to emission of pollutants like SOx, arsenic, lead, etc., which pose environmental as well as public health risk. Then we will be also discussing about the options of effective desulfurization methods for the studied lignites and option for sulfur extraction use, as sulfur is an essential raw material in various industries. This is a geological map of the Saurashtra Basin, where my basic two mines are Surkha mine and lignite Katsalia. And as per lithology, you can see that majority of the area is overlain by Deccan Trap, which is a key source of sulfur, as sulfur leaches from these Deccan Traps into lignite seams. As we know that coal is a heterogeneous sedimentary rock, although it is mostly composed of organic matter, natural, but also has inorganic mineral matter. Sulfur is also a common constituent of coal, but unlike other mineral matters, it does not affect the rank of coal. it occurs in different amounts in coal, and on the basis of these amounts, we term high sulfur coal when it is more than 1%, and when it is less than 1%, we name it as low sulfur coal. There are basically 3 different types of sulfur in coal, which we characterize as sulfate sulfur, pyritic sulfur, and organic sulfur. These needs to be identified for better utilization of coal and reduce environmental hazards in mining areas, surrounding water bodies and power plants. Sulfur accumulation in coal starts at P stage, passes through diagenic stage, and ends ultimately at metamorphic stage. In coal, sulfur exists in organic and inorganic form. The inorganic forms are usually sulfides and pyrite being the most common inorganic contaminants, and organic sulfur are mainly composed of aromatic and aliphatic thiols. This is a field sample. As you can see, the latches of pyrite being present in coal samples. This is a study that we did on a basis of proximate, ultimate, and GCV. The proximate data are with lignites. As you can see, it is high in moisture, volatile matter, but it has less in ash content. The factor is that in some of our samples, the sulfur percent was as high as up to 9%. Then we did a petrographical study. As you can see, these are massive forms of pyrite, which indicates that it was accumulated after deposition condition. And we also have framboidal pyrites, which indicates marine influence and syngenetic deposition of sulfur. When we visited the mine, we didn't have to wait for the geochemical results. The problem was staring at us. As you can see, the pyrite nodules are present there, and in open condition, these pyrite nodules reacts with oxygen and releases sulfur dioxides. There are also some problems with spontaneous combustion, and to avoid that, they used to sprinkle water, which resulted in leaching of sulfuric acid, which was accumulating around the water bodies and whatever dip condition that were suitable, which resulted in water contamination, acid mine drainage. And there is, when you visit Surkha mine, there is a basic notice that they say that wherever water is accumulated, don't use it for cleaning purposes, as it might be highly acidic. We have talked about various chemical process, physical process, and biological process, such as using of Acidiophyllus peroxidians bacteria to remove sulfur. But in reality, what we see that they are manually separating pyrite nodules, which were being transported to power plants instead of using any scientific method. And these pyrite separated nodules were also not kept under any cover. They were exposed as and when these exposed pyrite nodules, then they again react with oxygen and water, and same problem of sulfur leaching as well as sulfur dioxide emission in atmosphere is happening. And to conclude, sulfur in lignite occurs in organic forms of sulfate. Sulfur is being a notorious corrosive agent. It also affects mining equipments and machinery, and also has a degrading effect on boilers of thermal plants, which results in higher operational cost and overall affecting the economics of mining activity. Adequate desulfurization methods should be employed to tackle these issues, for which knowledge of source of sulfur and depositional condition of coal in lignite is a must, and accordingly suitable methods can be utilized. Innovation in sulfur management is crucial for coal utilization and supporting India's net zero emission goal. India also doesn't have a native sulfur source of its own and depends heavily on imports for its domestic use. If an effective sulfur extraction method is employed, which can reduce India's foreign reserves and import costs. This study is also useful because after decades of China being the top SO2 emission, now India has surpassed China and is the leading SO2 emission in the world. So this thorough study is required on this topic. Thank you.
Thanks very much. This is an interesting concept, actually. We have time for a few questions. If no one have questions, I have questions. Okay. That's a really interesting concept. So currently in the mines, are they using some sulfide management?
Yes, ma'am. They are using manual separation of pyrite, and they were actually boasting of this method that this is creating employment opportunity.
Okay. Are they using some carbonates?
No, ma'am. This is only manually they are separating pyrite nodules from the belt, and that is also if they could have kept it under some cover, but no, it is exposed in open pits in there.
Yeah, actually, this sulfuric acid problem is a big problem. Even though it's separated, still you have the problem of managing the sulfur, right?
Yes.
Thank you. Yeah.
Thank you, Anurag, for covering your paper well within the time. Now we have next paper on topic integrated carbon footprints, sequestration and credit assessment in open cast mining by Pranav Mishal et al.
Yeah. Can we have slides? Hello everyone, I am Pranav Misal. Thanks for giving me the opportunity to present myself and my paper here. It is integrated carbon footprint, sequestration and credit assessment in open cast coal mines. Okay, so coming to the part, actually when we see in an open cast coal mines, there are means like scope 1, scope 2 and scope 3 emissions there. So I am limited with scope 1 and scope 2 emissions. Scope 1 is a direct emission, which is like fugitive emissions and the emissions done by the diesel. Okay, and scope 2 emissions, which I have considered is the electricity, the power which we have taken outside, like from power plants. So I have calculated them both. So when we do mining, okay, so there is a lot of disruption of a land which happens within the mine. Okay, so like I have considered an hypothetical mine which has a total area of 1400 of hectares, which has 90 million tons of reserves. Then the stripping ratio is 8.98 and the total life cycle is 33 years. So like we should consider like 2 years of like starting period, then 29 years of production period and 2 years of the closure period. So once I was like studying on this part, so I got to know that the major emission which is happening within the mine is the fugitive emissions. Fugitive emissions are those emissions like we say like CH4 or other gases which are like emitted from the coal seam. So those are the fugitive emissions. Again, the diesel consumption which we use in our mine, like for HEMM and all other things. So diesel consumption, and again the scope 2 emissions, which is an electricity which has been like introduced from power plants itself. So the 72% of part is from fugitive emission, which is like a very big what we say emissions in our study. So what I have introduced is sequestration. So actually once I was studying, so I got to know that the total dry mass which has been collected, dry biomass which will be we collect, so that is the total carbon equivalent what we are collecting. Okay, So what I have introduced is like we should plant a sapling, then to the maturity period, which is the maximum absorption period, till that time we should keep that plant, and post that we should harvest that plant. Like we have 33 years of mine life, so within that mine life, like 2 times, 3 times, whatever the maturity period is, so we can plant that tree and we should harvest that tree. So what happened is, what my study says is, as per IPCC guidelines, it says that it is 0.47% of your dry mass which you have been collected. So what I have introduced is harvesting. So it is the total weight of the plant, the dry mass. We should harvest that, and it can be used for commercial purpose like timber, wood, whatever it might be. Okay. So these are 7 species which I have introduced, like bamboo, teak, sal, then neem, mahogany, eucalyptus. So, and the harvesting cycle for 33 years. Okay. So we can plant bamboos for 4 times within that 33 years of cycle. Then harvesting 2 cycles for teak, for 4 cycles for sal. Like they have their maturity period. What I wanted to introduce is like the total mass gain. Like I want to give an example. If there is a child, it grows till 12 years, 15 years, or 20 years at max. It gets its highest biomass till its maturity period, like 18 years or 20 years. The same is with the trees. So once they have gained their biomass, which is the peak time, like increasing period of biomass, so they used to collect that biomass, and once it has been done, we should harvest that, and that is how we are collecting the biomass, and that is how the CO2 equivalent credits have been collected. So this is the whole concept of my study. Then coming to that study, within that 1400 hectares, like post closure and before closure, like I have planted the trees, and I was able to generate 9.26 million tons of CO2 equivalent carbon credits. So if you see, within my mine, it was 2.73 million tons of emission of CO2 equivalent from my mine, from which I have collected 9.26 million tons of CO2 equivalent by harvesting cycles of that, the plantation which I have done, that rotary harvesting cycles, and the net surplus is 6.53 million tons, which is the net surplus. So if we see that this 6.53 million tons of surplus biomass that we can sell in the market, that is the first profitability thing. Again, the next thing is what we say, the carbon credits which we have generated. So it should be verified from ISO 14064 verification, which is an audit for performance. Like this gives you the carbon credits. Again, to verify that carbon credits, and we can sell those carbon credits as well. So this is the whole concept of my paper. So I would like the questions from you. Yeah, please.
As you said, that CH4 emission is maximum from the mining activity.
Right.
So just I want to know which plant can absorb the CH4.
So no, actually what happens is when you came to carbon credits, it is equivalent.
That I know. Just I want to know which plant can absorb CH4. Is there any species which can absorb?
No, sir.
That's all. Thank you.
So just to clarify this thing, we are talking about carbon dioxide equivalent thing.
It is a different thing.
Yeah.
As you said, you can grow the different kind of plants. So CH4 emission is there, and that cannot be absorbed.
Right, sir.
Then what is the use?
So actually my focus is on carbon dioxide equivalent.
That you should say, that you should say.
Right.
Thank you.
Anyone else having any question on it?
What about the oxygen that those plant provides us?
So actually we are looking on carbon dioxide carbon dioxide sequestration. So ultimately, if carbon dioxide gets sequestrated, then the percentage of oxygen will automatically increase in the atmosphere. If he finds that, like, we consider this room, if like 0.5% of carbon dioxide is there and we plant a tree and like we harvest that, so the carbon dioxide is sequestrated, na sir? So the percentage of oxygen get automatically increased. So that is how it will work.
No, but my question is the growing plant and already matured plant. What about the oxygen providing capacity?
So it requires studies. I have not.
Okay. Thank you very much.
Actually, a related question. Usually in mining sites, you cannot plant all these trees, and everything is dependent on the ecosystem, you know. And you may be introducing bamboo, but it may be, let's say, a species that is killing the others, you know. So these hypothetical studies, yes, those are really good. Everything is dependent on the site, and also if you consider the social aspects of these practices, people may not be happy with that production. So as a mining company, you need to consider all these constraints.
Right, ma'am.
Yeah, so I just want to know how you can consider all these in your calculations.
So, ma'am, this all plantation is within the leasehold area, the leasehold boundary which I have got from Ministry of Coal or Ministry of Mines for the mining. Okay, so the leftover part, like within that boundary, so if we utilize that part and we do cyclic plantation and harvesting on that part, so we can do this thing.
My question is, did you ask the local people? Will they be happy for that? And did you talk to ecologists, flora, fauna? Will these species make the flora, fauna still stable? You know, those are really interesting but essential considerations while you are calculating it. Technically, implementing all these things are really easy, but recently all mining companies, we mining engineers, are considering these as the constraints of the future. That's what I wanted to deliver this to your attention.
Right.
Thank you.
Patnai, I have one question here. Have you any effect on the mineralization of the Ajadiyatra indica as well as Arjuna terminalia? Suppose you are planting on that particular area where, and what effect will occur with the CO2 and other GHG emissions?
So, sir, could you please repeat the question, sir?
My question is that suppose any plant you are planting on that particular area, and that one is the neem, Ajadiratra indica, you have shown inside that, and other is the Arjuna terminalia. So, what effect on the mineralizations on that particular plants or the saplings? Suppose the plant is going to be older and older, okay, and this will goes up to the 50-year-old, and from the beginning, from the start of the plant growing, then what effect have you read the performance on that mineralizations?
No, sir.
Thanks very much. We also take to. Okay. Oh, you can continue discussion. Thanks for the audience asking these interesting questions. So the next paper.
Thank you very much. Thank you.
Is paper 65, and the presenter is Silo Kumar Ramteke.
हो गया
co-session chair. I am Silav Kumar Amteke, working mining professional and alumni of VNIT. My topic is coal mine methane recovery, pathway to safety, clean energy resources and climate resilience. My co-author of this paper is Dr. Ritesh Lokhande, who is also a conference chair, and Dr. Vinod Atmaram Mende from Simfer. Actually, coal mine methane known to miners since over 200 years. Due to a methane layering occur during mining operations, it causes disastrous mines accidents. In the past, more than 45 disasters occurred due to methane explosion in mines. In every year, China lost the 5,000 to 6,000 people died in every year in China due to methane explosion. So recovery of methane during mining of coal seam is called coal mine methane. Methane emission during underground mining is a major safety hazard as it forms explosive mixtures. When it concentrate come in range of 5 to 15% in UG mines. Recovery of methane from coal seam makes mining activity safer from any possible explosion in underground mines. Methane is a clean source. Methane it is a potent greenhouse gas and it has 25 times warming potential compared to CO2. The vegetable matters disintegrate into peat, lignite and bituminous. Due to volatile matter and water presence in the vegetable matter, it disintegrates into CH4. Operating coal mines can be made self-sufficient for energy requirement, installing methane-based electric generator. Actually, in India, there are very less degree 2 and degree 3 gassy mine have been declared. CMM recovery scope and prospect in India. India is the world's second largest coal producing country and has a strong potential to utilize CMM as a safety measures, energy resources and climate solution. Coal mine degree 2, DGMS has classified the mines as degree 1, degree 2 and degree 3 depending upon the gassiness of coal seam. Coal mine degree 1 and degree 2 in Jharkhand, West Bengal, Chhattisgarh contain large amount of methane in the form of CMM. India's CBM potential is significant, with methane stored in coal seam capable of supplementing limited domestic natural gas supplies. Commercial CBM production has begun, notably in Raniganj, Jharia, Bokaro, Karnapura and Sohagpur coalfield and other blocks created by ONGC, SR, GECL, Reliance and other Eastern India. Methane released during active mining operations remain largely unutilized, contribute sustainability to the fugitive emission. Large-scale CMM utilization could replace part of important natural gas, potentially saving hundreds of millions of dollars annually and improving safety security. It can also generate carbon credit. Up to 35% of the India's CMM emission could be mitigated by 2030. It is the mission of Ministry of Coal. Key challenges include low methane concentration, limited infrastructure, high upfront cost and regulatory barriers, which have restricted project to pilot stages. Supportive policies, CBM blocks, solution actions, advanced recovery technique and DGMS safety regulation can help transform CMM from a hazard into a valuable energy resources. It can also provide energy security to the nation. Then CMM recovery potential, coal mines and block in India. There are 3 collieries in Dharia coalfield, 4 collieries in Dharia coalfield, Murre Dia, Amal Dia, Sudam Dia and Central Bharatpur colliery, which is having CMM resources of 4.98 billion cubic meter in Dharia, 0.76 billion cubic meter in Amlabad colliery, 0.8 cubic meter in Sudam Dia and 5.31 billion cubic meter in Central Parvatpur colliery. Also in Raniganj coalfield, in Kalidaspur colliery, Gusak colliery, and then in Munidi and in Putki Baliyari also. Underground coal mines by degree of gasiness across various states and districts in India. The degree 1 DGMS, as per classification of DGMS, degree 1 gases which emit less than 1 meter cube methane per ton of coal produced. A degree 2 emission rate is 1 to 10 cubic meter per ton of coal produced, and degree 3 mines more than 10 cubic meter per ton emission rate per ton of coal produced. We have identified 70 degree 2 mines, out of which in Jharkhand state, Dhanbad, Hazaribagh, Ranchi, Bokaro and Chatra, Ramgarh, there are 19 degree 2 mines and 3 degree 3 mines. In Jammu Kashmir, Rajouri, there is 1 degree 2 mines. In Madhya Pradesh, Betul, Chhindwara, Sardol, Umaria and Anupur, there are 9 degree 2 mines. Orissa 2 degree 2, and in West Bengal there are 39 degree 2 and 3 degree 3 mines. The global scenario of CMM recovery. Global leaders in CMM recovery includes the United States, Australia, Russia and several European countries. United States pioneer CMM commercialization supported by strong regulatory market incentive and technology invention. Methane is widely used for power generation, heating and pipeline injection. In China, China represents the largest and fastest growing CMM market with strong government mandate and subsidies. It hosts a highest number of operational projects worldwide. It hosts around 84 projects. As of 2024, about 254 CMM projects operate globally, mainly involving drain gas recovery, with China 84, US 54 and Australia 26 leading deployment. CMM and abandoned mine methane project deliver major climate benefit, avoiding over 3 billion cubic meter of methane annually, equivalent to more than 55 million ton of CO2 emission. Europe and Australia focus on mine safety, energy transition, while developing economics, India, South Africa, Indonesia, Latin America are emerging markets supported by climate finance and technology transfer. The method of CMM recovery during coal mining, the figure illustrates that there are pre-drainage before mining, cross-major drainage and gobe gas. The pre-drainage involves extracting methane from coal seam before the mining operation begins. Cross-major drainage, the method capture methane during active mining by drilling holes, and we can recover methane through gobes also in subsidized area. The captive assessment of CMM recovery, that is pre-mining, it is high methane concentration, about 80 to 95%. The ventilation air methane, it has very low. it uses use of oxidation technology like RTO and catalytic oxidation. Then there is medium methane concentration is GOP gas recovery. The geological aspect of CMM recovery is depending upon the coal rank, that is coal seam thickness, depth of coal seam. The higher is the depth, the methane occurrence is more. Then clit system, well-developed faces and birds clit, enhance permeability and allow easier gas flow. Then permeability, porosity, gas content, structural features, roof and floor lithology, hydrogeological condition, and in situ stress conditions. Then operational features are the panel dimension, larger longwall panel, seam depth, mining height, and higher coal production, rate of coal production. CMM resources and reserve estimation. The table shows this total reserve estimate is about 18.27 billion cubic meter in India. This is the demonstrated pilot project successfully demonstrated by SIMFER, CMPDL and BCCL at Munidi, which generate electricity power to supply to the mine colony. And in summary, the methane from coal mining is a serious safety hazard and a powerful greenhouse gas contributing to explosion risk and climate change. CMM recovery captures and utilizes methane before, during or after mining, converting into a clean energy resources. Key recovery methods include pre-mining drainage, GOP gas extraction, and methane capture from abandoned and sealed mines. CMM projects significantly improve the mine safety, reduce explosion risk, and enhance underground working condition. Record methane support climate mitigation and economic benefits, including energy generation, reduce fossil fuel dependence, and also it generates carbon credits. India has high CMM potential in coalfields such as Jharia, Raniganj, and Bokaro, and expanding recovery can transfer hazardous emission into a strategic energy and climate asset. Thank you.
Thank you, Ramtekji. We can have a short question as we are running short of time. So only one question will be allowed.
Sir, very basic question I have today, that at the very beginning of the presentation, sir told us that CO2 and methane, methane has the potential of, global warming 21 times more than CO2. So will you please elaborate that?
Actually, methane is 28 to 30 times 30 metric tons equivalent to CO2 emission. So when we reduce the emission of methane, we can generate 28 times carbon credit than CO2. Actually, CO2 can be synced, but methane cannot be synced. Due to covalent bond of methane, it takes 10 to 100 years to disintegrate the methane molecule.
Okay,
Yes,
that's all.
thank you.
We will move to the next presenter.
Thank you.
On the topic sustainability and sustainable development mining, a review of framework, gaps and future directions. I request the presenter to kindly limit his presentation to the maximum 8 minutes, as we have to include one additional paper in the session. Any presenter available? Okay.
Okay, good afternoon, everyone. I am Sarita Patel. I am a third-year mining engineering student at NIT Raipur. Today, I am going to present our paper on the topic Sustainability and Sustainable Development in Mining, a review of frameworks, gaps, and future directions. As we all know, mining plays a very crucial role in economic development, employment generation, and industrial growth. The mining sector supports regional development and technological advancement. At the same time, mining activities interact with environmental systems, land use, water resources, and community livelihoods. So, sustainable development in mining doesn't focus on restricting mining. It focuses on improving efficiency, planning, and integration across the mining life cycle. So, a range of sustainability frameworks are available to guide mining development. In practice, these are applied based on the project context and priorities. Today, environmental and economic aspects are more commonly addressed, while social integration and ecosystem services can be further strengthened. So, integration of all these sustainability frameworks will lead us to improvement of long-term mining outcomes. The aim of our study was to review sustainability frameworks to understand the interconnected pillars of sustainability and identify the areas of improvement and long-term development. We adopted a structured literature review approach, and our sources included peer-reviewed papers, reports, and books related to sustainable development in mining and sustainability. So, the concept of sustainable development was framed or formally considered by the Brundtland Report in 1987, which defined sustainable development as the development that meets the need of present without compromising the ability of the future generations to meet their own needs. So, this definition emphasizes on intergenerational equity and long-term responsibility. It recognizes environmental limits along with acknowledging the economic growth. So, this slide shows you the three pillars of sustainability, which must be balanced and integrated. And as you can see, the three pillars are social sustainability, environmental sustainability, and economic sustainability. A true sustainability can be achieved when all these three pillars can be interconnected and addressed at the same time rather than addressing each of them alone. This slide shows you an IPAD equation which is formed by Paul Ehrlich and John Holren, which gives you an idea like environmental impacts are shown as the product of population, affluence, and technology. Nowadays, the population growth and the rising consumption has led to the increase in demand for mineral resources, and technological efficiency plays a key role in reducing environmental impact per unit of consumption. So, this framework highlights the importance of integrating technology, efficiency, and sustainable planning to have the most of the outcomes from mining. Mining also contributes to socio-economic development through employment, income generation, employment, and infrastructure development. The CSR, or the corporate social responsibility, that provides a structured approach to strengthen this socio-economic outcomes. So the CSR framework includes the stakeholder engagement, impact assessment, mitigation planning, and the implementation, monitoring, and transparency in the reporting can lead you to enhance accountability and long-term effectiveness. So this slide shows you how ecosystem services impact pathways in mining. Ecosystem services are the benefits that are provided by the ecosystem to support human well-being. Mining activities interact with multiple ecosystem categories, and these service categories includes provisioning services, regulating services, cultural services, and supporting services. So understanding these interactions, as you can see that mining activities can lead to direct and indirect impact on the ecosystem, which in turn lead us to ecosystem service disruptions, and next leads to human well-being impacts. So if you will understand the interactions properly, so we can mitigate them, and we can lead to rehabilitation efficiency. This slide shows you the alignment of mining and the Sustainable Development Goals. The Sustainable Development Goals formed by the United Nations gives you an integrating framework for environmental, social, and economic objectives. Mining contributes to SDGs through employment, infrastructure, and mineral supply. Aligning mining sustainability frameworks with the SDGs strengthens long-term development outcomes in mining. In conclusion, sustainable mining will benefit greatly with the integrated frameworks rather than isolated technical measures. So, strengthening the planning across the mining life cycle will improve the environmental, social, and the economic outcomes. We found that the key areas for further strengthening include the mine closure planning, ecosystem services, integration, and long-term livelihood transitions. So addressing these areas is a concern for us, and we should focus on it. Currently, nowadays, many of the sustainability frameworks in mining are commonly aligned with a weak sustainability assumption, which allows for the trade-off between the environmental and the economic objectives. So advancing towards a stronger sustainability approach will emphasize the ecological limits and the long-term ecosystem resilience in mining. Here are some of the references which we used during our project. Thank you. Thank you for your attention. I'll be happy to have questions.
Okay, thank you. Limiting your presentation well within the time. So we can have one question. Anyone? Oh, thank you. So moving to the next paper, paper ID number 90, related to a critical appraisal of mineral resources of Gadchiroli district, very close to this place. What's the name of the presenter? Okay, thank you.
Hello. Good afternoon, everyone. Firstly, let me introduce myself. I'm Dr. Rishi Sharma. I'm currently working as assistant professor in Department of Mining Engineering, UIT Gadchiroli. What we are doing is we are training tribal kids to be mining graduates so they can join mainstream and contribute to the mining industry. So firstly, let me introduce why we choose this topic to present over here. Firstly, as we already know, Gadchiroli is a long-term hit region with the Naxalism. So right now it is coming up and mining activity is being booming in the region. So we have chosen this topic just to highlight how and what is going on in the Gadchiroli region regarding the mining activity and how these districts that is very mineral rich can contribute to the Maharashtra to become a $1 trillion economy. Now, moving on. So firstly, the introduction. This district is situated in the easternmost part of Maharashtra and is bordered with the Chhattisgarh and Rajnandgaon district and Bastar, and it has a boundary with Telangana, Adilabad and Karimnagar region, and geology rich in ancient craton rocks and history of deformation and magnetism. In case of mineralization, it is a home for hematite and BHQ, and other resources which are present in the region are granite, limestone, laterite, and limonite. Now, moving on to the next slide, it is a major attraction for the industry, for the mining industry basically, for the investment, and it has a resource potential for the large-scale extraction and steel production. Economic impact: establishing steel and allied industries can be established over there because of its mineral rich background. Now, socio-economic impact: due to the arrival of mining industry, it can provide employment to the many people that are not in the mainstream in the region because of this long-term history. Now, moving on to the next slide. In the CSR activities and sustainable mining, corporate social responsibility, many educational institutions have been established by the Lloyds. First example is the UIT Gadchiroli, and healthcare facility like one hospitals, they have established Lloyds medal there for the treatment of the locals, and many small scale industries for the local people they have established to generate employment for the local people. Now, impact of mining industry: it is improving the life quality there, and growth of mining and allied industries have been happening because of the coming of the mining industry there. Environmental impact: due to the coming of the mining industry, there are environmental impact also. So there is a need for sustainable mining, like with the use of fossil fuels, over beneficiation plant activities, tailing waste recovered, and mineral processing plants and manufacturing activities. All these activities generate environmental impact on the environment. To counter these, sustainable mining practices are important. For that, solar power, use of solar power in our many mining operations, use of captive power plants like Lloyds in their pellet plant, they have installed captive power plants where they are using waste heat recovered from the stack kilns to heat water and produce electricity out of them. They are majorly using electric vehicles for their major mining operations, so environment have less impact. Mine reclamation activities they are also using very aggressively. And now major minerals that is present in the area that can contribute to the economy are hematite and BHQ. In this, firstly, is it can contribute in the steel production. Cast iron, sponge iron, and agglomerates are also being made from the fines that is being produced in the iron ore mining. Now, this can be used in the steel utilization that can be further empower our automobile industry, construction industry, and helps us bridges, railroad, etc. infrastructures. Now, there is another important mineral that is tungsten that is present here. It is quite a hard mineral. When it is alloyed with the carbon, tungsten carbide helps in making of drilling tools and drilling bits for major coal cutting machinery in mining industry. It can also be used in semiconductor chips. Now, silica. Silica is another important waste that is being generated from the BHQ, that is banded hematite quartzite, that can be used in the paint and coating industry, in construction industry, foundry, and casting. Now, limestone is also another mineral that can be used, which can help establishing cement industry in the Gadchiroli region. Now, moving on to the mining activity that is going on in the area. What is exactly going on there? Now, mineral resource potential of Damkod, Wadbi, and Surajgarh Hill Range deposits are nearly 8,350 tons, out of which 2,000 million ton is pure hematite that can be extracted, and 6,350 million tons is the BHQ, that is banded hematite quartzite, which can be extracted. This can establish Gadchiroli as a major potential steel and the mining hub. Now, it can help us producing in the mining industry, steel industry, cement industry, and construction industry. All these industries can be benefited from these resources. Now, what is the role Lloyds and Metal Energy is playing in the region? It is basically operating Surajgarh iron ore mine currently, which has a production capacity. It can produce up to 55 million ton per annum, but right now they are targeting a direct shipping or target of 26 million ton, out of which 10 million ton is hematite and 45 million ton is the BHQ. From BHQ, after processing, the total is the target of 26 million ton direct shipping ore they want to produce from there. Now, what are the environmental friendly initiatives that Lloyds Metals is taking, which will help the region to grow, but in the sustainable mining way? We don't want to ruin the environment of the area. So for that, they have established a slurry pipeline for ore transportation from their iron ore grinding plant to their pellet plant, which will help us to reduce the carbon footprint, as it will reduce the uses of vehicles and other transportation methods. They are using major electric machinery. All their machinery is electrical. They have been using excavators. Big heavy earth moving machineries are also electrical there that they are using to reduce their carbon footprint. They have established captive power plants, as I have already told you, to use the waste heat produced from the pellet plants and use it to produce electricity. Now moving on to the next slide, mining of low-grade BHQ, that is banded hematite quartzite, because mining of low-grade BHQ should be such that we can increase the iron content of the ores in the mineral processing plant, so it can be sell profitably. So due to the presence of such iron ore in large quantity in the area, when we performed elemental analysis of BHQ, so silica weights that was present is 46.5 weight percent. That was quite high, and mining activity is quite damaging to environment, as we already know, but this waste caused another problem for waste utilization. So such waste can also be utilized for the road, glass industry, and other road construction, glass industry, and in semiconductor industry also such silica waste can be utilized. Now application of advanced mining processing techniques. Lloyd Metals have indigenously developed advanced mineral processing techniques for the beneficiation of the low-grade BHQ ores, so it can yield the product yield of 34 to 36% with 65 to 67% of Fe concentrate. Now, sustainable mining practices that have been going on in the area. Firstly, challenges that have been faced by the mining industry is extracting our ore profitably at a low cost, and there is a large volatility in the market due to the uncertain and unpredictable world. So, simultaneously, they have to reduce their carbon emission to meet our 2047 net carbon zero target of our government. Now, the use of renewable energy for achieving this, they are using electrical vehicles and other renewable form of energy for decarbonization, optimization of operational cost, and infrastructure and techno-economic barrier, like implementing smart mining and technological improvement in the mining, but at the same time taking care of the economics of the operation, because in the end it's a business, so it should be profitable. Now implementation in the mining industry, how they are implementing and what they are doing there. Firstly, they are using autonomous haulage vehicles, battery electric vehicles in remote mine areas. They are converging their electric combustion engines into electric vehicles. And Lloyd Metals are also using fully electric vehicles. They are using slurry pipelines for ore transportation, captive plants and power plants. Now, moving on to the next slide, they have established 89-kilometer long slurry pipeline from iron ore grinding plant to the terminal station at Konsari plant, which is equipped with the supervisory control and data acquisition system, which can monitor real-time our slurry pipeline. So it should be it is also corrosion free, and its supply and all parameters can be studied from remotely from their control room. The capacity is 30 million ton iron ore it can transport per day, which can significantly reduce the carbon footprint by using of, as we have eliminated the use of trucks and other purpose to transport our ore. Now, captive power plants, they are using a waste heat produced from the iron ore kilns. That waste heat is about 700 degrees Celsius, which we use to heat water, and they have established 30 megawatt and 4 megawatt plant of captive power plants at Ghugus and Konsari DRI facilities, Lloyds Metals. Now, coming on to the conclusion, these extensive sources of Gadchiroli will help in the indigenization of low-grade beneficiation of techniques, and district mineral wealth includes I have already told you 8,350 million ton of iron ore reserves, indicating substantial economic benefits now, which can be beneficiated to such grade. And these collective portion of Gadchiroli will help it to emerge as the major steel manufacturing hub. Growth of mining and steel industry will foster small scale industries and enhancing revenue generation and employment opportunities. Iron ore resources can generate significant revenue, while silica from beneficiation can be utilized for road, glass, and other ceramic industries. Now, another industry that is coming is the 40,000 crore investment from the ArcelorMittal steel plant, that they will try to establish 6 million ton plant per annum to generate 20,000 employment, and direct or indirect, and project is formalized between the MOU between Mittal and Government of Maharashtra. And another 22,000 crores investment is coming from the companies like Lloyd Metals, Ambuja Cements, JSW, and local construction materials like refractory minerals and other recently discovered 75 million ton tungsten resource will further support Maharashtra's vision of becoming a $1 trillion economy. These are references that we use. Thank you very much.
Thank you. Anyone? We can have one question on this paper.
So a lot of mineral resources are there. That just it's up from your presentation. Your department is working taking any project and doing some work related to that.
Sir, the thing is that currently we are just starting our institute, and we are educating tribal kids to become mining professionals, so they can be employed there and they can join mainstream. As this region was quite backward before, now our college is just establishing. It's just in the first year.
Okay.
It's running from 5 months only.
Okay, good to know. Thank you.
Okay, thank you, sir.
Okay, I have been to this mine just before coming to this place. I visited that Lloyd Still mine, and I really appreciate the management for taking many initiatives which are unique in its nature.
Yes, sir.
Like for the first time they have thought of utilizing BHQ as a resource rather than a waste.
Yes, sir.
And it is taking its shape. So very, thank you.
Thank you, sir. Thank you so much, sir.
Which is paper ID number 84, related to calibration of a ventism network model for mine ventilation.
Mahesh, na?
Yeah, very good morning to all the delegates present over here. So myself, GDN Raju, I am a research scholar in the Department of Mining Engineering, NIT Rourkela. So I am going to talk about calibration of Vensim network model, which is used for ventilation planning. So this is a case study that I am going to present as a part of one of the project we have done for Coal India Limited. So my supervisor, Mahesh Kumar Srivas, is also the author of this paper. So these are all the contents that I am going to explain in my presentation. So from last 2-3 days, we are listening to various topics like rock mechanics, tunneling and all. So the topic that I am going to discuss is somewhat different than what we have seen so far. So I am going to talk about the mine ventilation, which is also a important system for underground mining. So for those of you who are not from mining background, so mine ventilation is a system where we'll provide a fresh air into the underground mining so that it will take out all the gases and heat that is produced in the underground mines. So this ventilation planning is very essential in order to ensure the safety of the workers and to maintain the underground environment healthier and safer, as well as this is required to meet the statutory complements also. So, but nowadays, as we know, most of the shallow deposits are exhausting, and we are going deeper and deeper. And to meet our rising demand, we are deploying heavy earth-moving machinery, heavy capacity machinery also. So, because of all these things, the ventilation system nowadays is becoming very complex, and we are not able to do the actual analysis manually. So this is where Vensim will help us. This is one of the software based on Australia. So where we can visualize and plan the ventilation system of the mines. So in this presentation, I'm going to describe about what we have done and how we have utilized that Vensim planning. So, but the thing is, for any numerical modeling, calibration plays a very important role. Then only we will have the accurate thing. So, coming to methodology in this present study, so first we have visited the mine where we are doing all this planning and all, and we collected all the basic information, what is their ventilation system, how the airflow is going inside the mine. And then we have conducted the PQ survey covering all the airways in the underground mines. And then once we have got all the data from a field investigation, we have developed a VentSim model and we have done some simulation models. So in figure 1, you can see those are the instruments that we have used for doing this field investigation. Most of the mining people, you are well aware of all these things, but those who are not from mining, so just these are the instruments that we have used for measuring air velocity and the pressure drop from one place to another place. So in the figure 2, you can see that is the mine plan. So they have one incline. So the green line that represents the intake airway of that particular mine. So and they have the LVC at this last point. And from here again, the return airway is going through this path, and they have the main mechanical ventilator that is installed there. So as of now, the working is going on here, but very soon they wanted to start working here. They wanted to extend this section towards the downside. So during our field investigation, we have done PQ survey. So this is how the PQ survey will do. So this is point A and point 2. So between these 2 points, we have measured the pressure difference. That is the pressure drop between these 2 points. So by using pitot tubes and piping system, we have measured the pressure drop between those 2 points. And near the doors and air crossing, this is how we have measured the static pressure, and this is how the path of anemometer we have rotated in order to get the quantity of airflow that is moving on that particular area. So once we have all the data, we have developed the VentSim model. So there are different approaches to develop a basic simulation model in VentSim. So, but I'll recommend to import the AutoCAD file, which we can get from the mine itself directly. So that will give the good accurate thing. So once we import, so we have developed the basic network model of that mine, and then after having the basic network model, we have updated the geometry by using the survey data, and then we have calibrated that model using the data that we have actually collected from the mine, so which includes the resistance of the path and the fan data and all. So accordingly, we have run the airflow simulation, and we just compare the actual values what we have measured from the field and what we have getting from the simulation. We have run under different alternatives until we get the satisfactory results. So this is what the model that we obtained from the VentSim model. So as I have shown in the earlier mining plan, so this is where they wanted to start their production soon, and this is where they have now. So this is the model that was developed in the VentSim. So after that, as I said earlier, we have run the different simulation models. So this is their mine model. So earlier I have shown you that their future proposed plan. This is the continuation to that plan. So future they wanted to do the development along the east and west also, and they wanted to extend their working towards downside also. So these are the different alternatives that we have done. So the description of alternative 1, 2, 3, 4 and is also given in the next slide. So in the alternative 1, they wanted to develop the east side facing along with that existing LVC. In 2, they wanted to develop both east and west side sections along with the existing LVC. And in alternative 3, they want to develop only east side. In alternative 4, only west side. In alternative 5, they want to develop east, west and along with the downside section. So these are the results that we got from the simulation model. This is what the desired airflow they need as per the Indian statutory rule, that is at least 2.5 cubic meter per ton of output of man shift. So these are the expected outcome that we got from the simulation results. So in the alternative 1, with the existing condition, they cannot go with this one. But if you see other alternatives, so they may be go with the other alternatives as per their requirement. So these are the results that we got. So from this study, we have successfully calibrated the Vensim network model, and the errors that we got from this model were within the accepted range. That is, we got around 90% of accuracy. And in this study, we have calibrated using the resistance and the pressure drop that we got from the simulated and the measured data. So this model, what we have developed, it was given a reliable performance, so which they can use for running the multiple simulations under different alternatives. And also by using the same model, we have given different alternative suggestion for the mining people, so that they can extend their ventilation network accordingly in their future also. So these are some references that I have used for preparing this PPT. I would like to acknowledge my institute, NIT Rourkela, for supporting me, and also I would like to acknowledge Vensim software people also for providing me with a free education license. So finally, thank you. Here I have given my mail ID along with my professor mail ID. If you have any further queries, you can contact us. And if you want to know more about what we have doing for our research, you can scan that QR code. Thank you.
Thank you very much. Any questions from the audience?
Yeah, I have a question.
Sir.
Vensim, as we have discussed with many people who have been working several years in the ventilation planning, specifically in CMPDL, their thought process is that Vensim overestimates air quantity, and you must have compared what the PQ values you have calculated and what the PQ values have been given by Vensim. Do you have any such experience with the Vensim?
Oh, sorry, actually how we calibrated is, we have developed the basic Vensim network model, and then we have just given the pressure drop. We did not given the quantity for the simulation. We just given the fan parameters, the fan curve, and just we have given the pressure drop. So automatically the quantity will come. Then we have compared the quantity which was given by the Vensim and what we have actually measured in the field. So in that way we have calibrated.
So any comparison with your
yes sir, we got around 92% of accuracy. So generally from the literature it was given that up to, if you get the error of, it is acceptable up to 10%. If you get up to 5, it is very good. In our case we got around 7 to 8% of error. So as per the literature it is acceptable.
Thank you very much. We will continue
thank you.
With the next paper, which is paper number 62, Manoj Kumar.
Good afternoon, Chair, Co-Chair, distinguished in front of me, students from NIT, myself from CMPDI. Take the opportunity to thank the organizer for giving me the opportunity. This paper is about carbon footprint reduction strategy in mine closure planning. I am skipping this one. Coming to the objective of the study, this paper identified the major GHG emission source during the mine closure, delineating from the regular practices, evaluate MPG 25 provisions from a carbon perspective, propose reduction strategy aligned with circular economy. As we know, the mine closure cycle is about progressive mine closure planning, final mine closure plans, and post-mining land use and monitoring. This study starts with the scope formulation, identification of emission sources, mapping these with mandates of Mine Plan Guideline 25, estimation of associated carbon footprint, along with outlining the carbon footprint reduction strategies, developing integrated carbon footprint framework with certain conclusions. Starting with the scope of formulation, this includes developing physical and fixing physical boundary along with a spatial boundary, aligning with the framework of Mine Plan Guideline 25. Next one is the identification of emission sources, identifying GHG hotspots mapping along with high emission, medium or low emission zones, defining the equipments involved in this as per diesel equipment, OB handling with the backfilling, transport, infrastructure dismantling, pumping and wastewater management, security, post-closure monitoring. All as per the para 8.10.1 of mine plan guideline. We have developed different components and tried to develop a matrix as per requirement of 8.10.1 for the various activities like progressive, post-mine closure, which includes dismantling and disposal of mining machineries, safety and security, technical and biological reclamation, post-closure monitoring and supervision, along with sustainability projects. Defining the parametric importance units with along measured magnitudes of GHG emissions for each activities. Continuing with this, about estimation of associated carbon footprint, just general formula, multiplying the activity with the emission factors. We have developed around 75 to 160 empirical relations to establish this mine closure GHG emissions. Strategy includes the reclaim framework, reduce emission at source, using electricity or less GHG emission sources as equipment, circular sources use, land restoration, adaptive reuse, inclusive community transition, that is for the community and by the community, monitor and optimize the resources. Coming with the outline carbon footprint reduction strategies, includes various activities and different operations like operational efficiencies, resource efficiencies, using of renewable resources, nature-based solutions, including various digital interventions, repurposing of land as per mine CISO guidelines of as a reclaim framework, converting dismantled open space into community and renewable energy resources, engage local stakeholders for scrap collections, plantation, and other activities of restoration, recycling and reuse, and optimize work planning. Again, matrix developed for these processes. Carbon reduction strategies. First point is to avoid. If not avoided, then try to reduce by optimized land resource design, reduce rehandling of OB, energy efficient equipment and scheduling, reduce emission at source, enhance circular resource use, that is waste utilization, carbon sink creation through reclamation, ESG integration in mine closure process, just transition perspective, all as per the MPG guideline 25. Then from there, integrated low carbon framework is to be developed that will be based on baseline carbon footprint assessment, low carbon land use planning, green infrastructure integration, resource efficiency interventions, renewable energy deployment, its monitoring, reporting and verification, and again using optimization as per the need-based impact assessment study. This framework outlines the comprehensive approach for the progressive mine closure and the post-mine closure processes, which minimizes emissions, enhances resource efficiency, and maximizes social economic benefits for the local communities, that is for the community and the by the community. Challenges in this process may initiate high initial investments and sustained funding in low carbon technology, infrastructure gaps in remote post-closure site of the coal mines, technical constraints in emission and reduction options. We have to think of that. Technical challenges in methane management, particularly during the post-closure period, dependence on skilled personnel and digital interventions, environmental viability affecting carbon sequestration and reclamation, maintenance and reliability issues, logistics issues, community interface and socio-economic transition.
in the conclusion, key insights regarding priority emission resources. We have to think of complete roadmap of sustainability mine closure to be drawn, repurposing and community-centered transformation. We have to think of carbon retrospective landscape uses. Mine closure can significantly reduce life cycle emissions. Mine plan guideline 25 provides a scope for low carbon innovations, circular economy with reclaim framework, focus on ecological restoration and renewable energy integration. That's all. Thank you.
Any questions? If not, thank you. We will move on with the next speaker. That is paper 74, Pallavi Wankere.
Pallavi Wankere, yeah. Seven.
Hello. Good afternoon, everyone. My name is Pallavi Wankade, currently working as a research fellow at CSIR NEERI Nagpur under the Department of Environmental Sustainability and Green Economy at CSIR NEERI Nagpur. My supervisor is Dr. Hemant Bhirwani. And my topic for the presentation is analysis of carbon footprint and carbon credit in coal mine sector in India using coal mine methane cash flow model. The main objective of this study is to quantify methane as a carbon footprint in terms of CO2 equivalent with the help of IPCC GWP guidelines and estimate carbon credit potential with the help of US EPA coal mine methane cash flow model. The baseline emission data is collected from Global Energy Monitor, Ministry of Power and Ember reports, year 2025. So what is the background and motivation for this study? Now, methane is a potent greenhouse gas after CO2. It has a GWP potential, global warming potential, almost 84 to 86 times of CO2 for 20-year time horizon, and almost 28 to 36 times of CO2 for 100-year time horizon. It has atmospheric lifetime of 12 years. And now in India, we mostly rely on coal for more than 50% of electricity generation. In today's time, there is a rise in electricity demand, and so there is a demand for use of coal, and so it will automatically increase the methane emissions. However, in India, there is a lack of economic and environmental integration for the methane mitigation parameters. If we talk about the coal mine methane emissions across the globe, coal mine methane emits more than natural gas supply chains. Coal mine sector emits around 40 million tons of methane annually. It is a global data obtained from International Energy Agency for the year 2024. If we look into the methane marginal abatement cost curve, any abatement measures would be cost effective if the price of, if we get carbon credits up to USD 20 per ton of CO2 equivalent. So in the mitigation measure, whether it will be flaring, ventilation, air, oxidation, or any kind of mitigation measure would be effective. So talking about coal mine methane emissions in India, India has surface mines as well as underground mines. Almost it is a percentile ratio that I obtained from Global Energy Monitor May 2025 data. 92.92% are surface mines and rest are followed by mixed mines. If we look into the table, surface mines have more emissions comparatively underground mines. Like surface mines has 1,957 million cubic meter cube per year of methane emissions. Now, what exactly is coal mine methane? So it is basically a gas released during coal mining operations, particularly during mining, ventilation, and gas drainage systems. And it mainly contains methane along with CO2, nitrogen, and water vapor. So now talking about our US EPA coal mine methane cash flow model framework. The model framework is very simple. First, we check the methane availability with the monitoring data. Then we go for the technology selection based on the emission percentile, which technology can be selected, like flaring. So in the right section, you can see there are 10 different scenarios mentioned in the US EPA model framework. We can go for cold drying, flaring, enclosed, open. Then we can go for standalone, ventilation, air methane, oxidizer, like that. So depending on the Indian environmental and economic conditions, I have chosen enclosed flaring and open flaring. So then once you selected the particular technology, you can do cash flow forecasting. You will get to know about the CapEx and OpEx values. Then you will get to know how much methane is distracted or utilized with the help of that technology. And at the end, you will get to know about the revenue streams and carbon credits. So these are the model input parameters. Most of the technical parameters are adopted from US EPA CM model defaults and industry best practice guidelines. So enclosed flaring has 15 years of project lifetime and open flaring has 10 years of project lifetime. And we have fusion surface GOP gas drainage for the methane capture. So these are the mitigation scenarios result obtained from open flaring and enclosed flaring. Now, if we compare, enclosed flaring has more carbon credits earned per year, almost 1,0236 tons per year. And also the internal rate of return is higher than open flaring, which is 11.98. And the payback period has also reduced. So it is more financially viable and suitable to Indian conditions. Now, how to obtain carbon credits in India? This is particularly for coal mine owners. Once you have the idea about your project setup and the technology that you want to select, then you go for the registration and approval, get it authorized by Carbon Credit Trading Scheme, authorized by Bureau of Energy Efficiency. Then there is a monitoring and revenue analysis, which is mostly done by third party, like VCS, Gold Standards, American Carbon Registry. And then you can trade in Indian carbon credit market and get your credits issued. Now, what we can conclude that the coal mine methane mitigation is significant for carbon footprint reduction. There is a great economic viability, and there is a huge potential of carbon credit generation. However, in India, we lack the robust carbon credit frameworks like American Carbon Registry Gold Standards or like VCS. So there is a need to establish some carbon credit framework for the Indian carbon credit market. And yes, that's how we can mitigate methane emissions. Thank you.
Any questions? Yep. I'm going to get one question, so we'll take yours.
So what do you mean by open flaring and the closed flaring?
Could you repeat, sir?
What do you mean by open flaring and closed flaring?
So open flaring, it's like openly it will flare. There is no capture of methane outside.
How it can be done? Is it practically possible in the mining?
Yes, sir.
How?
Usually I have taken like almost 1 minute. So if you place 500 meters spacing between gobe gas drainage well at the mining site, you can recover that methane for the inclusion.
After recovered, we can use it. No? It's a fuel.
Yes.
Okay. Second query is, do you have an idea that we have our own emission factors? We are not using the IPCC guidelines for the emission estimates.
Okay.
Because that is a very higher side.
Yes.
Okay. So we have to use our own emission factors for the oil and gas sectors as well as the mining sector.
Yes, sir. There are for every mining and methane emission, there is a particular emission factor listed in the global energy monitor data.
We have listed. We have determined for the open cast underground, and based on the degree of gasiness, we have our own emission factor.
Yes.
It is available on the Ministry of Coal websites.
Yes.
So please go through it.
Yes, sir.
Okay. Thank you.
Thanks very much. We have one last paper, paper number 81, to be presented by Amit Kumar.
So good afternoon all. My name is Amit Kumar Mankar. I am a PhD scholar in the Department of Mining Engineering, IIT Nagpur. So this is my paper title, UAV-enabled framework for critical zone mapping and stability assessment of mine waste dump slopes. So as the energy demand is increasing day by day, which accelerating the production of coal, and with the production demand increasing day by day, which also accelerating the production of OB dumps, and these OB dumps are being dumped internally or externally based on the area of availability, and the internal dumping is one of the sustainable approach in which OB is being dumped inside the mines, and the stability of these dumps is one of the major concern for the mining industry. The reason being, if this slope fails, it may lead to loss of human life and damage to infrastructure and disrupt the mining operations. So, and between 1901 to 2016, there were 23 catastrophic incidents has been taken place, mainly due to slope failures. And the recent one was the Rajmal coal mine in 2016, in which 23 people have lost their life. And this is one of the picture of Rajmal open cast project in India, in which 23 people have lost their life. So this study tries to provide a comprehensive framework for identifying the critical zone in advance so that this type of large catastrophic failures can be prevented in futures. So this is my study area in which the whole study has been carried out, which is the Sonpur Bajari Open Cast project, located in the eastern side of the Raniganj coalfield, West Bengal, India, one of the largest coalfield in the country. This is my methodology, which has been divided into three major phases. First one is the data acquisition, in which two types of data has been acquired. First one is the high resolution images, and the second one is the control points. And the second phase is the pre-processing and 3D reconstruction, and the last is the analysis using numerical modeling software. So in methodology, starts with the image acquisition. So for this study, the images has been acquired using DJI Air 2S drone, having the 20 megapixel of camera, and it is a multi-rotor drone. And the reason why we have selected this multi-rotor drone, because it has a capability to hover at a particular place for capturing the stable images, and it is not possible with the fixed wing drone. And in this study, total 210 number of high resolution images were acquired, and the second parameter during the acquisition which we taken care is the flying time and pattern, in which drone follows a fixed path to cover the area of interest precisely for the acquisition of images. So in this study, the grid flying pattern was used for the acquisition of high resolution images, and the reason why we have chosen the grid flying pattern, because we are able to maintain the overlapping percentage between the images. As you can see, the image in which the red line is the flying pattern, and the red, the black and white box, which is the photogrammetric targets that we have used to place all the area of interest for the collection of ground control points. And in this study, we have chosen the overlapping percentage of 80% of frontal overlap and 60% of side overlap. And in this study, we have used the ground control points for the scaling of the 3D model. So total 7 number of ground control points has been collected with the help of total stations, and all the photogrammetric targets were placed over the whole area of interest. And as you can see, the ground control points has been georeferenced in the 3D model. So point cloud generation and 3D reconstruction. So the purpose of the generation of this 3D point cloud is to get the 3D realistic model of the mine dump slope that further we will use for the numerical modeling for identifying the critical zone. So in the initial stage, we will get the sparse point cloud, and in the second phase, we will get the dense point cloud. So this is our comprehensive workflow. It starts with the image acquisition using the drone for the study. Like I said in my previous slide, that we have used the DJI Air 2S drone having the 20 megapixel of RGB camera, which follows a fixed path for the acquisition of high resolution images. And then we have used photogrammetric software Pix4D Mapper for the generation of 3D model. So the Pix4D Mapper is basically a software which uses a structure from motion pipeline, which uses a scalar invariant feature transformation algorithm for identifying the common features across the multiple images to estimate its camera position and orientation, and along with the triangulation helps in identifying the location of that feature. And this the final 3D dense point cloud generated from this photogrammetric software will be used for the analysis of the dump slope. As you can see in the last images, these three models has been generated having the factor of safety of 1.49, and the contour map which shows that the center area is the most hazardous area apart from the other areas. So these are the results that we got. Is the model that we have generated using the 210 number of UAV images having the dense point of 51401,580 points, and having a ground sampling distance of 0.0 centimeter, which is quite good for ensuring the precise topographic representation, and the critical zones that we have identified using the numerical modeling software having the FOS of 1.49, which indicating the area is stable but needs regular monitoring. And the conclusion is that this study provides a comprehensive methodology by combining the UAV, 3D reconstruction and numerical modeling for assessing the slopes. And the second thing, this study shows that how the integration of geospatial and geotechnical data enhances the precision, efficiency and timeliness in assessing the slope condition for safer and more sustainable mining operation. Thank you.
Thanks very much. Any questions? Yep. Nick?
I was wondering what the assumptions were for the shear strengths of the waste material and how you obtain this.
So CSN parameters we have carried out through experiments, and we have given as an input parameter in the numerical modeling software for identifying the critical zones, the cohesion and internal friction.
I'm wondering if anyone in the waste dump industry has done tilt tests, large-scale tilt tests that we've used on the dam, like 5-meter size tilt test. You let the shear box gradually fill with material and it self-compacts, and then you excavate around the box and you do tilt tests, so it gives the very high friction angle at very low effective normal stress, and then you extrapolate with a nonlinear envelope.
Okay.
Have you seen that or not?
No.
You
Sir,
haven't?
we have just collected the samples from the field and we have done the experiments, and based on that the internal friction and cohesion we are given as an input in the numerical modeling software, and based on that we identified that this particular area is the critical zone.
There may be a scale effect, yeah? Particle size scale effect.
That we need to think.
Thank you, Nick.
Thank you.
And if you don't have further questions, we're going to close the session.
I request the session chair and co-chair to please come on the dais. We'll be calling the names of the authors and request session chair and co-chair to please hand over the certificates and memento. So, Iftisa Raul, if she is here, please come forward. Anurag, Mr. Anurag. Mr. Pranav Misal, please. Mr. Pranav is not available. Okay. Request Siloy Kumar Ramteke to please come forward. I think Dr. Yashwant Katpatal is not here. Am I right? Anyone? Varsha Mane, Chandrakant Bhoyer, is anyone present? So we'll move on to next. Sarita Patel, please come forward. Farita Patel is also not here. So, and Meenakshi Goyal, can you please come on the dais? Yeah, Rishi Sharma is there. Yeah, please, Mr. Rishi, please come. Next is Mahesh Kumar, please. Manoj Kumar sir, can you please come forward? Pallavi Wankhede. Amit Kumar, please. Thank you. Request the chairman and co-chairman to stay on the stage only. Calling Dr. Yerpude, please come forward to felicitate chairman and co-chairman. Thank you, each and every one of you. Please join for the lunch. And before lunch, we have a very important announcement. There is a group photo just outside the dining hall in the open area. Please join for the group photo before the lunch. Everyone, please join for the group photo. Please, everyone, to join for the group photo outside the dining hall in the open area, please.
every industry presents unique challenges that demand smart, agile, and efficient solutions. At Solar Technical Services, we don't just provide products. We deliver expertise, innovation, and precision-engineered solutions tailored to your specific needs. From mining to infrastructure development, our expertise extends across multiple sectors, ensuring seamless operations, optimized performance, and sustainable results.
It gives me great pleasure to inform you that Solar is now providing customized blasting services to many of our customers who require specialized blasting requirement. This we do it by providing fit-for-purpose product and making available skilled resources. Solar takes full responsibility of all operation and safety and management of the blasting services. We strive to achieve a safe, efficient, and consistent blasting, which is the strength of our team.
At Solar Technical Services, we don't just provide solutions. We optimize, refine, and enhance operations for maximum safety, efficiency, and sustainability across mining, construction, and infrastructure industries. Blast optimization, engineered for maximum impact with minimal disruption. Efficient fragmentation means lower costs and higher productivity. Optimizing resources for long-term efficiency, minimizing environmental impact while maximizing productivity. Backbreak and overbreak management. Controlled blasting techniques to reduce material wastage, enhancing structural stability and improving cost efficiency. Vibration management services. Cutting-edge technology to monitor and control ground vibrations, ensuring the safety of nearby structures and communities. Fragmentation prediction and analysis. Advanced modeling and data-driven solutions for precise fragmentation and improved material handling. Operational costing solutions, a meticulous approach to boosting productivity while maintaining cost efficiency, ensuring every project stays within the budget. Our expertise has powered some of the most demanding projects across industries, including coal mining operations, enhancing extraction efficiency and safety. NTPC PB Mine, optimizing blasting for large-scale energy operation. Limestone extraction, precision solutions for cement and construction industries. Metal mining, infrastructure mega projects, contributing to nation-building endeavors. Raj Infra and Mumbai-Pune Expressway, pioneering controlled blasting solutions. Jayakwadi Dam and Shahpur Railway Blast, ensuring safety and precision in critical engineering projects. With a presence in 82 countries and over 6 lakh metric tons of explosives delivered by FY24, Solar Technical Services is a trusted partner in blasting and technical excellence. Solar Technical Services, expert solutions with the power to propel.
Solar Industries India electronic control block ये सिस्टम से उसने 55,000 एमपी का ब्लास्टिंग किया और उसने काम पूरा 2.5 महीने में सिस्टम को खत्म करके अच्छा तरीके से हमको कैमरा कर दिया।
सोलार में इलेक्ट्रॉनिक डिटेक्टर यूज करके हम लोग ब्लास्ट किया। ईच होल इंडिविजुअल ब्लास्टिंग करते इसलिए वाइब्रेशन थोड़ा कम आ जाएगा। नियरेस्ट हाउसेस गोडाउन्स में हम लोग वो किसी को डिस्टर्ब नहीं करना है, इसलिए स्पेशली सोलार को यूज कर रहे हैं।
एक यूएसबी निकालना, एक इसका यूएसबी मैम का था, वो निकाल दो।
कौन से मैम का है लेकिन?
क्या मालूम, ये निकाल दो ना।
अरे यार
ये
प्रफुल, हाँ
ये
एक मिनट, पासवर्ड है ना?
You can keep it in your pen drive now, and then you can do that. The presentation is about.
अभी जो ऑनलाइन है ऑडियो, हाँ?
नहीं,
ये
I'm
पोस्टर
not
मेरे को दे
asking
दो
to
वहाँ
share
पे,
it to me.
बार
You
बार
can
आगे
keep it in pen
करेंगे,
drive and
वही
just
चलाऊंगा।
insert the pen drive.
और ये अभी जो ऑनलाइन है गूगल में, ये निकालो, इसको लगाओ, इसको लगाओ, इनको ऑडियो देना है, आगे दो।
ये आप कोई रख लीजिए, वो आएंगे मैम को। प्रतीक,
ये वाला लगाना है यहाँ पे।
भाई वो क्या कर रहा है, वो नहीं है उसका काम। इसमें ISAMET का प्रतीक, पहले ये अपना काम है भाई। एक दिलीप सर का ही है ना, दिलीप सर को बोल रहा था।
ओपन करो गूगल मीट। आपका लेट है, पहले जो ऑनलाइन है और टाइम है, जो ऑनलाइन है गूगल मीट वाले, मेरे को गूगल मीट चेक करो।
एक मिनट, उसको बुलाता हूँ।
और एक तो यहाँ पे नेटवर्क नहीं है, फिर कैसे करेंगे?
नेटवर्क के लिए बात किया है, वो देंगे वाईफाई, ये होटल का।
को मेरा दे देता मैं, होटल वाला क्या देगा, मत करो, फुकट पैसे जोड़ेगा आप।
प्रफुल सर,
हेलो, डायरेक्ट इधर से दिखा देते हो। पीपीटी में जो वीडियो ऐड किया ना 550 MB वाला, उसके लिए शेयर नहीं हो रहा, तो इसी से करना पड़ेगा अपने।
हाँ, क्या खुलना है? मेल खुलना है इसमें?
ISAMET का।
हाँ,
आने के बाद ही होगा, अपना 6वां सेशन है। हेलो, 7 है। देख लो एकदम 2 घंटा थोड़ा सा अभी यहीं पर है।
हो गया इसमें?
मैं ढूंढ रहा हूँ कहाँ बैठे।
अरे नेटवर्क दे रहा हूँ मेरा वाला,
मेरा
नहीं वो नहीं चलेगा ना, मेरा 100 MB लगा हुआ है ना।
ठीक है,
वो होटल वाला आपसे एक्स्ट्रा चार्ज मांग लेगा ना।
पासवर्ड सही बता रहा ना।
यूनिटी के अपने साइट पे लाइव चालू है ना, उसके लिए लगाया मैंने अलग से। फोटोज खींचना, हाँ हाँ, वो मेरे को पोस्टर भी दो ना, ये वाला आपने।
ये जो वॉलपेपर है,
हाँ।
इसका जो वॉलपेपर है वो सर से शेयर कीजिए, और यहाँ पे ISAMET का वो खोलिए मेल, इसमें
कनेक्शन हो गया नेट
मेरा करके देखिए।
नहीं चलेगा, फिर गूगल मीट के ज़्यादा लगता ना।
ये पासवर्ड क्या कनेक्ट क्यों नहीं हो रहा?
व्यू कर लीजिए एक
सर
बार।
बोलो कि मेरा लैपटॉप उधर रखने बोल दिया ना, वो सर के इधर आए।
अभी होगा, कैप्स्टॉक दबा था ना, करके नहीं हो रहा था ना।
वो कंफर्म करो
कैसे अभी खट से कनेक्ट हो गया। गूगल मीट चालू करो।
हाँ,
ए,
ISAMET
ए,
का खोलो।
इधर ऑडियो दे। ओए। उधर के आवाज उधर, उधर की आवाज उधर। अब ये इनपुट लेना, आउटपुट कर देना। काय निकाला इसका
वो
कहा?
इनपुट नहीं है शायद इसमें।
फिर कैसे आवाज देंगे?
इधर चेक करो 3.5 में जाके वो वाला है ना
ISAMET से ये का पासवर्ड में हाँ मैं बता रहा हूँ जगन्नाथ और
गूगल मीट का
वो कंफर्म करो आप
कितने लोग जुड़ने वाले हैं वो मेरे को
कौन सा लैपटॉप इधर रहेगा।
हाँ ना ऑडियो की सेटिंग का है
ज्वाइन नाउ करा हाँ ऑन हो गया इतने लोग हैं और
अरे त्यांना आवाज नहीं मेरा आवाज आ रहा हेलो हेलो
पेपर से पण बघताय
अरे अभी अभी जोड़ा हुआ
हेलो आई थिंक सो हेलो हेलो
हाँ यहाँ आ रहा पर यहाँ से आउट हाँ
I think 4 people are doing online. No? 5.
अरे पर इधर
Indians or international?
अबे यहाँ पे आ रहा उनका आवाज यहाँ से तेरे को आएगा ये
हेलो
हाँ अभी आया देख अभी आया ना अबे तू आया ना अबे क्या है फिर हाँ, आ रहा है हमारी आवाज हाँ
आ रहा है आवाज हर्षल आ रहा है आवाज हाँ
तू इधर यहाँ बोलिए कुछ सवलत से कर दो
हेलो 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 माइक टेस्ट
No, it is here. No. Yeah, it should be there. Presentation is ये है ना हाँ प्रेजेंटेशन है पहले उनके गूगल मीट है वहाँ से 4 लोगों की उसके बाद
वो तो बाद में है हमारे पहले नहीं आ रहा हमारे बाद में हो पहले थोड़ी था
आने दो उनको
तो सीरियल के हिसाब से बाद में है सर वो देखिए गए बाहर 4 people are doing online लिखा है ना बाहर
हेलो हेलो ठीक है ऑडियो हेलो हाँ ये आ रहा है इतना बड़ा आ रहा है ओके है सब
ओके सर
ओके
हेलो सर ओके ना
मैंने नहीं देखा सीरियसली नहीं देखा कितना 11
ठीक
ना तुम यहाँ पे रहो ठीक है ऐसे भी चलो हाँ
Okay, good afternoon everyone. After the lunch, I'm Dr. Sumant Mohanto, faculty in the Department of Mining Engineering, VNIT Nagpur. I once again welcome you to the Orange City of India in the last session of this ISAMET-26. Respected speakers, esteemed faculty members, researchers, industry experts, and dear participants, on behalf of Department of Mining Engineering, VNIT Nagpur, I warmly welcome you to the technical session 7A of this International Symposium, ISAMET 2026. The theme of this session is dedicated to mining, which forms the backbone of infrastructure development, energy security, and sustainable industrial growth. I welcome Dr. J.P. Aglave, the session chair of this session, and Dr. G.C. Naveen, the co-chair of this technical session. I request Dr. J.P. Aglave to kindly accept this floral welcome as a token of our respect and gratitude. I now request Dr. Agarwal to kindly extend floral welcome to our respected session chairman, Dr. J.P. Aglave, sir. Dr. J.P. Aglave, sir, is a mining engineer and rock mechanics specialist with extensive experience in numerical modeling, geomechanics, and mining engineering. He is currently director at RockMech IT Solutions Private Limited, Nagpur. He completed his PhD in mining engineering from Queen's University, Canada, along with an MTech degree from Banaras Hindu University and BE in mining engineering from Nagpur University. Dr. Aglave has over 3 decades of international experience, having worked as rock mechanics specialist at Acres International Canada and as a general manager at Itasca India Consultancy Private Limited. He has been involved in major hydroelectric mining, tunnel, and slope stability projects across several countries. He has served as visiting faculty at VNIT Nagpur, is a member of leading professional societies, and has authored numerous technical papers in rock mechanics, numerical modeling, and geotechnical engineering. So a big round of applause for Aglave, sir. Now, I would like to invite Dr. N.R. Thote, sir, to kindly come forward and present a floral bouquet to our esteemed session co-chairman, Dr. G.C. Naveen, sir. यहीं पे रहो. Mr. G.C. Naveen is a scientist in the Department of Rock Blasting and Excavation Engineering, National Institute of Rock Mechanics, India. He has master's degree in mining engineering and he has over 15 years of experience in rock blasting and excavation engineering. He has extensively worked in the areas of controlled blasting, underground excavations, and urban blasting. He has published 25 research papers in different national and international publications. He has delivered about 20 lectures in practicing mining and civil engineers at various forums as an expert faculty in rock blasting. So, big welcome from him again. So now I respectfully hand over this technical session 7A to our esteemed session chairman and co-chairman for their opening remarks and further conduct of this session. Thank you, everyone.
Hello. Good afternoon to everyone.
Actually, यहाँ पे बहुत ज़्यादा papers हो रहे थे सर, तो we have shifted 3 papers over there because बहुत ज़्यादा 16 papers ज़्यादा हो जा रहा है, तो 1 से 8 यहाँ पे होगा and 1 को भी हमने दूसरे सेशन में शिफ्ट कर दिया है, तो बेसिकली 2 से 8 होगा, 2 से 8, 2 से 8 वो ऑलरेडी दे चुका है अपनी प्रेजेंटेशन, वो जल्दी करना, 2 से 8, तो इट इज 7 plus 5, 12 papers will be there.
Good afternoon, everyone. I think you had a wonderful lunch, and it's always at Radisson we have sumptuous meals, So don't doze off. Keep your eyes and ears open because we have a very exciting session here right now. We had more number of papers, but we have now reorganized some of these papers. So we will have 12 papers, out of which 8 will be physical presentations and 5 will be online presentations. So we have, we are running really late, and we have almost 120 minutes, and I'm looking at 12 presentations, 12, 13. So we will have 8 minutes of presentation time, so I think that should be sufficient, and then we can have 2 minutes for question and answer session. Okay? So it's from a 2, right? Okay. So we have we'll start off with, I think all the presentations have been loaded, right?
Yes.
Okay, good. So do you want to announce the name of the paper and the authors?
Yeah. Hello, good morning, good afternoon all. First paper is paper ID 71, is comparative analysis of various blast-induced ground vibration, prediction models through case study of urban area.
First is there, sorry. First is there, Chandrani.
Yeah, sorry.
First is there. Okay.
Yeah, first paper will be paper ID 28, shaft inlet construction in challenging ground conditions of Gumagon mine, Chandrani Prasad Verma. I request to present the paper.
I had an announcement, ma'am. Actually, there were around 16 papers in this session, in this 7A. So we request the last 3 papers, that is paper ID 103, 13 and 58. You kindly move on to the next session hall, that is 7B. Your paper presentation will be in that particular room. Okay. Paper ID 103, 13 and 58. Whoever are there, kindly move to the other hall. Thank you.
Respected Chair, all the delegates, friends and students, very good afternoon to all of you. I'm here to share the experience of shaft inset construction at high-speed shaft site of Gumgaon mine. Gumgaon mine is well known for its watery strata and the challenging ground condition. So, mine is producing around 1,20,000 tons of manganese annually, and they wanted to increase it to 4 lakh tons, and hence a high-speed shaft was proposed, which was being sunk by CC3 China and DCS consortium in 2020. And the shaft was having 7 insets, double insets, 1 on each side, and it was maximum dimension was finished diameter was 6.5, and depth was up to 350 meter, and the main rock mass was here quartzite and highly fractured and weathered gneiss complex, and hydrogeological studies suggested that water seepage will be around in the range of 42 to 83 cubic meters per hour. So they were having 7 inset levels. At 300 level, it was constructed successfully. But while constructing the shaft inset on east side of 400 level, they met with an accident. You can see here a huge mass of 9.5 by 4 to 5 meter about fell down from the roof of the shaft inset. And unfortunately, Simfer did not get the chance to examine this failure. And before Simfer was approached for the study, this area was sealed and filled. So access to shaft site and the rock mass was very limited for us. And later, Symfor was approached for support design of all the underground excavations associated with the shaft and connecting it to the ore body, like ore passes or pump houses, switches, and all those, switch rooms and all those. So to start with, what to do? We have very limited, only one inspection report of this failure, and very limited, only one rock face in the shaft. So we visited the mine site, and at that time production was going on in 300 level, and 400 level was under development, so which was 300 meter away from the shaft site. And at the shaft site, 4 boreholes were drilled, and of which 74 and 72 suggested highly fractured and weathered gneiss complex, but that was ignored considering that it has got diverted. And rest of the 2 boreholes were considered for the design of the shaft supports. And the support was 2 meter long resin bolts in 1x1 grid pattern with mesh and 40 meter shotcrete. But when we explored the logging details of these boreholes, the 72 borehole, I have shown here the logging details. You can see the red oval, where in the immediate back of the 400 level, RQD is lying in the range of 11 to 21. That is very, very low. And similar was expected at 500 and 800 level. 500 level is having up to 5 meter, RQD is 24, and beyond which up to 10 meter is having RQD 0. And the failure at 400 has already confirmed that rock mass is highly fractured and weathered, and it is having very, very low RQD. So we decided to go for numerical modeling for the design of the supports in next levels. And we collected samples from the mine site, and properties were determined. And this shows the full view of the model and all the excavations that we have studied in the model, and suggested the support design. But we will be concentrating here only for the shaft inside. Then these property sets were utilized in the model, and we played with the properties till we got the similar failure in the 400 level. And in this way, we calibrated the model, and same model is utilized for the prediction of failure height in case of 500 and 800 level. That comes around to be 5.5 meter height and about 6.5 to 8.5 at 800 level. So empirically, it was possible to estimate the support design, what should be the, what is the rock load height, and what should be on the basis of the RM, RNQ. It should be. And RMR we have already estimated as 36 to 42, which was very poor, and Q was also in the range of 0.5 through and 0.58. And this shaft and shaft inset was an intersection portal similar to that. So we considered ESR 1 and 1.6, and as per our suggestion, it should have, instead of 40 mm shortcut, it should have been 60 to 80, at least 60. So this is okay, but as the strata is loose, how these supports will stand. So it was necessary to consolidate or seal the immediate roof of the shaft inset so that the supports can work. Otherwise, the whole mass will come out with the supports. So to control that, we suggested pre-excavation grouting at the periphery of the shaft inset. And for that, we needed all this grouting pressure, material, and all this that was estimated from the field test. So to carry out this, we suggested 5 boreholes around the periphery of the shaft inset and 1 in the middle also, so that floor should also be intact while blasting is being carried out. And pumping tests were done to understand the pressure at which we need to pump the grout material. And this was 2.5 meter long, 108 mm dia pipe was initially inserted and fixed, and then 3 meter length pipe is inserted for water injection, and water pressure is measured, and hydrostatic pressure was measured at 1.5 megapascal. And on the basis of that, 60 mm dia pipe is then finally inserted at a small angle of 1 to 2 degree. and with a WC ratio of 1.5 to 1, which was gradually adjusted with the conditions existing at the site to 0.6 to 1, and finally grouting was done. And here you can see the blasted phase after grouting and the blasted material. Grouting has worked well. And as additional precaution, we estimated unsupported span and suggested this shaft inset construction in stages. And in any case, with the help of this RMR 3642, the excavation dimension at one point time should not exceed 2.5. So coming to conclusions, all the shaft inserts then were constructed successfully with the help of Semfer design, and instability modeling and its back analysis helped us in better understanding and prediction, and pre-excavation grouting definitely worked for the site as it created a sealed zone around the shaft inside proposed excavation. And thus with the help of this failure analysis, empirical and a coupled numerical approach, we were able to construct all the shaft insets safely. That's all. Thank you.
Excellent presentation, Dr. Chandrani. Any questions from the audience?
Yes, sir. Yes, sir. Because shaft is located in footwall side of the deposit. Because the shaft site was located in footwall.
Any more questions from the audience? I will have one question. Because we had an incident here, so did you come up with more of an instrumentation for the like the shaft, or the other excavations in this area?
For mining zone, they are using instrumentation, but shaft actually it is under the control of CC3. They are not very much interested in having those instrumentation installed, and so nothing is going on as such at shaft site. Yeah. In mine they are doing instrumentation, and that all data is there for mine, and the mine or the ore body is 300 meter away from the shaft site, and they are not yet connected. That connection drivage is going on, cross-cut.
Yeah, thank you, madam. So we will go with the next presentation. Paper ID is 71. Comparative analysis of various blast-induced ground vibration prediction models through case study of urban area. Author, who is the author? Abdur Rahman?
Yes, sir.
Yeah.
I'm here.
Yeah, you can start your presentation.
No. Pen drive लगाना पड़ेगा, वीडियो नहीं चल रहा, वो चाहिए होगा, मुझे पता तो नहीं चलेगा, कहाँ पे लगाएंगे? वीडियो अभी नहीं चलेगी,
ये चाहिए नहीं?
I request you to complete your presentation within 78
yes,
minutes.
sir. Sure, sir. Nothing is more. Video is not running. Good afternoon to all. Myself, Abdur Rahman, and topic of my manuscript is comparative analysis of various classical blast-induced ground vibration prediction model through case study of urban area. And objective is our study is open cut rock blasting in urban area, which area is in Navi Mumbai, and it is excavated for the Navi Mumbai International Airport. Airport is now running, and my work was to mitigate the risk and ground vibration, increase overall production with safety. We use 75 number of blast in this manuscript of 10 to 15 deep hole blast, and analyze the 3 empirical and 2 AI ML prediction model, and conducted various coefficient. The study outcome may likely be helpful to minimize the risk involved in carrying out open cut rock blasting operation at sensitive site. It is the area approx 11.65 square kilometer, and upper side of peaks is before excavation. It is 80 plus meter of height, and approx 10 village are nearby area, and there are highways and many more road, high tensile line, etc. is passed in the site, and it is the post excavation site now looking like this. It is the mainly basalt rock, massive basalt rock, and weathered and jointed basalt rock. There was a video, but it is not running. I don't know why. Mainly, I was saying there blasting. Blasting is nothing, only interaction of explosive with rock, nothing. So, and only 15% of energy is used for the break of rock, and 40% move in the vibration. So my paper is in vibration, so I am talking about the vibration. And control blasting. It is also a video, but it is not running. Control blasting technique efficiently distribute explosive charge with the rock mass for control of vibration, fly rock, and any type of micro fracture. It is blast design parameters which are used in manuscript. Diameter of all blast taking 1.5 mm diameter, and hole depth we take 15 to 10 meter. Burden, spacing, stemming, and almost our output Vmax means peak particle velocity. It is maximum 6.8 and minimum 1.03. It is the hole design, blast hole design, in which 15 meter we take 1 to 1.5 meter of hole deck, and with 2.5 to 3 meter stemming, and 10 meter one deck, 0.5, 0.75 and 1 meter. And it is the delay, corner delay and middle initiation. It is the vibration measure by seismograph, and GPS used for the location from the blasting phase to monitoring location, and blastware software for the further analysis. And empirical PPP prediction. I think all are aware here from this formula. Duell and Fogelson 1962 giving the scale distance formula. And from this scale distance, we can predict USBM, Embassy, Endron, and Langford-Skillstrom for the prediction of model. And it is the result of my manuscript. First, in left side is relation between scale distance and actual, and of USBM, and right side actual and predicted. So these are in empirical, and it is the artificial intelligence mechanical learning. I used a software Veka Mine, data mine of Veka software, in which I bifurcate my data in 80 to 20% for training and testing purpose, and find this result. USBM in empirical provide the best coefficient 0.72, and random forest model, a machine learning model, it provides 0.96% of coefficient, while multi-layer perceptron is 0.88. It is a conclusion. The safe control open cut blasting operation carried out at the environment friendly, sensitive as well as habitat site of new proposed airport at Navi Mumbai Hill site, and percentage studies focused on USBM and random forest regression model, and it imperative to safe control pre and post blast analysis be carried out in such sites which are sensitive in nature. It is expected that presented outcome of the study will be helpful towards the predicting safe open cut rock blasting operation parameter in such environmental sensitive condition. Thank you, sir. Thank you.
Thank you, Abdul, for keeping to the time. Any questions from the audience, please? Yes.
You were talking about AI and ML based assessment
Yes,
for
sir.
scale distance. Please elaborate upon that.
This, sir, or this?
Yes, yeah, this one. Please have some elaboration on this.
Okay, sir.
The data sufficiency.
I
what
use,
algorithm you are employing, because it is,
a software of data mine software.
Yeah.
Waikato University of New Zealand, it make the Weka software, and in this we take this software provide all the things which you was related to artificial neural network and machine learning. And I only split the data into two parts. One is 80% for the training and 20% for the testing. And training data provide almost about 0.93, while when test this data from the 20%, then it provide 0.85%.
Sir, whatever it is, you said it is from New Zealand, right?
Yeah, software is from New Zealand. Yes, sir.
So what data they have employed for developing that prediction model using AI? Now you are trying to use in Indian conditions. Is it worth?
But it is a provide the error related to error, sir. It is 96% is performance of the data, sir. Yes, sir. Yes, sir. No,
We are inputting the data based on Indian conditions, and the prediction is based on New Zealand data sets, right?
No, sir.
Is
Software is from New Zealand.
Software is from New Zealand.
Yes, sir.
Then what algorithm exactly it employs? Because we use PPV with a conventional method which has much more precision rather.
Maybe, but this time I am doing PhD, sir, and this data is also in using my
So
PhD.
at least you could have done a comparative analysis
Yes,
of the actual measured by using the kind of
a software of easy state.
Yeah.
I use this software for this regression and MATLAB also. But I am presenting here only for Weka.
That is what I am.
Yes, sir.
I think like
would have compared with the actual,
yes, sir.
measured
Yes, sir.
with the equipment and predicted by this AI-based model, right, sir? That's
well,
it.
as what Abdul is saying, he is working on his PhD, so there is much more things that will happen in future.
Yes,
so, okay. So we'll go with the next paper.
Yeah, next paper is paper ID is 78. Safe blasting practices in mines, a practical approach based on the experience in various open cast mines. The author is, presenter is Changate Songliana.
Paper number? 1 second, sir.
Just 1 second, sir. It's there. Yes. Actually, he has put his pen drive now, so I will.
Okay.
Paper ID?
78. Yes. Thank you. Respected Chairman, Co-Chairman of this session, dear delegate, the topic of my paper is safe blasting practices in mines, the practical approach based on experiences in various open cast mines. Two of the authors, Mr. Panchanan and Sakat Banerjee is also here. In this paper, I want to discuss the safe handling of explosive and blasting practice based on more than 25 experience in various open cast mines in India. This I have taken from annual report of PESO. PESO, unfortunately, they do not update their website. So the production of explosive, cartridge explosive in 2023 to 24 was 704,000 metric tons. And SME explosive was more than 1.3 million metric ton, and UNFO was about 22 metric ton, and all the detonators, including electric detonator. That time, electric detonator was still there. Electronic nonel, we call it shock tube. The total production in 2023-24 was 978 million in number. Here, the number of accident and person killed in coal mines and non-coal mines during 2024. This is taken from DGMS annual report 2024. You can see here the total accident, number of accidents which took place from both coal mines and non-coal mines was 71. Out of these 71, the total person killed was 89. The contribution of explosive in fatal accident in coal mines during 2024 was 5%, and in non-coal mines it was 9%. And if you study the annual report of DGMS, there is a trend, increasing trends of accident rate from 2022 to 24. Although we are having a little bit reduction in metal mines. Now there are so many advanced drilling equipment and blasting equipment, particularly electronic detonator is available. But accident due to explosive, it continued to occur. And last year, there was a big accident, this year, 2024 also. So based on this, I'll be giving our experience, how to deal with explosive and safe blasting practices. What is the cause of accident due to explosive or blasting? There are so many causes, we cannot say. But DGMS, they have classified the causes of accident due to explosive, and they have given the code, like solid blasting projectile, deep hole blasting projectile, secondary blasting projectile, and they have given another is other explosive accident. So there are so many causes, but luckily DGMS, they have given this code. At least we are having code. And I have shown these two photograph accident which took place in India. One is Gangaramchak and Gangaramchak Badulia coal mines. Accident took place on 7th October 2024. I was also part of the investigating team, and I cannot give the cause of because I'm part of the investigating, and the matter is still pending in court. And another accident where 4 people killed and 3 persons injured in SCCL in 2020. And explosive is very, very high energy and very dangerous. So I have listed accidental risks of electronic detonators, like high temperature, shock, vibration, so many things, and radio frequency energy. Apart from this, the possible accident due to electronic detonator can also occur due to electronic hardware fault, electronic software fault, environmental stress fault, user fault, etc. And similarly, shock tube initiation and explosive, they are very sensitive. They can be ignited by friction heat. They have to handle very, very carefully. I just wanted to mention different tests for electronic detonator. In India, a new IS standard was published in November 2023, where my colleague, my Nigam Saab, Atul Saab, were also part of the team in framing this new BIS standard. And in new BIS standard electronic detonator, the electronic detonators are divided broadly into two. One is grade A, general, and another is grade B, permitted. Oh, sorry. So there are so many test requirements here, and with this new IS standard, we are now expecting that a good, safe, good product will be coming out for electronic detonator. I have to rush like bullet train now. Regarding safe blasting practices, the best way is to follow rules and regulation very strictly. And DGMS also, they have published circular and technical circular and notification time to time. So I'm having list of the circulars related to explosive. I'm not going to explain it now. And I'll just mention what are the common mistakes we have observed in mines. Dealing of holes without prior marking of hole positioning. This happens everywhere. Another is drilling of holes away from the actual marking position. This, I had shown you one example in one of the best mine, cement mine. I'll not mention the name of the mines. Blasting team, they had marked the hole positioning very beautifully. But drill operator, he came and he drilled holes just beside the mark hole. We measure it, the distance 30 to 50 centimeters. And this communicative error, it could be very, very bad. I'll just have to rush now. Planning before blasting operation, we have to plan very carefully. We have to assess what are the risks involved nearby. And transportation also in, I just wanted to tell you that in Gangaramchak Badulia coal mines, after that accident, they had used wooden box to carry explosive, cast booster and accessories from explosive one to the blasting site. That only after the accident. Another important, I just wanted to say, now DGMS, they restricted to use mobile phone and all the electronic item in the blasting site. But communication is very, very important. We must have a safe distance. We have to fix a safe distance for communication. And charging of holes. Charging of holes is very, very important, and maximum accident occur during charging. I'm having only one slide now. I'll conclude it. I just want to show this photograph. This photograph I've taken from one of the best mines, public sector mines in our country. This practice happened still. This I've taken this only 6 months old. This photograph. What they have to do is what they are doing was they prime the booster cartridge with electronic detonator or nonel at one place. Then they carry by hand like this. So what will happen if accidentally if he fell? And it was having a detonator. And detonator is very sensitive to shock. They could be a very disastrous accident. I'll just conclude it. I just wanted to conclude that there is no absolute design in blasting and no absolute safety in blasting practices. Therefore, each blasting operation should be properly planned with all safety precautions in place. Thank you.
Thank you, Dr. Somalina. We can take one quick question for Dr. Somalina. Okay, otherwise, like I'll have one question. You said like last couple of years the accidents are increasing, right?
Yeah.
As per the DGMS report.
DGMS report.
So have you done an analysis as to in which area the accidents are increasing? Because the safety has been already there in the last 2 years. What has happened?
Mainly, blasting accident is mainly in open cast mine due to projectile that fly rock. But there are some accidents which took place during charging. Accidental blast. So, particularly in Gangaramchak and Gangaramchak coal mine, the whole explosive one was blasted. So, there's very difficult to, we try to analyze what are the causes and blasting, particularly in explosive. There are so many, if you see, there is no common causes. Main common causes is projectile. That's why DGMS, they have given a code. Thank you.
Yeah, thank you, sir. Next paper ID is 79, titled Investigating the Detonation Property and Deflagration Behavior of Permitted Emulsion Explosives. The author is Fairoz Ali. Requested to complete your presentation within 7 to 8 minutes.
Okay, I'll try. Very good afternoon to all. Honorable Chairperson, co-chairs, industrial expert, distinguished scientists, and my dear young researchers. I am Sunil Kumar Dhar, a research scholar from Central City, from CSR Simple, to be honored to present my topic, investigating the detonation properties and deflagration behavior of permitted emulsion explosive, on behalf of Dr. Fairoz Ali sir. As we know, in Indian mining scenario, there are different type of permitted emulsion explosive are used to perform the blasting performance. But here in our study, P1 type of permitted emulsion explosive are used. And there are several parameters that can be define the performance of explosive. But here in our study, we used two specific parameters like the detonation behavior and the deflagration properties of to check the performance of explosive. Under detonation behavior, we used velocity of detonation, air gap sensitivity, and continuity of detonation, and post-detonation fumes were conducted. Permitted emulsion explosives are especially designed for underground coal mines, in which the risks of methane risk ignitions and explosion of dust were dominant. And these are some importance of permitted explosive. First one, my objective is the detonation velocity. Detonation velocity is nothing but the speed at which shockwave front traveled from the explosive. And as you can see, this detonation velocity was measured using two methods. One is in unconfined way of measurement, one is confined way of measurement. In unconfined way, Daughtry's method is one well-known method that can be, as you can see from image A, that's the setup of Daughtry's method. And from this experiment, we get that in normal condition of VOD, of studied explosive found in between 3,932 meter per second to 4,032 meter per second. And thereafter, we perform the detonation performance at water slippage time of different time interval at 24 hours and 48 hours. So, result found that a significant drop in velocity was observed throughout this experiment. That is, in 24 hours, 200 to 230 meter per second of detonation velocity was reduced, and in 48 hours, 400 meter per second of detonation velocity was reduced. Thereafter, we can apply a simple formula to measure the detonation pressure of explosive. And for this studied explosive, the detonation pressure was found in between 4.4 to 4.7 gigapascal. Thereafter, this one also an important parameter, that is air gap sensitivity and continuity of detonation. In air gap sensitivity, that to be determined the sensitivity of an explosive to initiate the receptor cartridge. Means first one we have take the two cartridges. That one is donor cartridge, another one is receptor cartridge. And from the initiation was from donor cartridge, that it will successfully detonate the receptor cartridge by putting some 2 centimeter distance in between these two cartridges. And second one is the continuity of detonation. That is, we have checked the continuity at the time of detonation. That we have placed 5 numbers of cartridges in a single row, and thereafter we can check the continuity. And this for our studied explosive, this both of the parameters were found successfully used in underground coal mines. Defragration. Defragration is our important parameters to use the suitability of permitted emulsion explosive used in underground coal mines. Defragration is defined as the slow burning process of explosive, and this defragration studies was determined by using two methods. One is long cannon method and another one is short cannon method. But here in India, for permitted emulsion explosive, you used long cannon method, and these are the sample preparation method that used to determine the defragration studies of permitted explosive. For this, first initially samples were weight of sample were taken, and 30% of cartridge of explosive was removed from the explosive cartridge, and at that vacant space, 10 gram of G20 grade of gunpowder was filled and was detonated by the use of fused. Thereafter, the prepared sample was kept centrally inside a 40 centimeter of paper roller, and the prepared sample was kept inside the long cannon, modified long cannon. And the defragration study was recorded by using high-speed camera, and it was found that both the samples of defragration study was complete in between 99 millisecond. That will be satisfactory. Yes. That will be satisfactory. Complete the defragration study within the acceptable limit. That is the 99 millisecond. And after the studies, post-blasted sample were recovered to check whether it is deflagrate or not. And this one also an important parameter, that is post-detonation toxic fumes study. For this experiment, that in underground confined space, that the detonation of explosives should be in that is they must be within a permissible limit of fumes because of the confining. So here in this experiment, 50 grams of explosive was placed inside the, this one is the steel chamber, or that is the gallery. Directly I go to the result. And for this study, the total NOx and CO and both of the toxic fumes were found within permissible limit, that is less than equal to, NOx is found less than equal to 20 liter per kg. CO was found less than 40 liter per kg, and both of the toxic fume were found less than 50 liter per kg. These are my conclusion. That is, studies of detonation characteristics, deflagration, and post-detonation fumes are an important parameter for permitted emulsion explosive, that is to be safely used in underground coal mines. Based on the studies conducted in two samples, that is P1 type emulsion permitted explosive, the VOD varies from 3,932 to 4,032 meter per second, and the detonation pressure varies from 4.4 to 4.7 gigapascal. And the permitted explosive also must be at least 2 centimeter air gap to successfully utilize in underground coal mines. And the CO concentration was found within permissible limit.
The floor is open for any questions. Any questions from the audience?
Yes, please.
So, in the VOD determination,
yes,
you have used the dewatering method, right?
Yes.
Have you measured the same explosive by the in-hole method?
Here.
We use dosage method as well as VOD method. So there is a huge difference between in-hole VOD and unconfined condition.
Mhm.
So for permitted explosive, there is a standard. So we are using dosage method, which one is validated by VOD method. That is incidental Canada method. Is unconfined condition.
Okay. So, do you recommend for the in-hole VOD determination if there is a huge difference in between these two types of measurement?
That is really correct. Particularly for permitted explosive, we have to do in underground coal mines. There is a little bit difficult because we cannot do testing of permitted explosive in underground coal mines, but we can do in our Canon gallery.
Okay.
That is very good suggestion. But we'll do this SMB explosive. SMB explosive, we are having a lot of this one data trap also. We do in-hole VOD measurement.
Okay. Thank you very much.
Excuse me, sir.
Thank
you. In unconfined condition, we have measured the VOD using dewatering method as well as this resistance wire method by doing DTVM and other instrument also. So in that we have seen this. There is a huge difference between both the condition. Unconfined condition with the dewatering method, we have seen the plus minus 400 variation, and in the resistance wire method, around plus minus 200.
Okay, that is unconfined condition or
DTVM delay timer and VOD tester instruments.
Okay. Both unconfined condition.
Yes, in both unconfined condition. So
So
which one will be? You will suggest which one will be good?
I don't know exactly which should be the best, but if you see, we are also using VOD made of Incidental Canada. We also have that delay timer. And we also do this using dosage method. So best way is to do calibrate in all the possible measuring instrument.
Okay, thank you.
I'm asking about this unconfined condition and
Unconfined,
surface.
Correct. Yes, we are doing with all the three methods: dosage method, VOD method, and delay VOD and delay timer.
Yeah. Actually, I have tested around 10 samples for the same pump track and same condition. I have observed that variation.
Definitely,
I think
due
So
to the
your
paucity of the
DTVM
times,
gives better results than that.
we can have this
dot-
discussion, sir. Sorry, I had to cut you short on there, but the time is short for us. So maybe Dr. Somalina and Sunil can get in touch with you during the tea break. We'll move forward to the next paper.
Yeah, thank you. Yeah, next paper ID is 50. Topic is investigation of stemming in bench blasting, a case study. Presenter is G. Gopinath.
Yeah, very good afternoon, respected chair and co-chair and delegates. Myself is Gopinath and my co-author is Mr. Naveen. So we are from scientists from National Institute of Rock Mechanics. I am talk on about the investigation on stemming. Almost all people will know what is the stemming. It's nothing but inert material we are filling at the top to retain the gas energy to work to done this work. If it is good stemming, definitely you will get a better fragmentations as well as the displacements, and you will get a low vibrations. If it is gas energy is not retained, definitely it will be ejecting out, so that will lead to a bad fragmentations or poor fragmentations, and you will get a tight mug pile. In that way, you will get the productions also will less by loading it, and also it will leads to vibrations. So in that context, what are the factors which are influencing by stemming? There is some many factors are there, but we are giving the main influence factor. One is the stemming length, and then stemming material, and then the initiation, what is the bottom or top initiation, and then how the whole conditions, whether it's a dry hole or a water hole. So we have done some or three experiments on this by varying stemming length and then stemming material, as well as what the initiation system like bottom and top initiation. This is the one experiment we done at one of the mine. So you can see there are 5 blasts we took. In that 3 parameters we have changed with the same hole, means the same blast. We need not to change the rock mass conditions to keep rock mass condition in the same conditions. For that we took for the 3 holes in the same phase, and then for the 3 holes, individual holes, we changed our stemming length, and also the 3 parameters of the drill cuttings and then the angular chips and the initiation systems were changed. And then we analyzed the fragmentations as well as for the displacement and the phase velocity by using a image processing software, as well as the videos are captured with high-speed camera, and we analyze the phase velocity by using the pro analysis. And this is one of the example of that, how we charge the 5 blast, the bottom charge, and then how we use for the stemming materials. You can see the result of that, the 3 blast which are taken here by changing the drill cuttings, angular chips, and then angular chips with the detonating cord, and then using a shock tube detonator. That is bottom initiations and top initiation. You can see the first figure. You can see once you change your stemming length, there is the ejections out, means it's not retained the gas energy to work done, so it's ejecting out. That is the 1.5 meter stemming length. And if you see at the 2.5 meter stemming length, it retains the energy to do the work. So that's what is showing in the drill cutting with the shock tube. Once you switch it over to replace the drill cuttings to the angular chips, you can see all the holes are almost retained, but the 1.5 meter stemming, it's ejecting out. If you come to the next figure, if you see, we are used for the angular chips and the detonating cord, means the top initiation. Definitely top initiation start in first, so that it ejecting out the stemming portion. That's what it shows here. And this is one of the video of the slow motions video. It's slow motions video of the one of the blast, which takes first hole, second hole, and third hole, so how it's ejecting out for the camera one. And the second experiment we done with the same mine. We varied stemming material with the same block of the block which charged with the drill cuttings, of the block with charged with the angular chips. And you see the angular chips and then the drill cuttings, how the variations in the result. And we used for another case study of this one, we done with the stemming plug. Now people are using for the stemming plug. We used for the stemming plug at the top with the air decking, and we used at the bottom also with the air deck techniques. So this is also taken here. You can see how the explosive is retained. That means the explosive energy is retained in the hole by using a stemming plug. This is the latest one. I like to highlight these portions. Actually, we are used for this the third trial we took. This is the latest stem gel. I think people are not used about the stem gel. So we are experimented with the stem gel as well as for the stem plug. We compared these two product in one of the mine. This stem gel is from the Shockways from Australian company. They are using actually the truck loading directly to the stem hole. Need not to put it manually, just directly, it automatically it mixes and it pours to the hole. So that's what the stemming material, instead of stem, we are pouring stemming material, the stem gel is using here. So they are unfortunate to brought this truck here, so manually they mixed at the site for the demonstration purpose. So 2 blasts we conducted at one of the mine. So that is the one we are showing here. The liquid and then the water, whatever the water it's available, that same water will be mixed with 1:14 ratio and then directly pour into the hole. So it is in the liquid form. Once it is mixed with the hole, mixed with the water, within 10 minutes it makes a semi-solid of liquid, and then directly we are pouring in that the hole. So what we done is here is once again the stemming and the same block of the portions of the stemming plug we used with the bottom deck and then the top deck, and then the up portions we charged with the stem gel, what we are showing on the next section. So this is how we conducted that blast. We see this one, the first photograph. This block is the stemming plug and then the stem gel. The second photograph is only for the stem gel. So you can see exactly the result. You can see the blast from the stemming gel and then the stem plug. Stem plug is retained better than the stem gel. The first wall is ejecting out because there is some burden will be more there, and initiated the first wall there. That is the reason the first wall has got some ejection in the photograph. And then you can see the stem gel. Almost all the walls are ejecting out, means water evaporations are there. That's what we saw here. Water evaporations are there in this. And this will be a videograph of that. We captured with high-speed camera. You can see the, hope it will run. Yeah, it is running now. So left-hand side is our stemming plug, and right-hand side is the stem gel. So this is an high-speed camera of 250 frames per second we captured for our analysis purpose for assessment of the stemming. And we used for the analysis like fragmentations, displacement, phase velocity, as well as for the fragmentation we done with the image processing software, and then pro analysis we used for the phase velocity measurements. Throw we are measured directly at the site. So that's what the result is shown here. And you can see the result of the second one for using the drill cuttings, aggregate and stem plug. How it is the result was varied, and this is the results we can see here. You can see in the both first and second one, yeah, I'll be finished in 1 minute. See, both if you compare with the first result and second result, the stemming plug is better result what we got it here. And this is the stem gel. Since we are not analyzed more here because we have done only for the 2 blasts, so we are not went more analysis part of stem gel. But the 2 results shows almost the same fragmentations what we got in stem plug as well as the stem gel. But the throw, if we compared with the stem gel and stem plug has got more throw than the stem gel. So that's what we are shown here. And the stem plug, this is one of the cost experiments also done. This is a cost calculation done by the mine owner, not us. So the using the stem plug, it's almost 4 months of data of that company. So the saving cost compared to drilling and blasting is around 1 rupees to 2 rupees to 63 rupees per cubic meter. The cost saving was there for drilling and blasting by using a drill, using a plug system, apart from the loading cost. So my conclusions will be, at the end will be the cost saving will be around 1.4 to 2 rupees to 63 paisa per cubic meter by using drill cutting for that particular mines what you have used. Definitely the stemming length, if you increase, definitely the stemming will retain, but the color boulder will generate. That also you have to take care. So you have to optimize the design in that way. And angular chips, if you replace, definitely it retains more gas energy in the hole. Whenever there is a watery hole, we will switch over for angular chips. Yeah, thank you very much.
Thank you, Dr. Gopinath. Now the floor is open for any questions. Yes, sir.
Hello.
Yes,
sir. Nice study, sir. Just want to understand, after this study, have you derived any conclusion regarding the stemming length ratio? Because as a thumb rule, we blasting engineers are following 1/3 of stemming length, 2/3 is explosive column. So since you have done so many experiments, so have you derived any solid or concrete formula type of thing, which type of rock will need which type of stemming length?
We are actually
still we are on thumb rule.
Yeah, for the specific to the site only we are arriving, but because the rock mass are not same for as well as the rock mass condition or the color portion, no, it is not same. If sometimes we are used for less than 1B we are used, sometimes we are used for more than 1B also we use, sometimes we use 1B also we are used. But what I shown the stemming plug at the last end, no, so there we used for 1B, one time of the burden we used. And then that we are reduced to less than 1B so that we got more fragment, means the boulder and the collar region. That is the reason, the purpose we are putting the stemming plug and then putting that. No? So we are putting around 0.5 times the burden we are used. And the fragmentations come down. What we got it for the 1B, it is less than that we got it.
And
so it is specific to the site.
Yes, sir.
So that is the reason thumb rules are using.
Thanks, sir. Thanks.
Yeah.
And one more query from our side that Suppose you reduce the stemming column also, and if you start the quick setting cement top capsules for better retaining of energy.
Definitely.
Have you tried that one also?
Quick setting we are used only for tunnel. We are used for the quick setting, but not in the open cast mines because it's cost effective. If you compare to the quick cement, this stem plug is cheaper than the quick cement. What I understand, the quick cement cost. Yeah,
Thank you, sir.
Thank you. There's one more question from Dr. Swamilena. We'll take it. Make it quick.
Really a nice presentation and very interesting paper. Have you studied the size of the stone, angular stone you say? What is the size of the stone?
It is less than 10 mm.
Less than 10
10 mm aggregates. I have in my paper all the gradations of the aggregate also it is there. Less than 10 mm aggregates.
Okay, have you tried with different size for according to your hole diameter?
Yeah, we done that. We done for that.
So that will be interesting. I want to see how much you can improve.
We varied one of the, it is not there here, but we varied the different stemming material, what you said for the aggregates for the different size.
Okay,
so
sorry,
that we done
I'll have to cut down. We can have these discussions during the coffee break, okay? Thank you. Maybe, shall we move to the next?
In one of my demolition, I had used the quick setting cement for the stemming of the holes, and it act nicely.
Yeah.
Okay, thank you.
All of you.
Yeah, thank you, Mr. Gopinath. Sir, because we are running short of time, you can discuss later, sir. Yeah. Yeah, next paper ID is 126. Control blasting in tunnel in densely populated areas by using electronic detonator and blast design software. The presenter is Yogendra Nigam. Yogendra Nigam, right?
Sir,
Anjani presenter?
Anjani Kumar. Tapesh Jalandra Anjani.
So you can complete within 78 minutes.
Audio भी चाहिए. कोई इशू? इसको रहने दो. ठीक है. इसको ऑडियो का दे दो ना. ऐसे रख देते क्या इशू? So, shall we start? Yeah. Good afternoon, everyone. I am Anjani Kumar. Excuse me. Okay. Good afternoon, everyone. I am Anjani Kumar Bograju from Solar Industries India Limited. Firstly, I would like to thank VNIT Nagpur for giving us an opportunity to present a paper on our case study, which is control blasting in tunneling in highly dense populated areas by using electronic detonators and blast design softwares. As India looks into the future, the role of tunneling is very crucial and important for development of country and for connecting places and for reduction of carbon emission also. So from past 2 decades, tunneling in India has undergone a remarkable transformation. But specifically when it comes to the urban tunneling, it has very much challenges in it, like proximity to structures and variable geology. When it comes to the Himalayan geology, the use of TBM sometimes is not feasible due to the geological parameters and smaller lengths of tunnel and its challenges. So choosing a method of excavation plays also an important role. But in our case study, we have followed by the NATM method by using electronic drill and blast to carry out the project in a safer and efficient way. In the initial stage, we have tried the conventional blasting, but which was not able to mitigate the ground vibration concerns. So after that, we have introduced, as being technical experts from solar, we have introduced the electronic blasting, with the help of our technical expertise and blast design software, we were able to mitigate the ground vibration concerns and AOP concern in particular that area. So going to the company's profile, Solar Industries India Limited is a leading manufacturer of explosive. We are largest manufacturer of initiating systems, industrial explosive and defense and aerospace explosive. So in the introduction slide, these are some key challenges there were, which we have to mitigate, which we have to maintain all the regulations and maintain all the AOP and ground vibration concerns. So in this introduction and this case study, we are going to be discuss a comprehensive study of case study in which we have taken about 129 blasts, and in further slides we will going to be discuss. So I would like to introduce Tapesh, who will be leading the presentation, and we will be discussing about the methodology what we have adopted there.
Thank you, sir. Good afternoon, everyone. So coming to the slide, methodology. So before blasting and tunneling, we conduct a thorough geological assessment in coordination with geologists, which includes identifying the direction and orientation of joints, and also evaluating the competency of rock mass. And existing fractures, joints, and bedding planes significantly impacts how the rock breaks during blasting. So this is the pre-blast survey, which we have to do before designing a blast design. So coming to the blast design, designing an effective blasting pattern for tunnel is essential for efficient excavation, and which ensures safety and minimum environmental impact. And now coming to, so depending on geological assessment, we design the drilling pattern, and our primary objective was to reduce the ground vibration by maintaining the maximum instantaneous charge, which we control by manipulating the drill design according to the variation in the rock geology. So after conducting blast, generally we had analysis of the post-blast, which includes ground vibration analysis, fragmentation analysis, and profile analysis. So regular vibration monitoring and analysis of the blast is essential to understand blast performance and to redesign a blast for the future. So here we can see this is our one of the blast design which we use to drill 100 to 120 holes, and this is the timing. Coming to the next slide. So focusing on the tools that we used in tunnel blasting, this constituted the main components and were fundamental to achieving controlled and optimizing blasting. So first is electronic blasting, which is our in-house developed technology from Solar Industries India Limited, which has 4 components, as you can see, microdet, logger, and tester, and blaster. Coming to the iBlast software, so in order to scientifically detect and predict ground level vibrations, we have used iBlast software for controlling the PPV, which is very beneficial for the optimization of blast. Our next important role was to control ground vibration, and so for this we have used seismograph instruments, which is used for regular vibration monitoring and analysis and gives an extra edge for upcoming blast. Now coming to the next slide. So this is the PPV versus blast number graph that we can see shows that the most recorded PPV values remain below the specified desirable limit, which is acceptable limit is 5 mm per second. And so as we can see, while minor fluctuations are observed between blast, but there is no significant increasing trend, suggesting stable parameters, and the variations in PPV are likely to change in geological conditions, charge per delay, and blast design adjustments. Now coming to the next slide. So by conducting the comprehensive study, these were following observations. Earlier we were using nonel detonators and also surface initiators for tunnel blasting. But due to scattering effect and obviously delay time inaccuracy, multiple blast holes may initiate almost simultaneously, resulting in overlap of char detonation, and it was always hitting the threshold limit of 5 mm per second. And so we were not able to mitigate issues, so we have to adopt electronic blasting. So after electronic blasting was adopted, the vibrations were under control as there is high delay accuracy, and also the vibration mainly depends on maximum charge per delay of only a single hole. And also we have increased the delay interval from 10 ms to 100 ms, and the observations were the energy release was distributed over time, the wave interaction was minimized, and also the charge per delay was effectively reduced. Now I would like to even to.
So as you can see, there's a statistical representation of the blast we have carried out in our comprehensive study. So the upper portion generally indicates that the conventional method blasting we have done prior to adopting the electronic technology. So as you can see, there was a major increase in vibration as compared to the electronic detonator, as you can go to the chart. So going to the conclusion, so basically programmable electronic detonator can be the best solution in terms of controlling vibration and AOP when it is required. By using electronic detonator and iBlast softwares, the ground vibration was reduced to 48%. So in the final slide, I would like to just show you a case study video which we have been carried out in Shimla. So please kindly say it.
जो भी टर्निंग कर रहे हैं ऑलमोस्ट हम हैबिटेशन एरिया से हमारी टर्निंग हो रही है हाईवे जो बन रहा है हैबिटेशन एरिया से बन रहा है जो भी है यहाँ पे वो एकदम पास में और वर्टिकल कवर भी 25 मीटर से लेके 100 मीटर तक वैरी कर रहा है। यहाँ पे एक नॉर्मल ब्लास्ट करना इतना आसान नहीं था, इसलिए हमने यहाँ पे सोलर टेक्निकल सर्विसेज को हायर किया। उन्होंने स्टडी किया कि कैसे होते हैं, तो उसने अपने हिसाब से स्टैंडर्ड सेट किए कि ड्रिलिंग पैटर्न क्या होगा। तो ईच एवरी ब्लास्ट हैज अ डिफरेंट scenario and different lateral covers. So we have to execute each and every blast to control the vibration as well as noise, and to make sure that there should be no nuisance created by our blast. So that is our first priority right now. क्या मुझे पता लगा कि सोलर प्रोजेक्ट्स यहाँ पे बैकएंड लेवल यूज कर रहे हैं, तो आपकी टीम ये पूरा डेमोस्ट्रेट किया। डेमोस्ट्रेट करने के बाद हमें भी बहुत अच्छा कॉन्फिडेंस है कि हम लोग कर पाएंगे। मुझे तो बहुत अच्छी टेक्नोलॉजी लगी ना, मैं तो ये चाहता हूँ कि फ्यूचर में और कुछ टेक्नोलॉजी यूज करें।
Thank you very much. We'll have a very one single question quick because we are running late. Any one question? Oh, okay.
Really interesting. Now, using this electronic detonator, we can go ahead. Now it is proved. Really, I appreciate it. And what I just wanted to ask one question: what is the difference in cost if you are using electronic detonator and nonel? Cost, yes.
Yes, sir. So, sir, cost analysis wise, now also, as you have seen for last three years, that cost of electronic detonator is continuously going down as the volume is increasing. And second thing is that in tunneling, the total cost depends on the pull and fragmentation and cycle time. So if we can reduce that, and we have observed that the pull which we have achieved with the electronic detonator was far better than ASCA conventional. So the total cost analysis wise also it is beneficial, but I cannot disclose that cost here. So that's the thing. But every time the pull was far better and cycle time was reducing. So in every blast pull was improving. So total cost was reducing, sir.
Yeah, that's good. Thank you very much. I think the future is that you'll have to go towards the electronic detonators anyway.
Yes.
Thank you very much. We'll have the next question, please.
Thank you so much. Thank you so much.
Yeah, thank you.
Thank you, sir. Thank you. It was a pleasure to standing over there. Thank you so much.
Yeah, next paper will be paper ID is 70 or 136. Paper title is Positive Externalities Evaluation of Reclaimed Open Cast Mines of Telangana Considering Vegetation as Base Parameter. The presenter is Amar Padol. Yeah, you have around 7 minutes to present.
नहीं आ रहा ना लेकिन इधर तो ये वाला स्ट्रक हो गई लैपटॉप स्ट्रक हो गया कजन आया
Good afternoon, everyone. My name is Amar Padode. I am from CSIR Niri. Our research topic is positive externalities evaluation of reclaimed open cast mine of Telangana considering vegetation as a base parameter. Open cast coal mine, while crucial for energy demand, create several environmental damage like destroy existing vegetation, disrupt soil quality, soil profile, and degrade entire ecosystem. Our study objective is to quantify vegetation changes cover between 2015 and 2025 using NDVI, evaluate economic benefit using social cost of carbon, and provide site-specific insight. Our study area include 6 mines operated by SCCL, which is Gautam Khani open cast coal mine, Koyagudem open cast coal mine, Jawahar Khani open cast coal mine, Kakatia Khani open cast coal mine, Dodli 1 and Dodli 2 open cast coal mine. Let me explain our methodology. We employed a mixed method approach combining remote sensing, field data, and economic valuation. For remote sensing, we use Landsat 8 imaginary using USGS Earth Explorer, which provide consistent high quality vegetation data over time. The NDVI normalized difference vegetation index our primary metric. NDVI value ranges from -1 to 1. We validate our satellite observation with field data to ensure accuracy. For economic valuation, we consider vegetation improvement into carbon stock estimate and then applied social cost of carbon framework, essentially translating ecological gain into monetary framework, monetary value. Let me briefly explain how NDVI work. The formula NDVI is straightforward. NDVI equal to NIR reflectance minus red reflectance divided by their sum. Healthy vegetation strongly reflect NIR light, absorb red light for photosynthesis. Now we come to the heart of our finding. The comparative map show the dramatic transformation between 2015 and 2025. Notice the shift in color. The green areas representing highly vegetation have expanded significantly across all 6 mines. The red and brown area including barren or degraded land have shrunk considerably. Let me quantify these changes for you. Gautam Khani open cast coal mine showed the most impressive recovery. Vegetation area increased from 2.99 square kilometer to 5.807 square kilometer. That's expansion of 2.81 square kilometer of new vegetation, followed by Jawahar Khani open cast coal mine increase of 2.38 square kilometer. Critically, every single mine showed net positive vegetation growth. Now let's translate the ecological improvement into economic terms. We estimated carbon stock using social cost of carbon. We estimated carbon stock using established relationship between NDVI value and carbon sequestration capacity. Research showed that vegetation with NDVI value 0.17 to 0.85 range can sequester approximately 46.32 ton of carbon per hectare. Using the social cost of carbon approach, we represent the economic damage caused by 1 ton of CO2 emission. We calculate the value carbon stored in the recovered area. The formula account carbon stock per hectare based on NDVI, total reclaimed area, the social cost of carbon in USD, purchasing power parity to convert it into Indian rupees. Here are economic benefit. GKH OC lead annual benefit of approximately 2.16 crore from carbon sequestration alone. JKH OC follows with 1.82 crore annually. KTK OC 2 contribute 1.66 crore. Dodli OC generate 1.24 crore, while KOC 2 and Dodli OC 2 contribute 0.52 crore and 0.56 crore respectively. The combined annual benefit across all the 6 mines is 7.96 crore. Let me step back and consider what these results mean. First, the consistent vegetation increase from 2015 to 2025 proves the systematic reclamation work. Second, this ecological improvement deliver multiple benefits: enhance the vegetation, stabilize the soil, preventing erosion. Third, the carbon sequestration represents measurable climate mitigation. Fourth, the economic valuation of 7.96 crore annually demonstrate that the reclamation is not just an environmental obligation, it's an economic investment with the quantifiable returns. Conclusion. Let me consider with one of our key takeaways. One, remote sensing based NDVI analysis provide a reliable, scalable and cost-effective tool for monitoring reclamation progress across the large mine area. All the 6 opencast mines show significant vegetation recovery over a decade. Economic valuation using social cost of carbon framework reveal substantial annual benefit of 7.96 crore, demonstrating that the effective reclamation generate measurable value. Fourth, site-specific results provide actionable insight for adaptive management. 5, the integrated approach combining remote sensing, field validation and economic valuation offer a replicable framework for other mining region in India and globally. These are the reference. Thank you.
Thank you, Amar, for completing the presentation within time. Any quick questions? Okay, we'll go to the next presentation.
Yeah, thank you. Next paper ID is 72, Strategic Economics of Rare Earths, India's Opportunity. This presenter is Arun Vijayan. Is he available here?
Yeah, sorry. That's okay. So good afternoon, everyone. Thank you to the chair and to ISAMET committee for the invite. I'm Arun Vijayan, heading vertical on metals, minerals and mining at Barrow. And today I'll be exploring, where is the display? Yeah. And today I'll be exploring the strategic economics of rare earths and why India's next advantage lies beyond the mining gate. So the 150 papers that we saw, I think only around 10 or 15 were concentrating on rare earth. And this will be more confined towards the economics aspect of it, beyond what is there in mining. So, global rare earth is highly concentrated. China controls separation, metal manufacturing, alloys and production. That single node dependence exposes EV, the renewables and most probably and most importantly the defense segment. And it's subjected to curbs, political tensions, geopolitics. And this is happening even though India owns like 6 to 7% of monazite reserves. And the issue here is we are not capturing more than 10% of its value. So the core question that I'll be exploring here today is, can India move from an upstream extraction to a resilient mine to market role? So here's a backbone of the study. We'll be touching upon 4 different aspects. One is a cost curve benchmarking across individual stages from mine to market. The trade flow mapping, which I've done through UN Comtrade, which is a trusted secondary source. We are looking at 2 scenarios, the baseline versus the accelerator strategy, and it is modeled to 2035, that is 10 years down the line. I prepared this in the month of November. And finally, we'll be touching upon the policy risks, ESG filters. This is to keep the numbers realistic and ideal to the scenario. So, a quick roadmap. We'll be covering 5 sections here, and I'll walk you straight through them so that we can stay in time. If you look at the slide, China delivers more than 70% of rare earth output. When it comes to separation, it is around 80% and more.
And when it comes to the magnet manufacturing, especially NdFeB, which is used in permanent magnets, it's completely reliant over there. This itself showcases heavy rare earth supply shocks, especially something that has been happening of late, maybe a Myanmar curve or anything that, let's say, the dominant industry looks at. The ripple is showcased throughout the geography, and it is reflected in the global market within a span of a week. This is the exact risk why every OEM is hunting a China plus one strategy. And in my opinion, that is exactly the window which India can literally focus upon. Now that we spoke about the global scenario, where do we stand? Abundance of monazite and other upstream raw materials will be India's strength. But the gap, if you look at it, it's non-availability of a commercial high purity separation. There is no large scale alloying, almost zero magnet output, and that's the reason why less than 10% of whatever reserves that we are having is realized. In such a scenario, any vulnerability, the price spikes, we will have to bother. So we are always dependent on pricing. And how this can be checked out? Just give me a second. Yeah. So the policy mix, it enables a controlled participation, import proven solvent extraction technique. I'm speaking of midstream here because midstream is the area that we need to focus on. Building coastal clusters, co-locating upstream, midstream and downstream industries. The result would be value addition. What we saw as less than 10% now will climb to 25 to 30% of value addition, and the result would be reduction in trade deficits and India stepping into an OEM's preferred sourcing list for the finished product, and that is exactly what we would need. How do we compute this as against current scenario? Side by side numbers points the story. Baseline keeps India import dependent. We are exposed. An accelerated scenario wherein an investment of, let's say, 2.5 to 3 billion is what I had expected. If you look at it and provide the investment in the splitter that is provided, what we see is the accelerated scale of separation can be achieved in. First, domestic magnet lines can be opened up, and heavy rare earth security via recycling and maybe overseas offtake, and that will help us further in the scenario. When we look at policy levers, competitiveness now hinges on to ESG compliance and traceability and not the cheapest ore that is available. Key levers that I've identified is streamlining permits, JVs with tech transfer, hydrometallurgical recycling, and alignment with EU, CRMA and US defense sourcing rules. This has been kept in because there is a lot of discussion happening globally throughout who can be the alternate for China. What is to be taken away from the slide? I would say 4 C's. One is capability beyond mining. Second, cluster formation to unlock the scales. Third, compliance with global ESG guidelines. And fourth, collaboration across government, industry and academia. Execute these and India would be a credible mine to magnet alternative the world is searching for. So that sums up what I had to explain. And to sum it up, before I do have time, this was developed in the month of November, and I had expected an investment of around 2 to 2.5 or maybe $3 billion if India is investing. And what we saw on the budget from Nirmala Sitharaman on Feb 1st clearly determines what we just saw. Investment in midstream, and the value stands at around $1 billion. So what we can see is the progression that the government is making is exactly in its line. 2025 budget saw us providing, let's say, value to upstream. 2026 budget showcased cluster formation. It's the same term that I had used here. Cluster formation. There was a cluster identified between Orissa, AP, Tamil Nadu and Kerala. There is a joint venture mentioned by Nirmala Sitharaman, 6,000 metric ton per annum. So exactly this is what India would be requiring, but I would request the policymakers to increase the budget that is allocated to midstream to maybe a $2 billion, that is like 14,000 crores. And finally, I would say the next budget, India should be focusing on downstream, which is magnet manufacturing and recycling. Thank you.
Thank you. Thank you, Arun, for a wonderful presentation. Any questions from the audience? It's kind of interesting that you did this analysis like 6-7 months before the budget is presented, and it's important that like no single country can have a domination, because this is important aspect for the global like a situation with the changing geopolitical situations that what are happening. So thank you very much.
Thank you.
We would have the next 5 papers are. Do you have one question? Okay. We'll take it one
Certainly,
only, okay?
sir.
Very quick.
Yeah.
So I think we hold to 3% of global rare earth resources.
Correct.
And what referred to the Indian Union budget. Most
Yes.
important aspect is what we see, even if you have those rare earths with us, the process of beneficiation is very slow, time-taking, and technology.
Correct, sir.
Wherein our nation is lagging. So please throw some light. What time period will it take?
I had
To
explored
reduce our
exactly.
dependency.
Yes, sir. I had explored this exact question. So, as per assessment, we are at least 15 years behind China in heavy rare earth, 7 years behind rare earth. The reason why we need not worry about heavy rare earth is it is used in magnets that goes into automobile industry, and neodymium. This is used in reduction of temperature that comes in when the wheel rotates. So there are technologies which can be substituted, which is successfully pilot driven by BMW, Toyota, and others. So heavy rare earth need not be concerned. And I spoke to IREA, CMD, ex-CMD, day before yesterday. So he was also the same impression. Whatever is required for strategic purpose, that is defense, the IREA has access to it. So our concern should be separation, purification, magnet manufacturing, focusing rare earth, which is around 5 years away if we are not reinventing the wheel. I mean, there is already technology available. JV should be the ideal way that we should proceed.
Yeah. So do you see any PLI kind of support in this sector from our union government?
Union government is clearly on track.
Because it is all mining which is dictated by our mineral policy, right?
Correct, sir. So government
when
clearly...
it comes to exploration, exploitation, licensing, all that, there are still certain bottlenecks which prohibits. Say, for example, still it is lagging. An exploration agency need not to be exploitation agency. It is retendered. So that is what I see a major bottleneck in mining of rare earths when it comes to private sector participation.
You are correct, sir. So the government clearly understands the urgency and requirement for participation. What is lacking is the speed of execution. And I'm pretty much sure the finance ministry, and I think this falls under Energy Association right now because thorium and all is involved. But by next budget, I'm pretty much sure, or maybe if there is anyone from the policy making, if they can solve us out, I'm happy to share my insights with them.
Thank you. Thank you, Mr. Arun Vijayan. And my compliments for a wonderful and very much relevant presentation. Thank you.
Thank you. Thanks a lot. Means a lot, sir.
We will have now the next is online presentations, right? Number 9.
Yeah, regarding this online presentations,
Due to some technical problems, we'll. Okay, okay. So it's working now. Fine, fine.
Good day to all. My name is Sumit Kumar from MIT World Peace University, Pune. Today I will be presenting our research titled Numerical Investigation of Displacement Behavior and Optimal Spacing for New Tunnel Adjacent to Existing Underground Facilities. This study focuses on understanding how a newly constructed tunnel is an existing tunnel when both are located close to each other. Content. The presentation will cover introduction, research methodology, geotechnical parameters, results and discussion, conclusions, limitations, and future scope and references. Introduction. Urban infrastructure growth has increased the need to construct new tunnels very close to existing underground facilities. However, tunnel interaction can lead to deformation, stress, concentration, and safety risk. Current studies lack clear guidelines for spacing and angular alignment. To address this gap, we performed a 3D finite element analysis using Midha's GTS NX to examine displacement and stress behavior under different spacing and angle configuration. Research methodology. A three-dimensional finite element model was developed. The new tunnel was positioned at different angles and distance relative to an existing tunnel. We evaluated displacement at crown, invert, and side walls, along with solid stress and surface settlement pattern. Geotechnical parameters. These are the geotechnical properties used in the model, representing competent hard rock. Parameters include unit weight, Young modulus, Poisson ratio, and cohesion values, which govern how the surrounding ground responds to excavation. Spacing and angle variations. The study considered multiple spacing ratios and angles between the new and existing tunnels: 30 degree, 45 degree, 60 degree, 90 degree, and 180 degree. This allowed us to capture a wide range of tunneling scenarios encountered in the field. Results and discussion. Displacement was chosen as the primary indicator of tunnel serviceability. We observed mainly four cases. Ground displacement increase when the new tunnel lies above or close to the existing tunnel due to vertical stress redistribution. Side walls showed the maximum deformation when tunnel was horizontally closed, indicating lateral stress transfer. Third crown displacement is more sensitive than the invert. And fourth, sidewalls emerged as the most critical structural component controlling collapse risk. Displacement analysis. Figure 4a and 4b, these figures shows displacement contours for 30-degree and 45-degree orientation. As the angle changes, the load transfer path also changes, which directly affects deformation behavior. For all angles, 30 degree, 45 degrees, 60 degrees, 90 degrees, and 180 degrees, a consistent pattern was observed. Smaller angles and close spacing produced higher displacement. Solid stress analysis, figure 5a and 5b. Excavation lead to stress redistribution around the tunnel surface. Our result shows minimum stress concentration occurred at 45 degree, 60 degree, and 90 degree positions. These are safer configurations. Maximum stress concentration occurred at 30 degree and 180 degree, making them structurally critical. Therefore, these are not recommended for new tunnel alignment. Surface settlement analysis. Surface settlement was also evaluated for all angle combinations. Higher settlement occurred when the new tunnel was close to the ground surface or directly above the existing tunnel. Angles of 60 degree, 90 degree, and 180 degree produce comparatively smoother settlement through ranking system, table 3. Based on sidewall displacement, a ranking system was developed to identify the optimal alignment. This allows designer to quickly determine safe spacing, angle combination during preliminary planning. Conclusion. The major conclusions are: tunnel interaction is highly dependent on spacing and alignment. The most stable configuration was at 180 degree with 0.6d spacing, showing the lowest deformation, 1.63 to 1.65 mm. Third, the least stable configuration was 90 degree vertical proximity, producing displacement up to 41.98 mm, approx 42 mm. Sidewalls should be used as the primary indicator for safety assessment. Fifth, general recommendation: maintain spacing of at least greater than or equal to 2D for safe tunnel development. However, optimal spacing depends heavily on geological conditions and excavation sequence. Numerical modeling must be complemented with field monitoring. Limitations and future scope. The study assumed homogeneous hard rock condition, groundwater, seismic effects, construction imperfections, and time-dependent behavior were not modeled. Future work will include heterogeneous geology, hydromechanical coupling, seismic vulnerability, AI-based monitoring, and risk prediction. These will help improve tunnel stability assessment in real-world projects. References. These are the key studies that support this work, covering settlement behavior, twin tunneling effect, numerical simulations, and underground infrastructure stability.
Yeah, it was in recorded video from Sumit Kumar. For this session, for this paper, we don't have any question here. So next we will go to paper number 127. Is sunlight transformer based storyboard.
Sir, may I leave the conference now? Okay,
Yeah,
thank
he's
you,
online. Anna ji Venkata Suresh.
మినిమైజ్ చేయరా అది ఏది ఓపెన్ 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 చేస్తున్నా
Venkata Suresh is online.
Hello, sir.
Yeah, Venkata Suresh.
Sir, is this visible to you?
Yeah, 1 second. We are setting up.
Okay, sir. Good afternoon, sir.
Yeah, 1 second. We are setting up your display. Is it? Okay, you can go ahead, and you have 5 minutes time, so that you can complete your presentations within 5 minutes. Yeah, carry on.
Okay, sir. Okay, sir. Good afternoon, sir. Today our topic is screen array transformer based storyboard generator for science projects. Here we have the abstract of this is screen array transformer based storyboard generator it generates classroom storyboards science projects using names as an input for the primary. This is the primary objective, sir. And also, while improving clarity, consistency, and safety awareness, the science education. Sorry, sir. Sorry. Yes, sir. No. The system generates key components and conceptual narrative, a structural step-by-step procedures, and develop detailed laboratory safety guidelines using advanced transformer models such as FLAN-T5 and also text generation model embarked for multilingual translation. By improving rule-based formatting, prompt engineering, and user-friendly interface, key narrate ensures reliable age-appropriate and well-structured outputs that produces system-enhanced accessibility through multilingual support, enables quick distribution via downloads PDF, and promotes safer laboratory practices, making it an effective AI-driven solution for modern science classrooms. The main objective is to design and develop AI-based systems that automatically generate structured science experiments documents for single experiment item. To generate clear narrative explanation, step-by-step experiment, produces an experiment specify safety guidelines using transformer-based language models. To improve accessibility and inclusivity in science education through multilingual content generation. To reduce the manual workload of teachers while ensuring consistently reliable classroom-ready instructional manuals. Proposed systems key array transformer based education content generates design assist school level science education. In this test input prompt story generation using FLAN-T5, step-by-step procedure generation, automatic safety detection, optional multilingual translation using embarked and M2M100. Final output as a download PDF or online. This makes system practical for use in low resource classroom. This is the proposed system, sir. First presentation layer. This you should give the inputs. In this you should give the inputs of the particular project, and then this second layer will enhance that and generates the story and also multi-language. This layer converts that into story and sends to this. This you can see in this. You can, the normal output will be shown, and this final output will be downloaded in different languages. And then, sir, key functions used in the proposed systems are FLAN-T5 for generating story type science projects. User instruction turning to handle narrative and procedural formats. No need of dataset or fine tuning. You can type the name, yes sir. Safety alert generator. Rule-based keywords phased from general steps. Ensures experiments include warning, use gloves, and etc.
Yeah, Suresh, come to
Further
conclusion.
sentence.
Yeah, Suresh, only
Multi-language
1 minute
support.
to go.
Sir?
1 minute. You have 1 minute. Please.
Okay, sir. This multi-language support uses Embark to help to other language people also. Proposed systems. Advantages is education. It is generally used for science projects for children, sir. To unlike generates easy to use and use it to generate for projects for the children. Zero set generation. No data set or model fine tuning required. Ade. And multilingual supports native language and classroom. And results. These are the results, sir. The system generates structures if you give the minute. Okay, sir.
Okay.
This is okay, sir. Thank you.
Yeah, thank you, Venkata Suresh. It was nice presentation. Yeah, thank you.
Thank you.
Yeah, I'm going for next presentation. That is paper number 77. Is he available? Is online? Yeah, high wall mining feasibility studies at different mine sites in India. Presenter is Manoj Khanal. Is he online?
I am online, but I'm not able to share my screen. I think I person from there to share my screen.
Yeah, Manoj. Yeah, Mr. Manoj, you can share your screen, presentation screen.
I'm not able to share my screen because of the permission thing. I need permission to share the screen.
Okay, you can start your presentation. You have 5 minutes to go, sir. Yeah, please.
Yeah, I'm happy to present. I'm waiting for here, but to show my slides, I need permission from you guys. Please blocking my screen. Yeah. Now, do you hear me now? Okay. So, my name is Manoj Khanal. I am one of the co-authors of this paper, and there are Mr. Atul Khatak, Mr. Bautan Singh, Dr. Rao Balusu, Mr. Pramod Kumar, and Mr. Pawan Kumar. We all are the authors of this paper. This is a collaborative project between CIL India and CSIR Australia. So, as we know, hypermining is a remotely controlled mining method which extracts ore from the base of an exposed high wall, and there are different types of high wall. We can see like single auger and double auger here, as well as we have the rectangular continuous high wall mining. I think you all know about this one, so this time limitation I have to go a bit quickly. So I'll cross it quickly. So because of low capital cost and the short lead time, is very popular, where you have where the limit is reached by the open cut method and uneconomical for underground method for extraction. So the success of the high wall depends on the proper selection of the sites, which are geotechnically suitable, which I'll show in high wall mining index, and also proper design of the mining layouts and pillars. Having said that, even though everything is done as planned or perfectly, but there are some cases where this has been shown as a failure or failure cases. So to avoid that, sometimes numerical model is one of the tools to look at the problem. So CSIR has been working in high wall mining for the last 20 years in Australia, and we have developed an SMI index as well as the high wall design mining guidelines, which are based on that we work on the project. There are 4 different aspects of the project. One is the field visit, and we are using the high wall mining index, and we did empirical approach and the numerical model. So during field visits, we come to the various geotechnical aspects, like for example, we can see here reserve coal available, coal seam thickness, roof conditions, measured geological structures, overburden depth, and all those parameters which are listed here that we inquired or we discussed with the mine managers and engineers. We did that in fact for 21 different mines in India. But in this paper, I'm trying to give one example for one of the mines we visited. And these are the 15 points or key parameters which have been placed in the Australian condition. And this is our reference to the high-wall mining index. And it's like there are 4 categories. One is the very critical, the most critical parameter called the roof condition. And the B, which are denoted by A. And the B's are the one which are critical parameters which we have to consider, and this is the way, like for example, if you look at number, excellent, good, fair, and poor, this is more like an experience and a visual observation. You start writing the number based on your confidence level, which are required to calculate the mine index. And the C groups are the ones with the subcritical parameters. And the D groups are also parameters which are very important, but which can be tweaked in design. So these are the critical parameters which you have to consider as well. So so based on this, for example, all those parameters were evaluated using the numbers. It's more from the experience and the people getting knowledge and the information from the mine site. So you develop, you score the number, and also similarly you find the confidence level. And based on this everything method, we calculate the high-wall mining. And the mine, in fact, we have done 21 different mines, and it's almost everywhere here. But in this particular case, I'm giving an example of the one which falls in this category, high-wall mining index and the confidence index in the first quadrant. So, and this now we go to numerical modeling. In numerical modeling, this is one of the mines we considered, and so we tried to create all these mines as close as possible with the field data and created the numerical model at 3 different sections. There are 4 different sections.
To come to the conclusions, please.
The one has false, so we have to ignore that. These are the limitation of the technology. And there are already 3 coal extracted in that area. The beauty is that there is a lot of high-wall mining, high-wall reserves in that area.
Sir, so you have 1 minute to go, sir.
This numerical model, we calculated the overburden stress, and using overburden stress values, we use the empirical formula as well. What we did is that we calculated the minimum width of the pillar for the high-wall mining and with the factor of safety. It's interesting. The factor is very higher here, which are very, and the NP area, like the mouse is showing, there you have more factor of safety. But it's designed for also multi-stream mining. So in that case, we have 2 options. Like either we have given distance between the seam A, seam B, and seam C. We have to find optimum design parameters.
So Manoj sir,
one example, like one example of aligned and non-aligned design of the one. When 2 strips are very close, they're apart by just 4 meters apart. Just the seam height is a bit less. You could see the bit less, bit smaller pillar, but we can't have a smaller pillar because the thicker pillar here it has to carry those loads. So technically, we have to align those 2 pillars, which we can see here. In that case, we might be losing coal here, but we provide the stability here. In that way, we derive the fan layout for all 3 different sections here. Which as an example, I have put one section, 2 sections here. So we can see the fan layout and the fan layout. It's a mixture of the layout, and this one is factor of safety overall is 3.5 calculated. And also, interestingly, in this region, all 3 streams, what we are analyzing at the moment, were extracted already. It's already the bottom of the stream. So we have to design a very careful extraction sequence, which also comes with experience. And this is the way. First, what we do, we fill up everything, and then in the step 2, we fill up, and in step 3, we started from the bottom of the seam, and we gradually goes up by back filling the seam.
Yeah, Manoj sir. Yeah, Manoj.
Here.
Yeah, you have.
This is the extraction estimation. So, and at the same time, one critical parameter is the span assessment. That is why we empirical formula, CSR formula, and also we use different site analysis. We created this one, and we can see that this is this site is stable. So, because of time constraint, I have to move very quickly. If you have any questions, please let me know now, or maybe feel free to send an email. So yeah, so this is one of the examples you could see here. If you have the very weak span, then you could see the falling of this one, which makes it unstable. But in this current case, what we studied, it is stable. So this is the current. Thank you for your attention. I think
Thank
I
you,
managed to do
thank you,
5 or 10
Manoj,
minutes.
for your interesting presentation. Sorry, we are running a little late on this time, so we will not be able to take any questions. With this, I think we come to the conclusions. We had the 8 formal presentation in physical form, and then we had 5 online presentations. The topics that covered in on this session is mostly like into the blasting, but there were also mix of like rare earth minerals and the environment and all the very relevant topics. So I think I would like to thank all the authors and the presenters who did their job wonderfully. Thank you very much. My co-chair, if you would like to add things. Okay, that's good. Thank you. I will hand over the mic to the organizers.
Thank you, sir, for your insightful guidance and smoothly conducting and steering this technical session. So in this session, we have witnessed a series of informative and thoughtful provoking presentations that addressed key challenges and advancement in the mining sector. I congratulate all the presenters for their excellent contributions. So now I request our session chairman, Dr. J.P. Aglave, and co-chairman, Mr. G.C. Naveen, sir, to come on to the stage and kindly felicitate the presenters as a token of appreciation for their valuable research contributions. Sir, ऊपर आ जाइए. Sorry, watch out. So our first author, Dr. Chandrani Prasad Verma. Our second presenter, Mr. Abdur Rahman. Mr. Abdur Rahman. Okay. Yes. After our third presenter, Dr. Savliana. Our next presenter, Mr. Firoz Ali. Okay, sorry. Mr. Sunil Kumar Dhar. Our next presenter, Mr. Gopinath Ji. And the last presenter of this offline session, Mr. Arun Vijayan. Mr. Arun Vijayan. Okay. Our one, two more are there. Next is Mr. Anjani Bhograju. And one more last, that is Mr. Amar Padole. Mr. Amar Padole. Yes. Okay. Yes, sir. Now I request Professor Rajesh Gupta, sir, Head of the Mining Engineering Department, to kindly felicitate our respected session chairman, Dr. J. A. Aglave, sir. Now I request Dr. Anupam K. sir to kindly felicitate our respected session co-chairman, Mr. G.C. Naveen sir. So now we come to the end of this session 7A. So with this, we conclude the technical session 7A of ISAMET 2026. We will have now a tea break of around 10 to 15 minutes. I request all of you to reassemble in this hall in 15 minutes so that we may proceed with the valedictory session, which also include awards in different categories. So thank you, everyone.
Please join for the tea. Thank you.
Mr. Tapesh is there in this hall or chale gaye bahar?
Hello. I request all the participants, please gather in the hall. We are going to start the validatory function within 5 minutes. Again, I request all the delegates, please gather in the hall. Because already our guests are here, we are going to start our validatory function within 5 minutes. Good evening, one and all. So we are here at the end of the 2 days schedule of International Symposium on Mining, Environment and Tunneling, ISAMET-26. It's been a wonderful journey last 2 days with so many different technical aspects we could learn through this. And for the today's validatory function, we have some of the stars of the academia and industry with us. It's a very proud moment to have with us the dignitaries on the dais. Next to me is Dr. Hemant Sharad Pandey. He is the Personal Director HR of Western Coalfields Limited. Also currently being selected as the CMD of WCL. Next to him is Shri Indradev Narayan, CMD of MECL. We have with us our HOD, Shri Rajesh Gupta sir, Dr. Rajesh Gupta sir, HOD Mining. He is the president of the function. Our another distinguished alumni, Professor VMSR Murthy, Director IST Shipur, and the advisor of this entire symposium and our guide philosopher, Dr. Rajendra Yerpude. I request Yerpude sir to please welcome Dr. Hemant Pandey with a floral bouquet. I request Dr. Ajay Agrawal to welcome Sri I.D. Narayan with floral bouquet. I request Dr. Nachiket Bhagade to please welcome Sri Professor VMSR Murthy with floral bouquet. All the delegates, as we have witnessed this wonderful journey and understanding different paradigms of mining, tunneling, environment through these 2 days, I'm requesting our advisor to the symposium, Dr. Yerpude, to present the report of the symposium in front of the audience. Please come in. Professor Nikhil Sardesai will also be joining us shortly.
Namaskar and good evening. Welcome to this concluding ceremony, that is a valedictory function. Greeting to all. Today we are having the decorated, illustrious alumni of the VNIT on the dais, and we are very proud of them. We are having Dr. Hemant Pandey, who is the presently Director Personnel, and he is designated CMD of Western Coalfields Limited. We are having the Sri I.D. Narayan, who is the CMD of Western Coalfields Limited. Sorry, he is the Mineral Exploration and Consultancy Limited. We are having Professor Rajesh Gupta. He is the head of the Department of Mining Engineering. We are having the Professor VMSR Murthy, who is the Director of IST Shipur, Howrah. VMSR stands for Vemababu Mallika Sita Ramachandra Murthy. That is his full name. In the audience, we have the various dignitaries. Dr. Nick Barden, he is there with us. Dr. Daniel, he's from Colombia, he's with us. Professor I.L. Mutrija, he is a founder member of the department and he is instrumental and teacher of all the alumni sitting over here. Professor N.R. Thote, he is a senior faculty member with us, and all dignitaries and distinguished guests present over here, they are the limelight of this symposium. This symposium started with a lot of preparation earlier, and the organizing committee has taken a lot of efforts for bringing this symposium to this level. And this moment is of the celebration and happy moment for the two things. We are having the Dr. Hemant Pandey, who is elevated to the chairman cum managing director. That is the one moment, happiest moment for us. And second happiest moment is the culmination of the successful symposium. This symposium would not have been possible without the active participation of all of you, delegates, authors, researchers, and all other those who are participating in that. We were having the national as well as international guest and participant, star, lustrous keynote addresses by national and international important persons and dignitaries. First keynote address is delivered by Dr. Nagpur, who is very famous for his authorized queue system. He was there with us and he shared a lot many things with all the audiences and the participants. And in day-to-day planning and design of the tunnel, we do use his queue system for many things. Then the other keynote addresses, specifically I wish to mention with regard to the Professor Dev, then Dr. Y.G. Kale, then all other there in the series. Professor or Dr. Nikhil Desai will give the complete report of that. How was the deliberation, how were the things were there. You know that this mining environment and the tunneling, here the environment is kept at the center. Reason is that we have given the thought to it, environment should be at the top, because all the activities will be revolving, whether it is a mining activity or maybe tunneling activity, revolving around the environment. Because the environment is there, good environment is there, then only human life will be there, whatever the activities that are taken. Mining and tunneling, really these are a necessity of the human being. Mining supplies the all raw material to the industry, whereas tunneling will give you the infrastructure which is necessary for the development and connectivity easily. Other things that may be necessary with respect to the various things associated with the either is the tunneling or is this mining. But you know that the mining and tunneling, they are all site-specific activities. And all engineers, whether the civil engineers, because here the gathering of civil engineers, geologists, and mining engineers, we need to see that since it is a site-specific activity, mining, whatever the requirement is there with respect to the environment, that should be taken care. We don't have any choice, because wherever the mineral is located, you require to go there and mine it. So here in this symposium, whatever the things that may be discussed or that they discussed earlier, that is all related with the environment and sustainable mining, whatever the buzzword you use, but everything that goes to the environment related thing. Tunneling has got some choice, but mining doesn't have any choice. Tunneling, you can have some kind of alignment changes, making some changes with the route. It is possible. But as far as mining is concerned, there is no choice at all. The deliberations, what is that is associated with all this aspect, and we are very happy that the deliberations and the discussions and whatever you think that maybe networking, this platform has provided the various aspect of deliberation and thinking. Here what we say that because the symposium is only for the 3 days, 2.5 days, it is not possible to discuss each and everything. That is not possible. So generally I used to say to my pupils that we give the fruit for thinking, fruit of thoughts. Or sometimes we may say that we'll give the idea for the thinking. So this symposium is marking that thing. That is whatever the initial idea is during the presentation, other thing that is given, and that is really maybe useful for the further kind of now your discussions and thinking. And we are hopeful that when you return back to your respective places, naturally this whatever the discussion is there, we can prolong it, start thinking, so that the Mother Earth will be saved, and whatever the activities you undertake since inception to the end, whether it may be anything, whatever the stability, then the monitoring, using the AIML approaches for that, or any other thing, we require to see the environment, because the environment is the first thing for the sustainability. So that's it is a built-in component for while taking any kind of thing. Dr. Shamnam from the Colorado School of Mines, he also gave the very good presentations on the AIML. He published so many papers with regard to the geoinformatics and all of the things that is necessary for the hazard detection. Likewise, Dr. Haas has given the presentation on the new system he designed for Australia, and he is there in India only, with regard to the IS system. IS system, it has got so many parameters which are required to be considered when you go for the designing, planning of the mining activity or maybe tunneling activity. So there is a comprehensive kind of approach, and that approach is really useful, and that is approach is adopted by the Indian Railways also for the tunneling. So that approach can be used along with the whatever the approaches are there with respect to that is given by the Dr. Nick Barton. So that will be at some extent we can make it really stable openings, and which will have the minimum kind of hazards and these incidences. Okay, so with this kind of thing, this symposium may be coming to an end, but yes, we have to take a pledge and hope that whatever the things we undertake with regard to the either mining or tunneling or any kind of allied activities related with that we require to use whatever may be the available technology or available methodologies or innovative research or ideas for the saving of the earth, Mother Earth, so that there will be a lot of sustainability. It may be from the beginning to the closure. But for the tunneling, it will last for so many years. There also, some components has to be there. He's there, and this requires the maintenance and all other things. Okay. With this, I will conclude myself here, and others, stalwarts, our illustrious alumni are there. One thing I want to mention that in this symposium, alumni of the VNIT are many participants, and they have actually used their knowledge, their intelligence, their leadership, and all other skill here during the deliberation. And we are proud of our all alumni of the VNIT. And I wish that they will again will contribute to the well-being of their own companies and to the fraternities, the civil, mining, and whatever the structural stability that may be necessary. Please give the big round of applause for our alumni and to all delegates and participants of the symposium. Because without all the participation of all, this symposium would not have got this glory. We are thankful to all for all their efforts and the contribution and cooperation for this purpose. This L&D construction and the VNIT, we have got the collaboration with them, and we are training their site engineers to the particular level. And we are happy that those site engineers are performing well when they are going to the field. Likewise, we expect that whatever the deliberations are there during this symposium, this will be really helpful to all the researchers, planners, designers, and other things. With this, I thank you all for attending the symposium. I thank all my colleagues and the organizing committee members, my dear students, for making this symposium at this level. Thank you very much.
Thank you, Dr. Yerpude sir, for your enlightening words. It's really that your guidance, we are taking each step every day in our day-to-day work life as well as in this symposium. Now I have a very big task in hand that I have to introduce you today's one of the distinguished guests here.
I'm introducing in front of you Dr. Hemant Sharad Pandey. If I will read his CV, it will take a lot of time. I will take permission that I will be brief in that. So, Dr. Hemant Sharad Pandey, he's currently the Director HR of Western Coalfields Limited, and the just selected as a CMD of WCL. We hope he joins very soon. He is a vast experience in coal mining, more than 30 years. We have seen him, like I mentioned in my inaugural speech regarding Harish Duhan sir. He is also one of them that we saw them working in mines in Savner area when we are just students. From those days, we have seen their career profile, and in those days, believe me, absolutely, because he's not sitting in and I'm praising him. In those days, it was very clearly said about these people that they are director and CMD material from those days. And after more than 30 years, he has spent considerable time in Western Coalfields Limited, considerable time in SCCL. He holds a doctorate degree in management. He holds postgraduate degrees in management as well as mining. And as most of the other mining engineers, he also has a first class. And he's a visionary leader with vast and diverse experience in coal mining, land acquisition, industry relations. He has been a pioneer in Western Coalfields Limited. Since he joined HR, he has actually given a complete new dimension to the HR function, as most of his colleagues can witness that his style of working has been totally different. He has given a new dimension and doing wonders in CSR work. We can see that in social media and newspapers every other day. WCL is doing something new in CSR. So and he has, of course, for so many these activities, he has won many accolades and awards. One of them being the Best General Manager Award in 2022. So I invite Hemant Pandey sir for his speech.
थैंक यू सभी लोग सोच रहे होंगे ना इतने स्पीच आने हैं. मैं आई विल टेक एकदम छोटा, ज्यादा टाइम नहीं लेंगे. प्रोफेसर Hayal Muthreja sir, on the dais, respected ID Narayan sir, Gupta sir, my senior VMRS Murthy sir, again my senior Yerpude sir, and Anupam Kher, my very good friend, and sitting in front of me NR Thote sir, Yogesh Kai sir, Agrawal sir, Harshad Datar sir. So many sirs are there, Manish Murkute sir. I cannot take names of all the sirs. So I am good evening to you all, and I am seeing the proceedings of this symposium. It's a really great subjects are covered in it, and as a practicing mining engineer, I think all these things are needed for the future. With the perspective of Vidarbha, it is being now said that we have to stop the coal production and then move to some another energy resources. So it is there in the Honorable Prime Minister's Amritkal targets, and all these targets, if we see as a student or as a delegate of this symposium, all these targets seems to be very difficult but logical. So in this scenario, what we are planning as a Coal India Limited or as a Western Coalfields Limited is to diversify ourselves into some different energy resources. And one of that, you must have seen the union budget this year's union budget. It was presented just a week back or 10 days back. In that, the special grant is given for coal gasification, and the target is 100 million ton by 2030. So what actually we are going to do is, as a coal producing company, we are trying to come up with first surface coal gasification in Majri area, and we are on to it, and that will start a new era for the Western Coalfields Limited. And along with that, one of more important thing which has come up is we have tested our overburden in situ and also the overburden dumps, and in that we have found around 17 rare earth elements and critical minerals, and that is also a very good news for Vidarbha. And if we see the government's perspective, we are going to be a company with a very varied energy resources or a energy production company, and the total outlook of this company is going to change every day, every year. Now we have got around 30 open cast mines with all the huge amount of overburden, because the stripping ratio is very high in the Western Coalfields Limited mines. So we'll be testing all those mines. At present we have tested only 6. So we'll be testing all those mines and trying to find out what else is there in the overburden. That will be our waste to wealth solution also, and that will also help in our country's critical mineral mission, and that we are going to do. In this, I was seeing this symposium proceedings and papers. In that, I have seen one article on pest technology also. So that is also one of the requirement for us, so that we mine with all the environmental concern. All our underground mines are standing on pillars for want of sand stowing or say land constraints. So we'll be going for pest fill technology also, and that is going to be a very turning point for the Western Coalfields Limited, and for that matter all the underground mines of Coal India Limited. In all the subsidiaries this problem is there, and we want to make them cost effective also. And the most important part, as Professor Yerpude sir has said about the environmental concerns. So we should mine our mining operations with all the respect to Mother Earth, and we should protect Mother Earth so that the planet sustainability and all those targets are met in a style. So in this symposium such many subjects are there, and there are many dignitaries who have come from abroad also. So I think this is a very successful symposium on environment, mining and tunneling. I will change the order of it. And we all should be concerned about the environmental issues of Mother Earth. And I wish that such symposium are again conducted in a 6-monthly basis or a yearly basis by VNIT. And I take this opportunity to thank all my gurus here, professors who have taught us during our college days, and because of their blessings and teachings we are here what we are. Thank you. Thank you very much.
Thank you, sir. Your words will inspire young mining engineers, budding engineers to take up this as a serious career. Thank you, sir. Moving on to next, another distinguished alumni of VNIT, Professor VMSR Murthy, currently Director, IST Shibpur, and he is also the Professor of Indian Institute of Technology, ISM Dhanbad. We have already witnessed his keynote address. He has also chaired session for us. Dr. Murthy has an extraordinary career in academics. In fact, he is an excavation man. His solution in, I think, 20 years back in drilling, if would have been implemented, the industry could have seen a new era from that time itself. and he's still working. You have seen his work in underwater blasting. Now he's into administration, but that doesn't stop him from taking keen interest in research, and he's actively involved in research as well. So I request Murthy sir to please address the gathering.
Namaskar. It's a very pleasant moment to see, many known faces. After a long time, I'm coming back to Nagpur. At the outset, Sri Hemantji, the new designate of CMD of WCL, and ID Narayanji, and the head of the department, Rajeshji, and Professor Yerpude, the advisor of this conference, and Anupamji and Nikhilji, and the entire galaxy, particularly adored by our Guru, Professor I.L. Muthreja, the founder of VRCE and now VNIT, whose instructions were really helpful to, as already rightly said by Dr. Hemant, have set the chart for us. The all VRCians or VNITians, they were set on motion long back in 86. And it's a good number of decades have passed, and you see, along with VNITians or VRCians, it's a collective effort that has really pushed, particularly this area as well as the entire country and abroad also to the new level. So I think we must credit the kind of training or discipline that has been inculcated by the then teachers and the row of teachers that have really groomed us, and all the dignitaries sitting in the on the dais and off the dais, particularly the delegates from abroad as well as India, and which represents, it's nicely represented by academia, research and industry equally, along with our budding technocrats sitting here. It has been a very pleasant time for me for the last 2 days. I never thought that I'll be staying for entire 2 days, in spite of, a couple of things happening there. So after I assumed as a director of IST Shipur, but I found in the recent times, I never found, the entire audience sitting for the entire 2 days, full, basically. I think full credit goes to the organizers for conceiving the theme, as rightly said, environment, mining and tunneling. They say the same way. The theme was really encouraging, and it binds many people together, industry particularly, coming to academia, and this is a great opportunity for each one of us to cherish, that lectures that have been delivered, including, the keynotes that have been given and other lectures that were delivered by many industry practicing engineers. And I'm sure this particular forum would be repeated as, may not be 6 months, I think that 6 months is too early. Probably it could be at least repeated, once in 2 years at least. Now, this kind of cycle is always good. That's a good suggestion, actually, that the department should consider. And VNIT, being in the center of the second capital of mining, and mining being now interdisciplinary with tech, invading into. And today we had an opportunity of, visiting the integrated command center of, WCL, which is one of its kind, probably the initiator. The full credit goes to WCL and the entire team of WCL, probably. And I'm thankful to Mr. Satishji, who has taken us there, and then when we visited WCL in the morning. And I'm sure these kind of initiatives, and I'm also now listening that the academia is, behind the industry now, or as a couple of steps behind. So it's time for the academia and the research community to rise to the occasion, and the research statements or the problem statements should be driven now, or taken from industry with a good industry institute collaboration. And VNIT has immense potential with its interdisciplinary branches. Way back, we have started somewhere around 59 or 60, and then today we served a lot. And I'm sure Nagpur being, one of the key centers of, business, and this will be a great opportunity to work together and, elevate. And, particularly I would like to say that recently I had been to ISM for another conference. There also I didn't see this kind of, audience being there. But then there, the topics were on smart mining, and then critical minerals and green energy. These are the three things that are being now talked about. which are referred already by Hemanji. Critical minerals, I was talking to ID Narayanji that, MECL has a great potential to collaborate with, institute like VNIT or IIT ISM or IST Shipur, where I am right now. It's a huge opportunity to work together on these, national priority agendas, and our students particularly, our researchers, and more importantly, the faculty. I'll address this to faculty because the faculty members are the change makers, and they have to lead from the front, and they have to be the, role model to see that, the students are given topics that are of national importance, and they play a very active role in the nurturing of this talent and make, it interesting and create all the facilities that are required. I'm sure the industry leaders sitting here will not, mind in supporting the academia and research in the big way, as I see, the stalwarts like, Hemanji and ID Narayanji and many more who are there in coal industry particularly and other industries would come forward to give these problem statements and make academia and research personnel as strong stakeholder in the development of this nation. So then only it is possible, what we are dreaming of, the Atmanirbhar Bharat or Viksit Bharat by 2047. So with this, I once again congratulate all the organizers and all the delegates who have come and delivered, their, intelligentsia. And I'm sure these, as he said rightly, Professor Yurpude has mentioned that this is a short interaction, so the real work is still remaining. So two things are important. We work in isolation, so integration is one important thing I find at this point of time, and also the translation. So we talk about, many things, but when it comes to grounding, it's not happening in the real way that it should happen. So I'm sure these messages will go strong, and then all the community will work hard to make India proud and the third largest economy in this world. Thank you.
Thank you, sir. As rightly stated, mining industry is also going to contribute extensively in becoming the third largest economy. One more thanks that being a teacher, it is always difficult to shorten the speech. So keeping it precise, thank you very much, sir. I now request my colleague and organizing secretary, also the program coordinator, Dr. Nikhil Sardesai, to please submit the report of the symposium.
Good evening, everyone. Thank you, sir. It is a huge honor to share the dais with the stalwarts of academia, research, industry, and administration. I'm here to give you the report of the conference. So the ISAMET conference was privileged to host a distinguished lineup of keynote lectures representing the global mining, environmental, and tunneling communities. Their insights and expertise have certainly illuminated the event, setting a high standard of discourse and collaboration. Professor Nick Barton from Norway shared the groundbreaking perspectives on rock mechanics and rock engineering. Professor Debashish Deb, President of ISRM and Professor of IIT Kharagpur, addressed the innovations within rock engineering. Professor VMSR Murthy, Director IIST Shipur and Professor at IISM Dhanbad, IIT ISM Dhanbad, provided a comprehensive overview of advancements in rock excavation and fragmentation. Dr. Shripad Nayak, Director of NIRM, discussed developments in geotechnical investigation, while Professor Daniel Hubinau from University of La Huaria, Colombia, offered international viewpoints on sustainable mining. Shri Senthilnathan K, Executive Vice President of L&T Heavy Construction Industry, HCI, delivered a keynote which was given on behalf of him by Shri Prasad Selvan, highlighting the industry leadership. Dr. Binishyan Hoss, Director of Amberg, India, and Professor Shebnam Dusgun, Professor at Colorado School of Mines, contributed their expertise in tunneling and environmental engineering. Dr. YG Kale, Chief Controller at the Indian Bureau of Mines, emphasized regulatory frameworks and best practices. Overall, it was a very, very overwhelming participation. The conference demonstrated remarkable engagement with the mining, environment, and tunneling communities. The call for abstracts was floated on the 1st of August 2025, inviting global participation. A total of 140 abstracts were received, reflecting strong interest and diversity of research topics. Of these, 111 full papers were submitted, showcasing a wide range of innovative studies and practical applications. During the conference, 85 papers were presented on-site in physical manner, while an additional 5 papers were presented online, ensuring accessibility and inclusiveness. The event's vibrant academic exchange was further enhanced by the participation of all the delegates, all the authors and presenters. Their wholehearted involvement contributed significantly to the overall success of ISAMET 2026. In summary, the conference was marked by an exceptional keynote session, robust participation, and a collaborative spirit amongst all attendees. The collective efforts of the speakers, contributors, and organizers have elevated the conference's impact and have set a benchmark for future gatherings in the mining, environment, and tunneling sectors. Thank you.
Thank you, Nikhil sir, for presenting a beautifully crafted symposium report. Dear attendees, now I am going through another important task of introducing you another distinguished guest here with us. We have with us Sri I.D. Narayan, Indradev Narayan, CMD of MECL. And Sri Indradev Narayan has assumed charge of Chairman cum Managing Director of Mineral Exploration and Consultancy Limited. It's a mini Ratna company and it's a CPSE under the aegis of Ministry of Mines. And since his joining, the MECL has taken a new path, and it has become a blue-eyed boy of the Ministry of the Mines, and they are looking at MECL for all good critical minerals. And I think Sri I.D. Narayan sir would have not imagined that his company is going to in that direction when he assumed the charge. So one of the most key company now in the under the Ministry of Mines. He's as you all know, he's a graduate of our department of 1990 batch, and prior to his assignment of this CMD MECL, he was regional director of CMPDL in Bilaspur. He has attained his first class mines manager competency certificate from DGMS. He has also been awarded the best general manager award by Coal India in the 2018-19. He was also bestowed with an award of best planner for planning and design work. He has distinctly led the team of planners which planned the open cast mine with highest target annual capacity till date. The Geura expansion OCP, 70 million tons, has been planned by him. Sri I.D. Narayan was a key member in planning and design of ambitious first mile connectivity program of Ministry of Coal. He has been an active part in CIL business delegation and visited Australia in 2007. So welcome, Dr. I.D. Narayan. Please guide us and with your words.
Thank you, sir. Thank you so much. Very good evening. Dignitaries on the dais, dignitaries of the dais. Mutreja sir, Thote sir, Hemant Pandey sir, HOD Gupta sir, Murthy sir, Yerpude sir, Nikhil sahab, and Anupam Kher sahab. I feel elated standing here to address this august gathering. This symposium is coming to end, but as they say, ant hi arambh hai. All of the previous speaker has told that this is the food for thought, and mining, environment and tunneling. This is a very apt subject and very timely subject which has been discussed during the last 3 days in this symposium. And I hope during this 3 days deliberations, all of you, including me, must have gathered knowledge and will go back with better professional. So, as discussed earlier, that mining is very, very important, and particularly in this scenario when we are transiting from the conventional energy sources to the newer energy sources, in which critical minerals are very, very important, and government are taking very active steps for not only for ease of business, but also supporting all the stakeholders through making the policies, supporting through budgetary provisions. You must have read or seen in news that India has constituted National Critical Mineral Mission. This is a mission with a budget of 34,000 crores of rupees. This is very important in our journey towards Atmanirbhar Bharat and Viksit Bharat. MECL is playing its role for exploration of all kind of mineral, including coal, but focus now has shifted to these critical minerals. We are not only exploring it in the boundary of India, but we have also ventured abroad to secure the mineral security. We have taken lease in Argentina, and we are trying to explore lithium there. There is a lithium triangle in Argentina, Bolivia and Chile. So we have acquired 5 leases there, and first phase of exploration, the geophysical work has been completed. The physical drilling is going to start very soon, and we are hopeful that we will secure some lithium for our country. Similarly, we are trying our venture in Zambia, in Australia, because we have this geology is site specific, and we have short of certain minerals which have been listed as critical mineral. These critical minerals are different for every country. We have identified 30 of them. 24 minerals under Schedule D is being auctioned by central government, and MECL is providing consultancy to the central government for auction of these critical mineral blocks. 6 tranches of auction has already been completed, and 46 number of blocks have been auctioned till date. 7th tranche is going to launch very soon. And apart from these critical mineral CL and ML blocks, the government of India has recently introduced EL blocks, exploration license. Exploration second tranche has just launched 2 days before by the Honorable Minister. Those who not know about the exploration license, it is a large area being auctioned in which any company can participate, and they can bid a certain amount, and after start of mining they will get their bid percentage for next 50 years or till the mining is done in that block. So that will be a revenue source for that. This concept has come recently to India. And apart from this auction part, government is supporting through budgetary provision also. Government is giving 50% of your expenditure back to you if the block is not so potential. It is limited to 20 crores of rupees. So the stakeholders who are trying their hands in, or those who want to venture in the field of mineral exploration or want to contribute to the endeavor of the nation towards mineral security can participate in this exploration license. And there is so much clarity available in government websites. Apart from that, government have recently launched NGDR portal, which is National Geoscience Data Repository. And 2 days back they have launched another portal, Next Gen portal, through GSI, which is portal having all the data, all the geological data available till date in this country, with integrated with AI and ML. You can have all the data in public forum, you can have for your use, and I request all the stakeholders present here to please visit that, even the young students to visit the portal, have a look. It is very easy. You have simply require a email address and a password. So please come together, which is the main motto of this symposium also. As Hemant Pandey Sahab has also told that this should continue. And they say in Urdu couplet that बात करने से बात बनती है, बात करने से बात बनती है, रोज बातें किया करो हमसे. तो ये जो बातें आपने 3 दिन में की, मुझे उम्मीद है कि इन बातों से बहुत सार्थक चीज़ें निकल के आएंगी हम सबको, क्योंकि देश एक ऐसे समय से गुजर रहा है जहां आप सबकी आवश्यकता है देश को, आपके प्रोफेशनल नॉलेज की, आपके ज्ञान की. मिल के जब काम करेंगे तो काम जरूर सफल होगा. आप आज का दिन बहुत खास है. ये सिर्फ इंटरनेशनल सिंपोजियम ही नहीं ख़त्म हो रहा है. आज वो एक वीक लॉन्ग सेलिब्रेशन जो चलता है, जो हमारे टाइम में नहीं था, वैलेंटाइंस वीक का, वो भी शायद आज ख़त्म हो रहा है. तो मैं बहुत ज़्यादा समय आप सबका नहीं लूँ. आखिरी जो 4 लाइनें मैं आपको कहना चाहूँगा, जो हमारे भारत रत्न स्वर्गीय हमारे पूर्व प्रधानमंत्री श्री अटल बिहारी वाजपेयी जी की लाइनें हैं कि कदम मिलाकर चलना होगा, कदम मिलाकर चलना होगा. कठिन समय है, तो इस समय में वी हैव टू कम टुगेदर एंड वर्क फॉर द कंट्री. थैंक यू सो मच फॉर गिविंग मी द टाइम.
Thank you, sir. Your address had so much of information for all of us. It's really enlightening for all of us. And some of the entrepreneurs, budding engineers, someone wants to come up as a startup in exploration, they can take a cue from here. It's time to felicitate our guests. I request Dr. Yerpude to felicitate our guest, Professor VMSR Murthy, with a memento. I request Dr. Ajay Agrawal to felicitate Dr. Hemant Pandey with a memento. I request Conference Chair Dr. Ritesh Lokhande to felicitate Sri I.D. Narayan, CMD MECL. I request Professor M.R. Thote to please felicitate Dr. Rajesh Gupta, the President of the function. The music has already set the tone for declaration of the awards, and I call my colleague Dr. Nikhil Sardesai to declare them.
Thank you, sir. I think this is the moment that we all have been waiting for. 3 days of constant deliberations have resulted in us finalizing the list of awards. So for the first award, we have got 4 theme-based awards. There are 4 themes. There were 4 themes for the conference: mining, environment, tunneling, and cyber-physical systems. So we have got 2 awards in each of these theme categories. And we also have overall best conference paper award, and the last is the best early career researcher award. So for the first theme, that is on mining, we have 2 papers. I will read the paper's title, or I'll read the paper's title and the awardee as well. So the first award for the best theme paper in mining goes to influence of direction of initiation sequence along and across the birth of dominant frequency of vibration induced because of underwater rock blasting. This award is given to Mr. Suman Modi from IIT ISM Dhanbad. I request Professor Murthy and Professor Yerpude sir and Professor Mutriya sir to kindly hand out this award to the awardee, Suman Modi. You had a train? Okay. So he has left. So the co-author is Murthy sir itself. The second best mining paper award goes to shaft inset construction in challenging ground conditions of Gumgaon mine. The author is Chandrani Prasad Verma from Simfer Nagpur. Chandrani ma'am, is she here? No, she's not here. Okay. So the award will be given to Dr. Manoj Bagade. I request I.D. Narayan sir and Hemant Pandey sir to kindly give the award. The next category is tunneling and excavation. So the first award goes out to comprehensive analysis of tunneling in jointed rock mass conditions of Himalaya, a comparative assessment. It is awarded to Mr. Karthik Siddhamal from NIT Surathkal. I request Murthy sir to kindly give out the award. Yerpude sir, please. The next paper in tunneling is Optimized Ground Improvement Scheme for TBM Breakthrough in Deep Clay under Backfill Pond Conditions, a case study. The awardee is Saumya V.S. I request Yerpude sir and Murthy sir again to kindly give out the award. The next category is environment. So the first award goes to impact of mine water discharge on groundwater level and plan for its long-term utilization, a case study. The authors are Varsha Mane, Yashwant Katpatal sir, Chandrakant Bhoyer and Abhijit Dharashivkar from VNIT. Nachiket, can you just take the award for? So Nachiket will be carrying the award for Katpatal sir. I request again the HOD sir, Rajesh Gupta sir and ID Narayan sir to kindly present the award. The next paper in environment is Carbon Footprint Reduction Strategies in Mine Closure Planning, a comprehensive study under MPG 25 guidelines. The awardees are Manoj Kumar and Shankar Nagachari from CMPDI. Manoj Kumar and Shankar Nagachari. Is there anyone from CMPDI over here? Okay, we'll go to the next category. It is cyber physical systems. So the first award goes to cost sensitive machine learning for seismic hazard prediction in deep underground coal mines, and the author is Anshul Agarwal from VNIT. I request I request Hemant Pandey sir and ID Narayan sir to kindly give out the award. Sir. The next paper is Machine Learning Approach for Precise Estimation of Blasting PPV in Tunnel Construction, authored by Pushpendra Patel, Harsh Kumar Verma, Manoj Kumar Mishra, Ashish Kumar Vishwakarma and Himabandhu Alakka from CSIR Simfer. Pushpendra Patel, okay. So Dr. Manoj Bagde will be collecting the award for them. Professor Yerpude sir and Murthy sir, I request you to kindly give out the award. So for the best theme paper award, the criteria were the scoring given by the session chair, the session co-chair and by the VNIT faculty member who was present in the crowd. For the conference best paper award, the scores were considered along with the similarity report which was calculated by Turnitin software and by the reviewers' comments. Based on all these criteria, we have found the best conference paper award, and it is the integrated microseismic monitoring and dynamical numerical modeling approach for post-mining seismic hazard and surface vulnerability assessment. And the awardees are Ms. Praveena Das Jennifer and Shripad R. Nayak from NIRM. A very big congratulations to them. I request the crowd to kindly welcome them with a huge round of applause. I request all the dignitaries on the dais to kindly felicitate them with the award. Thank you. Thank you, sir. Thank you, ma'am. Now I request the conference chairs to kindly join us on the stage. Dr. Agarwal and Dr. Lokhande, sir, please join us on the stage for the last category. It is the Best Early Career Researcher Award. And the criteria for this was all the other criterias along with the additional criteria that the awardee should be less than 35 years of age and the awardee should also be a working professional or an academician and should have registered to the conference. So we have found the awardee. It is so many criteria. So the best early career researcher award goes out to Miss Pathapati Supriya from L&T Constructions. I request all the dignitaries on the dais along with the conference chair to kindly come onto the stage to kindly award Miss Supriya from L&T. Thank you so much, sirs. Thank you so much, Supriya.
Thank you, Nikhil sir. It's all, we're witnessing so many happy moments here. Coming down to the next phase of this validity function, I request our head of the department, Professor Rajesh Gupta, president of the function, to address the gathering.
Respected chief guest, distinguished keynote speakers, esteemed delegates, faculty members, researchers, industry partners, and dear students. As we arrive at the closing moment of ISAMET-26, I stand before you with immense pride and gratitude. Over the past 3 days, this symposium has not merely been an academic gathering, it has been a vibrant confluence of ideas, innovations, experience and vision. We have journeyed across the complete spectrum of our discipline, from underground mining practices to strata control of advancements in surface mining and slope stability, from emerging concept in cyber-enabled mining system and intelligent monitoring to the growing integration of automation and digital technology. From crucial deliberations on sustainability, environmental protection, and circular economy principles, to transformative discussion on tunneling and excavation engineering in challenging terrains. Every dimension of mining and geoengineering has been thoughtfully explored. The technical sessions reflected the depth of ongoing research in rock mechanics, numerical modeling, predictive analysis, mineral policy, infrastructure development, TBM technology, and sustainable resource utilization. The interdisciplinary nature of the discussion, blending engineering, environment, policy, and technology, clearly indicates the direction in which our profession is evolving. I extend my heartfelt gratitude to all our distinguished keynote speakers. I would especially like to acknowledge and thank our esteemed keynote speakers, Professor Nick Barton, Professor Debasis Dev, Professor V.M.R. Murthy, Dr. Sripad Nayak, Professor Daniel, Professor Juliano, Professor Sanjay K. Sharma, Shri Senthilnathan. On behalf of him, the lecture was given by G.D. Raju, Dr. Vinician Haas, Professor S. Sabnam, Dr. Y.G. Kale. Invited experts whom insight enriched the symposium immensely. This deliberation on advanced rock engineering, emerging surface mining technology, port and underwater excavation engineering, 3D numerical modeling, environmental stewardship, artificial intelligence in mining, mining policy frameworks, and infrastructural transformation have set a clear roadmap for the future. I also sincerely appreciate every author, delegate, session chair, organizing committee members, sponsor and volunteers, Your contribution, whether through the research publication, discussion, coordination or participation, have made ISAMET 2026 a grand success. As the head of a department, I feel proud that our department could provide this platform where academia and industry met in a meaningful dialogue. Such interaction strengthen our commitment to responsible mining, technology innovation, environmental consciousness, and national building. May ISAMET 2000 not conclude as an event, but continue as a collective movement towards safer, smarter, sustainable, and cyber-integrated mining and tunneling practices. I sincerely thanks to each one of you, and in fact, I know that this conference was the brainchild of Dr. Yerpude, and he was the advisor, and with his motivation and other things that everyone has heard, so I would like that all of you give a big hand to Professor Yerpude. Thank you.
Thank you, sir. Thank you for your all guidance. Dear participants, ladies and gentlemen, before the formal vote of thanks, I would like to hear few words from you as well. We have different sectors coming together, tunneling, mining, environment. So welcome your feedback, quick feedback from 3-4 people. Someone can, I think, initiate from Simfer. We can start with your feedback. Anyone wants to come forward, share your feedback, please. Can give, there's a mic. Either.
Good evening to all of you. I'm Jay Aglave, and it was a wonderful event to see here ISAMET. We've seen the conferences all around the world. I've been to the places, and I think Nagpur is rising now. The success of this conference, as you see, there are people all sitting here at the end of 2 days, and we had all these varied subjects: mining, environment, tunneling, and very relevant topics, you know. So I think I congratulate the organizers. All the facilities were excellent, and we look forward such type of conferences we would conduct at least once in 2 years or 4 years if possible. Thank you very much.
Any more feedbacks, please? You can suggest us any areas of improvement. Dr. Danny, you would like to speak few words? Mic, please. Microphone, please.
Okay, thank you very much for this opportunity to be here. This symposium was amazing. I think the level of the participants, the presentations. I think here in India, the most important wealth that you have is the people. Very kind people and very smart people, very intelligent. Then all the presentations, most of them was in high level, environment, mining, tunneling, and I am so happy to be here these days. A long trip, 3 days, Barranquilla, Miami, Doha, and I am a little tired, but I am so happy to be here because I learned a lot with you. Your knowledge is amazing. And I am completely sure that India in next time will be more and more important in the planet because you have a lot of potential, even geological potential in mining, and I think mining is an important topic for you to transform this country in one of the most important countries in the planet, you know, that now is the fourth economy, but in the future I think that you will be even the first one because you have this potential, especially in people. You have very good people and also very smart, and the scientific level and academic level that I saw here these days was completely amazing, and I am would surprised with your level and all the presentations about all the topics. I has visited several countries every year. Next week I will be in the US in another international conference, and this level is so high. And also I congratulate the organizer of this symposium because the format is perfect. The organization was very good, and I am so surprised because even I have my conference in September, and I am completely sure that some of you will be in Colombia. This is the idea. I am going to apply, the same format because it's so amazing, the organization, and I am so happy to be here. And this is the point, this international collaboration between Colombia and India, because we have similar scenarios. Coal for you is very important. For us, coal is the most important mining in my country. Then it was amazing for me to learn about the current situation in India, and I am so happy to be here, and I learn a lot about your scenario. Your panorama is amazing, and I am completely happy to be here in this time and to share with you. Thank you very much.
Thank you, sir. Thank you. Anyone last feedback from sponsors? Any sponsor wants to speak quickly?
Sir, thank you very much. On behalf of the RockTech, I'm an ex-DJMS person, but now recently joined RockTech, and Mr. Manoj is here. So we contributed very little, but after a couple of years, I have been here standing in the Symposium, and that was very my dear place, my alumni place. I'm alumni of NIT, so and this has always been a very heartfelt feelings when I come to department and met all you all here. Apart from meeting my very senior alumni, my respected VMR sir, Murthy sir, my senior Dr. Hemant Pandey, ID Narayan, my batchmate, yes, of course Mutrija sir, and you all faculty members. Recently I have a very good close association with Bagade sir also. Apart from technical inputs here, the event was nicely and very carefully planned. Very good cooperation amongst the all wings of these places. The surprisingly the youngsters, that's what I carry the feeling from especially from L&T. All the budding engineers are there. They are into the numerical modeling more, and then some of them have presented, they validated their their models, numerical models into the practical validation. Some of them they have missed, but it's a really good beginning where tunneling people are also there, sandwiching into the mining, and there can be a precipitation of mining knowledge into the tunneling. So there is a lot of scope of mining into the non-mining areas. That's what I feel. And yesterday we were discussing with Murthy sir. So there is a lot of infrastructural projects are coming, and a lot of scope of mining engineers into the non-mining areas. So I take this opportunity to thank on behalf of the RockTech. That's what you asked me, any sponsor. So we contributed a very, very little, but thank you very much, sir. You have always supported me personally, Anupam Kher sir, and I look forward this kind of grand event in a very short span of time. Thank you.
Thank you, sir. Thank you. Now I again request my colleague, Dr. Nikhil Sardesai, to propose a formal vote of thanks.
Thank you, sir. Respected dignitaries on the dais, distinguished guest, Shri ID Narayan, CMD MECL, special guests, Professor VMSR Murthy sir and Dr. Hemant Pandey sir, CMD designate WCL. President of the function, Professor Rajesh Gupta sir, Head Department of Mining Engineering, VNIT. Professor R.R. Yerpude, Advisor, ISAMET-26. Dr. Anupam Kher, the Coordinator of the Program and Organizing Secretary. Conference Chairs, Dr. Ajay Agrawal sir and Dr. Lokhande sir. Distinguished professors, scientists, experts and industry professionals. My dear faculty colleagues, students, staff members of the department, ladies and gentlemen. I would like to begin by expressing my absolute privilege to be amongst the highly decorated alumni of VNIT Nagpur. Gita teaches us, yad yad acharati te shreshthas. It means people in general follow the actions performed by great personalities. The entire world pursues the standards set by their exemplary acts. May your experience be the path for us to follow. Now, I would request the audience to congratulate Dr. Pandey sir with a huge round of applause for having been designated as CMD or WCL. Indeed, it is a proud moment for all of us here and especially at VNIT. It is my proud privilege on behalf of Department of Mining Engineering to propose the formal vote of thanks for the validatory function of ISAMET-26. First and foremost, I express my deepest gratitude to our distinguished guest, Shri I.D. Narayan ji, for having shared his valuable thoughts and vision. Sir, your leadership in the field of mineral exploration and mining continues to inspire engineers, researchers, and policymakers across the country, and we are truly honored by your thoughts and guidance. I would like to express my most sincere appreciation to our special guests, Professor Murthy sir, Director IIST Shibpur, Dr. Hemant Pandey sir, CMD designate WCL, for sharing their insights and enriching this validatory function with their presence and guidance. Your perspectives from academia and industry provide invaluable direction to the young engineers and researchers. We, the organizing team of ISAMET-26, are deeply grateful to all our keynote speakers to have taken out their time from their very busy schedules to enlighten the delegates by their experience and presence. A special mention to Professor Nick Barton, Professor Dusgun, Professor Hubinau, to have traveled across the globe. My heartfelt gratitude to Professor Murthy sir, Professor Deb sir, Dr. Nayak, Shri K. Senthilnathan, Dr. Hoss and Dr. Kale for sharing their knowledge and inspiring all of us. I extend my sincere thanks to our Chairman, Board of Governors, Shri Madhabhushi Madana Gopal, for his constant encouragement and guidance to the Institute and for presiding the inaugural function on the first day. We are grateful for his continued support in strengthening the technical education and research at VNIT. I place on record our heartfelt gratitude to our director, Professor Premlal Patel, whose encouragement, leadership and vision made the organization of this conference possible. The administration's support to the Department of Mining Engineering has been instrumental in bringing this international forum to fruition. My sincere thanks are due to Professor Rajesh Gupta, Head of the Department Mining Engineering, for his leadership and tireless efforts in guiding the department and supporting the organization of this symposium. I express heartfelt appreciation to Dr. Ajay Kumar Agarwal sir and Dr. R.D. Lokhande sir, Conference Chair, for their dedication, meticulous planning and sustained efforts in bringing together experts from across the globe for ISAMET-26. I also thank Dr. Anupam Kher, Program Coordinator and Organizing Secretary, for efficiently conducting the validatory program. We gratefully acknowledge the generous support of our sponsors and industry partners whose cooperation has made this symposium possible. We are overwhelmed by the industry support in sponsorship. We are grateful to our platinum sponsors, SECL and L&T Construction. Our association with L&T extends beyond the conference, where we are in collaboration for training the tunnel engineers of L&T. A special thanks to Shri K. Senthilnathan, Shri Prasad Selvam and Ms. Nandita Chakraborty for attending the conference with their entire team of tunnel engineers and designers. We are grateful to our diamond sponsors, Solar Group of Industries, gold sponsors, WCL, Moil Limited, Hindustan Copper Limited, SMS Limited, Dalmia Bharat. ISAMET-26 is also supported by Adani Natural Resources, Rocktech Engineering Private Limited, Mahanadi Coalfields Limited, ARK Info Solutions Private Limited. Their continued support, collaboration strengthens the vital partnership between the academia and industry, which is essential for advancing safe, sustainable, and technologically advanced mining and tunneling practices. My sincere thanks to our partner organizations, IBM, Indian Bureau of Mines, and ISRM India for the association and support to this conference. I would also like to thank all session chairs, all co-chairs, authors, delegates, and participants who have traveled from different parts of the country and abroad to be part of this symposium. Your presence and contributions are the true strength of this event. Special thanks to publishing partners, Springer India, especially Ms. Neha Sharma, Ms. Swati Mehershi, and Dr. Deepak Suryavanshi, who will be handling the publication of this Scopus indexed conference proceedings. I would like to categorically mention the efforts taken by some of the luminaries of VNIT who have been quietly working behind the scenes for making this conference successful. First and foremost, I would like to honor Professor Mutreja sir. It is only by his constant support, efforts, and connections with the alumni who are now industry and academia leaders are we able to see this conference and this gathering coming together. We are also extremely thankful to Professor Inara Thote for his support and guidance. There are no words in any dictionary across the world to express the gratitude towards my colleagues, starting with Dr. Sandeep Panchal, Dr. Anupam Kher, Dr. Sumant Mohanto, and Dr. Nachiket Bhagade. I am extremely overwhelmed by the assistance provided by our PhD scholars, Mr. Pratik Khadse, Mr. Harshal, Mr. Nikhil Tijare, postgraduate students, Mr. Sai Prakash, Ms. Snehlata, and Ms. Alisha, undergraduate students, Ms. Tanu, Ms. Hansini, Ms. Shreya, Ms. Astha, Ms. Shriya, Ms. Kanak, Smriti, Harsh, Mridul, Shubham, Daksh, Purab, and Omkar, who have been tirelessly working for the past entire week. I have never seen them on time in the classroom, but they were on time for doing the job in the conference. So please give them a very big round of applause. Special thanks to our administrative staff of VNIT, of the department and the entire VNIT Nagpur, who have worked tirelessly for many, many days behind the scenes for success of this program. I hope that the deliberations and technical sessions during the past 3 days would have led to new collaborations and new solutions for mining, environment, and tunneling sectors. With these words, I conclude my vote of thanks. Thank you very much.
Thank you, sir, and also thanking the Hotel Radisson Blue for this wonderful venue and arrangements. I request all of you to rise for the national anthem. Mata ki jai. Thank you one and all. I declare the end of the symposium. Please join for the high tea. Thank you. Thank you.